Hello everyone and welcome to today's session on Azure Terraform full course. Terraform has emerged as a key component in the DevOps world. It enables you to replace the manual parts of your infrastructure management with a solid and automated foundation upon which you can build all your DevOps practices including automated testing, continuous integration, continuous delivery, and orchestrating the workloads using tools such as Docker, Chef, Puppet, and Ansible. In this session, you will learn all about Azure Terraform. So let's check the agenda for the session.
We are going to talk about introduction to Terraform. Now, if you check it out quickly, what is this infrastructure as a code? So, infrastructure as a code is the management of infrastructure, nothing but networks, virtual machines, load balancers, connection topology. That's the reason we've just discussed about what is network, what is a virtual machine, and all. Okay, and using the same versioning as DevOps team uses for source code. That is nothing but an infrastructure as a code, and that we are going to use it. So how it is going to be used? See this, what is the difference between? So anybody can tell me, friends, what is a configuration management tools? So IAC, nothing but infrastructure as a code, and a configuration management as a code. So what is a configuration and what is a infrastructure as a code? If you take a configuration means configuration management. So configuration management is nothing but if I have 100 servers, I need to install something, I can use this configuration. If I give 100 virtual machines, okay, 100 virtual machines I'm going to give it. If I give 100 virtual machines, if I want to install package, I want to configure some files, I want to start some services, for example, I can do that quickly with a configuration management tools with idempotent. For example, you are an administrator. Maybe you are a Windows administrator or a Linux administrator. As a team requirement, we have to bring it up 1,000 servers, and we have 1,000 servers, for example. And those servers, I need to configure it. I need a configuration, meaning I need to install some Tomcat servers or Jetty servers, or it may be IAS servers, or it may be Oracle, or it may be anything, whatever you require on top of it. I have to configure it quickly. And also, I need to update my security patches, for example, because every month, I'm going to get some patches. I need to apply those patches, for example. So, how can you do this? If I have 1,000 servers, or it may be more than that, also, for example. In that scenario, we are going to use a configuration management tool. Example, Puppet and Chef and say Ansible. And another one is Salt Stack. Get a chance, you can also read about this. But these are like a configuration management tools. So just you have to write a code and you have to pull it and execute it. Automatically in the 1,000 servers going to be configured without touching that servers manually. But now the requirement is little before configuration management tool, I need to create 1,000 servers, for example. So if I ask you to create 1,000 VMs in a Azure, so you cannot go into the virtual, say Azure portal, and you cannot create it one, right, virtual machines. I want to use a code. If I execute it, should create it. If I destroy it, should delete it, so that it will be easy to maintain. So for that case, we're going to use a infrastructure as a code concept. So creating the resources here, configuring the services, configuring the softwares, but here creating the resources. So as part of the creating the resources means I can go into any cloud. You take it Azure Cloud, AWS Cloud, or DigitalOcean, or it may be Google Cloud, or maybe my own data center. I want to create a resources straight away. In that scenario, how can I take it up? So then in this scenario, if you take an Azure as an example, we are going to use ARM templates. Azure Resource Manager templates. This is on-premise templates. Only works for Azure. Another one, if you take that, Terraform. Now, if you take it ARM and template on your Terraform, you take it anything, but the configuration, the ultimate goal is same. But Terraform is an open source and it can support for multiple clouds. So that's the reason It's widely used infrastructure as a source concept, code concept. Okay, so that's the one thing. So cloud formation templates and Terraform, ARM templates, all these are, we can use it vigorously. Now, if you take it in the main differences, little in a documented way, you can see here. See this? Can create and destroy hardware architectures. But see this here? Works only with softwares. Can install software while bootstrapping the servers, but you have to do manually. But this is cannot work on hardware level, but can install any software. If you take a configuration management tool, and if you take it in this part, should not be used as a replacement of configuration management tools, cannot be used as a replacement of infrastructure as a code, but both each other can complement each other. Nothing but if I'm using infrastructure as a code, if I want to quickly to configure something, if I use as a infrastructure as a service, I can able to call this configuration management tools. Example, I'm using Terraform, I need to install something software while booting itself, then I can call it up this configuration management tool like an Ansible. Ansible is, very, say, compatible to use it straight away from the Terraform itself. Okay, so then how it is going to be takes place infrastructure as a code, we'll talk about. Okay, before that, if you take it in a configuration management tools should look like this, taken a diagrammatical way. Okay, so we are going to take this machine. So this is your local machine, and from there you're going to connect all the virtual machines. This is the way it's going to be taken. And I'm going to communicate it with the SSH to this and say this and say this and cool. And this is, you can take it up, this is an Ansible host, nothing but your local machine or maybe a virtual machine. Okay, and these are like a VM1, VM2, like that n number of machines going to be there. Use those things. And it's going to be indicated with the SSH with port number 22. So this is the way it's going to be takes place. But if you take it up, if you take a infrastructure as a code concept, this is the way it's going to be takes place. If you take a diagrammatical way, just go here, take it up. This is like a your local machine or a VM, anything. Here, what is going to be there? I'm going to install AZ as well as Terraform utility commands. And then I'm not going to use these all options. Like this is going to take place. I'm going to connect what? Azure Cloud with authentication, right? I'm going to connect to this Azure, and whatever you're going to execute it here, Terraform files, it's going to be created, right? It's going to create whatever you want to create. You can create a resources. Actually, within the cloud only, I can say these like VMs can be created, and say we can create AKS clusters. We can create it anything, any service. By using any service, we can create a resources. VNets I can create it, databases I can create it, everything I can able to create it by using this part according to your script. So you're going to code here. Here I'm going to write a Terraform templates. So now we have to focus on this. We have to set it up. Of course, we have already AZ command, and even that is an optional. We can directly give the service principal, and you can give the account details, and you can also correct it right from Terraform. And then it's going to connect to the cloud. And if you are given the correct resources, automatically going to create a VM site, AKS clusters, VNets, and all. I can able to get it. Infrastructure as a code concept. See this, a Terraform is an open source infrastructure as a code software tool created by HashiCorp, okay, implemented by that, and it enables users to define and provision a data center infrastructure using high-level configuration language known as HashiCorp configuration language, or optionally we can call it as JSON. So it's nothing but what? Behind it's used Go language, okay, to use these resources. Nothing but what? Everything as a DSL. They already implemented some resources, nothing but methods. Those DSL methods we are going to use it, nothing but. That is I call a Terraform resources. Everything will get it ready-made. We just need to take it up what you want and you have to configure it. But how to configure and all, we'll see that as well. This is for AWS purpose it is showing, okay? But see this, install Terraform on local or an EC2 machine, create a user and use this user to authenticate Terraform to AWS, initialize Terraform directory, something like that. In that case, I'm going to set it up from our local machines. For that case, there are multiple things going to be there. I'll talk about this. What is this? You need to plan, apply, destroy. And there are so many commands going to be takes place. So for that case, I can set it up from my local machine itself. For example, what I need. So what are the prerequisites required if I want to do that? I need AZ, of course we have, and a Terraform utility. Simple. You should download the Terraform utility and you have to install it according to your operating system. So if you create a virtual machine from here and we can create it over there itself, okay, or else you can simply go in a local machine and you can also install it. See, for example, Terraform install on Mac, for example. See this, Ashika, we can get it straight away. So if you click on it, you can get to know what other things are required. Either of the one. See this, install Terraform, and you can see it's provided option also how to do this and all. See, steps also going to be provided. So manual installation, so homebrew on OS X, chocolately on Windows, Linux. See, straight away you can get it. Downloading these commands, copy, add JPG key, Ashika release package, and then just install the Terraform utility command. And once it is done, you can able to find it. See this, verify the installation. See, very well documented. Now if you go into this here, see this, it is showing that AWS, right? I can go instead of AWS, see multiple providers will be there. See, AWS, Azure, GCP, OCI, Terraform Cloud, multiple things. Out of that, see this, I can use provider type is equal to Azure, and you can click on it and install a Terraform. You can get it here and see same. I mean, Terraform command installation is same, but it's going to be get it here itself. Say for example, if I do that in a Mac, see this, brew tap hashcop, brew install Terraform, and say upgrade Terraform. We can do this. If I do that in my local, for example, it's a Mac machine, so I can copy this. I'll go here, or else I'll show it up one more thing in virtual machine also. I can create it one virtual machine. We can also do that. So, so tapped one car and 9 formulas is updated. And then take it up this, copy, and you can go here, install it. Now what it is saying that see this here, it's already installed Terraform. So to upgrade to 1.00, run brew upgrade Ashika tapped in. Now it's okay. Now we can take it up any version. It's okay. We can check it out accordingly. Your provider and version. That's nice. So once it is done, this command, right? Brew install Ashika install. You can upgrade, of course, and you can see the Terraform help commands. You'll get all options. See this here, Terraform. You got it or not? You can get to know. Yes, we got it. You can take help. We'll get it, all these options. So this here, the available commands for execution are listed below. The most common useful commands are shown first, followed by less common or more advanced commands. You can able to find it here. So out of that, there are multiple commands are there. Out of that, we are going to use initialize a Terraform working directory, and we are going to use a generate and show a execution plan. I mean, each and everything we can get some significant important going to be there. Now let's see how we can able to use it. What are the other things going to be takes place, right? If you see that here, there are multiple commands are there. See, init command, plan command, apply command, destroy commands are there. Okay, init is nothing but required plugins, required prerequisites going to be set it by the init command. So it's a little dynamic. According to your code, it's going to download the plugins. After that, it's going to give a plan. What kind of infrastructure you want to create it. It's going to give a plan. Nothing but I need a VM1, VM2, that kind of name. I mean, these many VMs going to be created. It's going to show it up before execution itself. That's a plan. So with that plan only, I can apply it to this. It's going to be a Terraform apply. If I say that Terraform apply, automatically going to be create a cloud. And then we are going to destroy it. If you want to destroy everything, then we can do that. Now, if I see this here, the what is code basics and all, we'll talk about now. How it is going to be takes place and what are the things are required, we'll see that. First of all, what is required. Okay, so one thing we have to get it first step is we need to get a provider. So there are some points we have to understand. One is provider. Okay, one is a provider. Another one is a resource. We are going to use it. Another one we are going to use a variables. Another one we are going to use a output. And going forward, there are multiple things are there. Backend also going to be used where you want to store it and all. Cool. Now let's take it up. Provider. If you take in a provider, see this here, you can straight away we can get it here itself. See, build an infrastructure. Out of that, how we are going to do that prerequisites? We have just installed, right? AZ login command, say authenticating using the Azure CLI. Then once you getting that, okay, and then is going to create a new file called main.tf file. For that case, we are going to use a provider. See, straight away it's provided. Even you can also get it here also. We can straight away we can get the code itself here itself. See, tutorials. If I go and I can get it everything the code. See, Azure, Oracle, Terraform Cloud, Google Cloud, AWS, all different clouds. Out of that, see this Azure. Out of that Azure, you can see that introduction to infrastructure as a code with the Terraform, install Terraform, build infrastructure, change infrastructure, destroy infrastructure. All these are we can use it. After that, if you see here, a build an infrastructure. Same thing, we are going to use it here. And once it is done, we are going to use this code. Very simple. So out of that, we are going to, because Terraform is an open source and we are going to execute it from outside. For that case, I need to tell about Azure account, right? I need to provide a, because I need to authenticate as per the document. If you check it out here, what we are doing that I need to connect to the Azure cloud. So to connect to this Azure cloud, we need a provider. So as part of that provider, I'm going to tell about Azure RM. If it is a AWS, I'm going to use a AWS. If it is a Google Cloud, I'm going to use a Google Cloud provider. Each and every provider is going to provide here. See this, we can see that multiple options. Azure. If I use it AWS, for example, right? If you click on it Azure, and then say that build infrastructure. If you go here, see what is going to be used? AWS. Provider is equal to AWS. If I say, for example, Google Cloud, if I want to use it, GCP, then see this. Same stuff, no much difference. You can come down and see this here. Provider is equal to Google. And then we are going to tell about what is a project, what is a region, what is a zone, what is a credentials, so that it can able to connect it. If I say, for example, Azure, and if I say that build infrastructure, see here. And if I go into this location, see I'm logged into that and you are going to give it straight away Azure provider. And this provider going to call Terraform required providers, Azure RM, source is equal to Azure RM, nothing but Ashika, and version equal to 2.26 is going to be used. And then required version is going to be a greater than or equal to 0.11 14.9. So if you have this one, so that configure the Azure provider. So this one we called as a provider. But if you take in a 0.11 version, only provider is not sufficient. Yes, if you go here in my local, I have one thing called Terraform. And if you see this here, cat main.tf file, what is that? Can you see that? It's an AWS one will be there. But I want to be used called Terraform Azure. Okay? Out of that, you can able to find. Under that, if you go one thing called, yeah, if I go into that resource group, okay, I just want to check it out. See this main.tf file going to be write it. See provider is equal to, under this, if you after that, it's going to create a resource group.tf file. So what is going to be used? It's going to be straight away, it's going to be create a resource. Same thing, right? Whatever we have seen that here, see Azure provider and resource group. but with version also we are including which version you want to use it. Cool. So where we are going to create it, just create a main.tf file. You can create it here. You can go and say make directory, say demo Terraform with Azure, for example. Then if I go into this and create it, just touch main.tf file. So this one I can get it straight away from, I can create one new work window. Okay, I can get it that. Open a folder and say from local, and I just create a demo. You can get it. See this here. Yes. This one. And I can start coding here itself. See main.tf file. See extension, we got it. So this is an extension, Terraform. So you can able to use Visual Studio. You can try to install this Visual Studio. It's very straight away. You can go into the download here. See this Visual Studio Code download. Just see this one. You can get it whatever version you require. I mean operating system. Accordingly, you can download it and get it. You'll get this kind of Visual Studio. And here, see this, there is an extension is going to be there. So as part of the extension, if you say the Terraform, because it's going to check it out. See this, the Terraform, see it's already installed. So that's the reason the code it is showing automatically. .tf file extension, if you use it, it's going to be a Terraform symbol come. And in the same time, if you see in the downside here, if I open this main.tf file, automatically it's going to come Terraform. You can choose it here, different options according to your language. Then here what I'm going to do that, I'm going to write a provider. See this, it's going to give a provider, required providers. So provider, and then you're going to declare it. The same thing, you can just copy it and do that. This provider going to take this. See here, Azure it's very easy, just you have to understand, that's all. And then if it is okay everything, then we can straight away we can test it. For example, I'm just done simple one. I'm just added provider. Is this going to work or not? I want to test it. So if I go here, right, in the terminal location, same location. Okay, and if I say that Terraform init, if I say that Terraform init, it's going to see that initializing the provider plugins, Hashcap, Azure RM, installing Hashcap Azure RM v2.62 default one. See, it's successful. And it's going to create .in Terraform file, just like it's a provider. See this here. If you go into this Terraform, you can find it some plugins. All the required plugins going to be download and go to see selections, registry, Terraform.io, all this. Now we'll go our part. Here we have a main.tf file. It's just a provider. It cannot create anything. Yes, it's going to be get a provider. It's just assume that it's going to connect a Azure. But we have not written anything, only just we have added that part. But if you see here in the code, right, if you just come down this part, see this here, resource. It's just a declaration. See, you take it Ansible, you take it up Jenkins going forward in your project point of view. You can use Terraform, you take your cloud formation, you take ARM templates. Everything is a declarative approach. Meaning, for example, assume that I have written already some methods like an add method and subtract method, okay, and say subtract and the multiplication method, division method, whatever methods are there, for example. So for that case, what you have to do that, we are going to use those methods, nothing but we are importing those methods, nothing but we are calling those methods with our parameters. For example, I want a calculation, sum of the two numbers I want to take it up. I need not to write a code and all blah blah things. We are just add 10 comma 20. If I do that, I can get an output. If I give a, for example, subtraction, I can give it 20, 30 minus 20. If I give it two parameters, I can get output. Nothing but what? We are just declaring. The same situation here also, right? If you see here, we are just declaring. What declaration? What you want to do that? We are going to use Azure RM resource group. Yesterday, we have created AZ resource group, create resource group name, and region we have given, automatically created the region, I mean the resource group in our Azure console here in the resource group section. Now I am doing same thing with what? Code. And this code I can keep it in a GitHub. Now see here, observe this, where we are doing that. RG, nothing but just you can give any name here, but this is the main important resource. Resource type, and the name. I mean, you're going to give a name. This is for name for the resource, and this is the actual resource name you want to create it, and then location is equal to West US2. Now just take it up, same thing. I can take same code, resource. Now see. So each and every item, whatever you want to create it, we can get it. So now I'll go here, right? So I just need to copy this content. Simple. Resource, Azure RM, resource group, RG. You can give any name. You can give East. Which region we have used? East or 1. Simple. Right? This is the resource we are going to use it. Just save this part. So the syntax is resource type, you have to use it. Just give some name for that, name and location. These are like a parameters. Like that you can create n number of resources and then just save this. And you can come down and you can just apply it. See this. Now say Terraform. I can do once again init. Let me see that one. Everything is in place. Now next step is what? I should say that plan, because there are multiple commands are there. Out of that, should use the plan command. See, generate and show an execution plan. This is an execution plan. How can you do that in execution plan? Can you see this here? Terraform plan. See, refreshing Terraform state in memory prior to plan. The refresh state will be used to calculate this plan, but will not be persisted in local or remote state storage. Cool. But what it is saying that East US 1 was not found in the list of supported Azure locations. Only East US is there. East US 1 is there in a AWS. That's the reason it is thrown an error. Now see that, right? If you're giving something wrong, see, it's giving an error. See, East US 1 was not found in the list of supported Azure locations. See, it's very clear. So West US 2, East US, Central US, all these are different types of regions. Where it is showing the line number 4, it's giving the problem. Now if I go once again main.tf file and simply remove that East instead of just 1, will get it into that part. Cool. Now you can once again apply it. Now just observe this. So what is happening? Right? The refresh state will be used to calculate this plan, but will not be persisted to local or remote state storage. Now, see this here. An execution plan has been generated and is shown below. Resource actions are indicated with the following symbols: create, plus symbols, nothing but. See, Terraform will perform the following actions. Just treat like it's a dry run, friends. It's just like a dry run. It will check it's going to create or not. And if it is create, what kind of resources going to create, it's going to show it up here. And see this here, Azure RM resource group .rg will be created with the name mydemotf in East US location, and this ID will create after apply. So what is there in that? Plan 1 to add, 0 to change, 0 to destroy. So you didn't specify an out parameter to save this plan. So Terraform can't generate that exactly these actions will be performed if Terraform apply is subsequently run. See here it is what is saying that you didn't specify an out parameter to save this plan, because I'm not saved anywhere this plan, just executed. So what is saying that, so Terraform can't guarantee that exactly these actions only can be applied, because for example I said Terraform plan, it's executed, I understood that this is going to be there. In between if I modify, for example, right, in between if I modify something, name or something, automatically it will be changed, right? That state going to be changed, that it may create different resource. So that is the purpose. So for that case, what we can do that, if you want to get guarantee this plan only I want to execute it, for example, okay, what I want to, whatever I'm planning, I'm seeing that in this list, same thing only I want to execute it. So for that case, I can give it like this. You can take help options, friends, always recommended. If I say this help, you can see multiple options going to be there. After that, -out will be there, right? You can somewhere find it. Destroy plan. Cool. It's not properly showing. Destroy is there. Detailed exclusion is there. Terraform plan. For Terraform, this execution plan can be reviewed prior to running the apply to get a sense of this. So for that case, what we can do, simply say hyphen out, say simply tf plan. Some name you can give it. Okay, if you see that in the tf plan, see, it's going to create it. Same thing will going to be executed, but it will be store that state, that plan. Cool. See this here. Good. Now see this here. Same thing, but the plan was saved to tf plan. Good. To perform exactly these actions, run the following command to apply. See, straight away I can apply it. Even you did something modification in the tf file, nothing but main.tf file, no problem. This tf plan can be executed. Okay, if I want to deploy, delete it straight away, you can simply say destroy. Automatically it's going to destroy. It's going to back up the tf state file and it will recreate the another. It's going to be happen. See here, it's destroyed, and I'm saying that yes. See how simple it is. You've just taken only one resource, but if you're going forward, you can keep n number of resources. Now let's take it up further. So I wanted to take it in one more example about the backend. So what is a backend? Meaning is, I want to state files, whatever we are managing, I want to use it, right? So if you take it in that example, select a state files passport, if you take it up, right? So we have just done that. If I say Terraform apply, you can take that command, you can get it from here. So if you come down, there is a state options will. I'll share this GitHub link. You can able to find it. But after that, can you see here what we are doing? State file. So what is the purpose of using the state file? Nothing but here tf state file. Yes. So tf state is nothing but desired state going to be maintained in the tf state. Like whatever you have created, the resources, it's going to be logged here. Okay. So for that case, what we are going to use it? If I say, for example, tf state, just see one example command, you can get to know what command we are going to use it. See, if I say that tf plan we have done, of course, this is, we know that up to this level, and apply, we can do this, right? And we can destroy, we have done that part. Now say, if I say that Terraform apply take help, just we are going to use this parameter. I'm going to pass the parameter Terraform apply. See this here, Terraform apply, say terraform.tf state file. If I give it Terraform and not a valid zip file, zip not a valid, okay, where we are using zip, it's not right. Okay, what is a command? State out, path to write a state to that is different than hyphen state. This can be used to preserve the old state. Nothing but state you have to give it. So for that case, I can say state and then Terraform dot. If I say that now, what will happen? We'll see that. What it is happened? Can you see this here? Terraform apply hyphen state Terraform.tf state, and execution plan has been generated and is shown below. Resource creations. Okay, Terraform will perform the following actions. Resource group will be created, and we plan 1 to add, 0 to change, 0 to destroy. If I say that yes, see that what's going to be takes place. And 1 added. If you come down, you can able to get that resource is created or not. This is done. So desired state, we can maintain it. So for that case, what we are going to use it, we are going to maintain. So this here is a backend.tf file going to be maintained here. So this is the one. Can you see here? So what we are doing that here, as part of the Terraform, if you observe, Terraform backend Azure RM, of course, same thing. So we are going to give a name of the Terraform. So you can get it here also from directly from here. You can search it out backend. So you're getting that somewhere. You can see that build your own plugins, store remote state, we can use it here by using this. Click on it. How you are storing this? Now you have a built and changed and destroyed the infrastructure from your local machine. This is great for testing and development, but in production environments, you should keep your state secure and encrypted. So where your teammates can access it to collaborate on infrastructure. The best way to do this is running Terraform in a remote environment with shared access to state file. So for that case, what we are going to that Terraform remote backend is going to be there. So this here we are going to add backend. So till now we have done the same thing, right? Here it is same. We have done up to this level is perfect. But set up the remote backend. We are adding that backend, an extra as part of the Terraform. That is what we are using the organization name and workspaces and example workspace. We are going to give it nothing but it's going to be a your container name. So that's what we are just seeing here, right? This is the one container name. So backend, Azure RM and resource group name, storage account name, container name, key, we are going to give it. That is nothing but a backend. So once it is done, Terraform Cloud, Terraform login and all, if you just do that, Terraform init, we are going to get it. And then you can remove the Terraform state file, set the remote variables. And once it is getting, right, just come down, update, nothing but what these are like creating the see account set, subscription ID and service principal. We are going to get it and then we are going to add that part, apply, and you can use these options. So nothing but the data can be stored into the remote site. The data can be stored in a remote site. That's what the point here. So if you just observe this in the main.tf file, we are just adding same stuff and same provider. But only thing is that backend.tf file, you can add it on the same file itself, but it is a separate file you can give it this way. So once it is done, as usual, we are going to execute it. So whenever you execute it, it's going to be updated over there. So for that case, what we have to do that we just need to add the backend. So if you come down here and create one file called say provider.tf file. As part of the provider.tf file, just need to add this, and you can come down here and say provider.tf file. You can get it. Now I'm just hard coding here. Of course, we can going forward. We can also get it that what resource group you have to use it and all. But you can see this storage account name, container name, and all we have to give it. So if you go in our console here, so just go into the resource group, create one. What we have to create? One storage accounts you have to create it. I have already storage accounts here. You can use this storage accounts. Out of that, what you have to create it? Shall I create it in this storage account? I want to create container. See this here, blob service container. You can create it a container. So name I can able to refer storage account name. I can change it, and then container name I can give this is TF state, and you can give it whatever access you want. So specify whether data is a container may be accessible publicly. By default, container data is private to the account owner. Use blob to allow public read access from the blobs. Okay, get it. Just create it. It's okay. It's created. But what I need to do that I have to give this storage account name. Let me take it up this name and I can update it here. The container and say storage account name is equal to this, and the resource group is what here? For this case, resource group is this is the one storage account. What is the resource group it is used? Can you check it out here? Replication resource group is this one. I can use this copy and you can update. I'm not creating explicitly, I'm just using same as it is existing one. Let me take it as this. As usual, EF state, account name, and resource group, and this file going to be created and it will be safely keeping over there. That's nice. And then save this. Now you can come down here as usual. It's going to be text space and remove these all stuff. Okay, Terraform backup files not required anyway. So tflan also just I'll remove it, not required. Main you can keep it. Provider main.tf files. That's all. So any number n number of tf files going to be you can create it. It will be referred automatically. Cool. Now say Terraform init. Let me see that is required to is going to download anything. Initializing the provider version is as usual. It's taken it time. It's fine. Now apply to say apply and say tf plan. It's going to create it. Okay. Then we'll lock it over there. But this time, whatever we are executing through backend, right? So if it is created, if it is creates, I can able to find it here also. One thing, home page, and say go into it's loading, right? Okay, Cool. So here you will find the containers. You got it right? TF state file we have container. Now see that state file is stored here, terraform.tf state file. Just now, see, it's a 720, 720. Good. Now just creating, but can you see that is there anything here? No, it is your TF state file. Cool. So that is a which anybody can suggest why we are using that, because of as a team, if I want to maintain a TF state, for example, if I do that in my local, the TF state file going to be there in my local. If somebody, once again, if I execute it, that same Terraform script, it will recreate it. But if you keep that TF state file in the remote location, the Terraform script going to be refer that TF state file every time.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So it will check if desired states exist or not based on this TF state file. Okay, now we have done. Now what I want is check it out. This file is created. If after this is created here, that's fine. But resources group is created or not, I want to check that. Yes, it's created. Now I'll go this situation and the whatever scenario I'm going to lock it here. Right? If I lock it, I cannot able to delete. Just it's a locking. It's a very good feature. Okay, read only, because unfortunately if I do unexpectedly if I delete it, you lose something. So that's the reason people going to use this lock option. There's an interview question also sometimes people going to ask. Okay, so test and then say okay, read only, test. See this, it's created. Now I'll try. We have explicitly added this parameter to this resource, but we have not done through say Terraform. But now if I'm trying to deleting this Terraform, through Terraform I'm deleting this resource, but is this going to stop or not, or what kind of exception or what it tell, we'll see that as per this scenario. Okay, it's a specific scenario. Now just say destroy. Okay, it's a destroy. It's going to refer that state file from the remote, and it will cross check that, and it will identify that what resource need to delete it, and then it's going to delete it. Let's see what kind of message it will going to show it up here. Say this here, it is previously it is not shown because Terraform file is, I mean, state file is not there. It is checking now Terraform state file. See this refreshing state here, resource groups my demo TF. Okay, an execution plan has been generated and is shown below destroy. Terraform will perform the following actions. Only it will check that according to the TF state file. So TF state file find this resource. So 0 to add, 0 to change, 1 to destroy. It's just a plan. Okay, try run. Now, do you really want to destroy the changes? Yes, I'm going to say yes. Let's see, is this possible or not? Quite interesting. Good. Now you got it right. So why it is showing the, it's enter a value Azure RM resource group destroying. It is trying to destroying the my demo TF. So what you understood? Terraform going to check the TF state file, not the Azure resources. So that is a we call as a desired state will be maintained through the TF state files. So if it is going to refer the TF state file, if I say that destroy, yes, I'm saying that destroy. But as part of the execution time, it will be restricted. Right? You are explicitly added that lock. So while trying to deleting that resource, you're logged already. We don't have a permission, so we got that exception. Say RPC error code unavailable. Transport is closing. Simply just throwing an error. It completely depends on this TF state file. Agree? On this containers, I mean, I'm right now storing in the remote side that we call backend. So this TF state file, way it will going to cross check that the TF state file, what content is there, accordingly it's going to respond. Okay, once again I'll do one thing. I'll try to apply it. It's already there, this my demo TF file. If I once again apply it, what will maintain, we'll see that, right? Okay, if I say that TF plan, Terraform apply TF plan, if I do that, what it will do that will see. So saved plan is stale. The given plan file can no longer be applied because the state was changed by another operation after the plan was created. Nothing but it's already created. Okay, I'll remove this. I just apply it. Now what will happen is acquiring the state lock. This may take a few moments. Refreshing the state. Now you got it. This may take a few minutes. Nothing will be happened. Even I can delete this lock also. We'll see that part as well. So you just go here, locks. You can delete this lock. Okay, I'm just done that change in the lock section. I'm just deleted. Fine. I can once again apply it. Terraform apply. I'll show it up diagrammatically what is happening right now so that you people can able to understand little bit in detail. That there is a where it goes right. That is sure that options auto approve backup compact warnings. If Terraform produces any warning that are not completed by the errors, lock is equal to true. State file when locking is supported. Lock timeouts input equal to no color. If specified, output won't contain any color. Parallels refresh state out target resource var file. I think, but this is going to be give. I think so. I'll just not pretty sure in a verbose mode. What are the things required? I'll just check it out if it is there anything. But I'm not pretty sure. Normally, -v. If I give it, I don't think so. -v will take a variable, not the verbose mode. Provider registry, the version of Terraform is out of date. The latest version is 1.00 something like that. So till now, what are the things we just discussed? If you take in the code point of view, we have understood about the provider, we have understood about the backend, we have understood about the resource. Now we are going to talk about data separation. What is a data separation? So it's nothing but what? We are, instead of directly hard coding the values as part of the code, like a resource name I have given, version I have given, name I have given. So those names and all, I want to be portable, but I want to be overriding. If it is a different levels, different environments, I want to use different values. But code will be same. But creating the resources will be different. Like Manav is also asked about like module, but module is little next level. But I'm just making the, for example, I want to create a resource group. If it is a dev environment, I want to create a group name is resource group dev. If you want to use a production, for example, resource group production, I want to use it. But in that scenario, I cannot write multiple main.tf files. I don't want to maintain it. I want to use what? Variables. I should be able to pass the variables. So for that case, we are going to use, the concept we call it as data separation. Nothing but one code with multiple parameters. Nothing but we are making the parameterization. Simple example. I have a add method, for example, Python. Okay, I'm just going to pass the variable here. Nothing but say what are the parameters I'm going to pass it out, just like say a comma b. Then a comma b values always sometimes I'm going to give 10, sometimes I'm going to give 20. Sometimes I can give a is equal to 21, another time I can give it 23. But the code going to be executed same thing, this one only. Sum is equal to a plus b something. Then accordingly, it's going to be takes. Good. So for that case, what we have to do that? How can we achieve it? So we are going to add two more files. One is variables.tf file. Here I'm going to declare all the variables. Okay, those variables I'm going to refer it as part of the main.tf file with a dollar, then name, variable name. You can give it here. Then we are going to pass it out either default values or I'm going to use it through tfvars files, like a dev.tfvars. If I have this dev.tfvars, I can apply it. For that case, what I can do that, I can simply say Terraform applied, and then I can pass these variables. Var file is equal to dev.tfvars. That's all. So that's what the point here. If you check it out, Terraform var equal to var file is equal to. If you want explicitly variables, just like a runtime parameters, you can give it. Set a variable in the Terraform configuration. This flag can be set multiple times. And if you say var file is equal to foo, set a variable in the Terraform configuration from a file. But if I have a multiple parameters, yes, this is the always refers to this terraform.tfvars or .auto.tfvars files are present. They will be automatically loaded. Even in Ansible, you take it Puppet, you take it any things, we are going to pass these parameters. Advantage is reusability. This is very important, especially in our projects in a production level, in a test level. If you want to do that, we are going to use this option. Good. For that case, what we can do that, we'll see that. So if you take it in that example, can you come down the one virtual machine? Take it at this virtual machine example. So this virtual machine. After that, this just observe this main.tf file and say variables.tf file. Now just observe what we are doing that. Till now, what we have, I'll just take it as sample way. So this variable, resource group name, string, rg name in Azure description. And this variable.tf file going to be, this resource group name, if you take it up and go into the main.tf file, you can search it out. It is going to be there now. See this. You are getting right? Name var.resource group name. But in our case, what we have done, we have just directly hard coded name is equal to. So what I'm going to do that here, instead of doing this, I can refer this part simply and just come down and you can get it here. Name equal to resource group name. But how can you get this resource group name? I can create one file, right? I can create, say, variables.tf file. As part of that variables.tf file, I can get it from here itself. This variables.tf file, and you can refer. I'm just taking only one parameter to understand easily, right? So you can get. So this is the variable we have used, and say main.tf file we are using here, resource group name. Now I need to create another one. So just observe here. What I'm doing that I'm going to pass the parameters either directly. I can pass as a Terraform apply -v or see this here terraform.tfvars. You can use this default one. So here, see this resource group name going to be takes place. Then you can create it. terraform.tfvars. Just simply you can create it like this. Terraform.tfvars. Here I can use this option. And this resource group, for example, if I give it my demo tf, right? I'm using same thing, my demo tf. So here I'm passing tfvars going to be, whenever refer it, it's going to be referred this variable, and from this variable the main.tfl can be getting. This variables is just going to be a declaration of your variables. Yes, I can give you a default value also like this. I can use default. But tomorrow I want a different environment purpose. For example, if you declare it here, I have to declare a value here itself. Am I right? See, I'm just what is my goal is I want to separate the data from main.tf file. For that case, I'm just created variables.tf file. I'm declaring. So if you want to default values, I can able to give a default here like this. But I want to override it at the time of runtime. At the time of Terraform apply command time, I want to change the value. But if I declare in the only within a variable, every time I should able to modify it. But for example, I want to maintain for dev environment purpose, test environment purpose, production purpose. I cannot maintain right variables. So variables is just treat like it's in between main.tf file, actual data. If you want to pass it out in between, this is going to be a layer. So main.tf file going to be refer this variable. These variables can be override the data with the tfvar. Whenever you pass the tfvars, it will be applied here in the resource group name as a value. You can, there are two things. Just think in this way. Say for example, I have a method like this. Pass parameters something like say int a into b. Then here I'm going to make a return a plus b. This a comma b values I can able to declare in the class itself straight away, right? I can declare here itself. But here, as per the class, I can say int a is equal to 10 and int b is equal to 20. But always going to be take 10 and 20 here itself. But what I'm doing right now, I'm going to pass the parameters class level, like int a, comma int b, and then don't refer this. Now what happens? Whenever you call a class, I have to pass this parameter. Sometimes I can able to default values, I can pass it out like this, 20. If you not pass any parameters, default value is going to be take it up. If not, so whenever you call this class, parameters like a 20 or 34, something like that, value is going to be override here. So this int a, int b here we are declaring, right? That is treat like a this variables. Yes, I can able to give a default values here. Default is equal to something like this. Default is equal to something, you can give blah blah. If not pass that tf vars, okay, then automatically this default value going to be applied. If you pass it out this tf vars, nothing but whenever you call it up your class, nothing but template, it's going to override that variable. Is this clear, everybody? So why we are using tf vars? Variables. If you want to separate the data, I have to use the variables. I have to declare those names. We have to refer it as part of the main.tf files. If you want to override it, this tf vars going to help us. Even we are going to use in Ansible also same situation. In Ansible, we are going to declare the variables as part of the modules, and then I'm going to pass it out like this. Ansible. Say this example I'm just giving. Okay, playbook. And I'm going to pass my inventory file, okay, and my playbook file, for example, site.yaml file. And then I'm going to pass it out -e, then variables names. Suppose name equal to ABC, nothing but resource group name, for example, RG name. Automatically, this value going to be override over there. If you not pass this parameter, default value is going to be taken. The same thing we are doing now. Terraform, apply, -v, then RG name is equal to something. This also can be possible, or else you can also give Terraform, apply, -var file, okay, and then use this Terraform tfvars. But of course, by default, automatically refer this Terraform.tfvars. If you give a name, but if any other place, you can give -v dev.tfvars, something you can give. Does that make sense, right? Same thing, right? We are just overriding the values, whatever we required, according to our requirement. So this one we call it as data separation. So how we are doing that? Now just see. We just added this now, resource group name here, my demo tf, and variables we have added here, and this variable I am referred here. Good. Just save it. You can save all. Now you can come down here. Automatically it's going to be takes place. Say Terraform, right? It's not up to date. Terraform is going to be, see this. It's given. It's not showing anything there. And then say apply. So nothing going to be happen. See, now what I do that, I'll just modify. Where I have to modify, just if I go into this location, if I give a 1, for example, save this. And if I go now here, I'll once again, I can simply say plan. Now see that is, see it's replaced because I modified the name, the resource group name. See this here, my demo tf2, my demo tf1. Good. And then plan 1 to add, 0 to change, 1 to destroy. Now I should say apply it. Now got it, friends? What we are doing that? I'm just modified the name of the resource group so that automatically it's going to be delete. So this plan 1 to 0 to change, 1 to destroy, 1 to add, 1 to destroy. Because I cannot rename it, I should delete it and recreate it. It's going to be text. So while doing something changes, you have to be very careful. For example, if you created another resource, for example, as part of that resource group, so that's the reason you should understand the backend. I mean, main concept like resource group contains multiple resources. If you directly change it, that name, it complete resources going to be deleted. So we have to be very careful on this one, right? So if you see that here, Terraform apply. First, it's going to delete the existing one. So don't think that if I just already main.tf file, that resource is already created, if you just change the name, it cannot rename, it can delete it. It's very important. One to add, one to destroy. See this. Or it cannot recreate another one. It just replace it. Is one of the important point this is. Normally, people are going to think that I'm just renamed the existing resource name, I'll just apply it. It cannot rename, it can delete and it will recreate it. Or it cannot recreate another one. Existing one going to be deleted, destroying. Good point. Now let's take it a further step. Okay, this is one thing. See this here. One added, one destroyed. You can find it now. Here, this is going to be deleted. My demo TF. Just refresh it and say, just refresh. Resource groups. It's created. My demo TF1. Now, this is another point. If you want to modify something, you should ensure that is going to be impact anything, the resources point of view. So don't think that I'm going to rename the existing one. No, it's going to be delete, and even here also we cannot rename it, right? The same thing we are going to apply here. Okay, that is one thing. And the next step is I want to create a virtual machine, for example, through Terraform. How can I do that? We'll see one example. That is nothing but a Linux virtual machine. I need to create it. So for that case, what things if I take it up, I can able to achieve it. We'll see that part. Okay, if you go here, okay, I have one example. We'll see one example. See this, there is a virtual machine. Just go this part. So just observe this one. Okay, I'm just copying manually from the to here. Say that module name is here. Straight away, we can get it one thing called copy 6 VM home directory, our demo amateur, and go into this demo Terraform. Sure, we got this. Now you can come down here. Just refer this straight away. Okay, and observe this. So what I'm doing now, just check it out. Main.tf file. What is there in that? So of course we know this part. It's clear. We're not bothered about all those things. Now just see that multiple resources. Till now we have used only single resource. Now see multiple resources. So how can you identify this one? It's nothing but you should understand what are the resources are required to create a virtual machine. Simple one. See this, create a resource group if it does not exist. See this. Now tell me friends, what we have to do in this scenario. So what resource group name you are referring, you have to check it out. How can you check it out? Var.resource group, I'm going to check it out. So that is going to be variables. See this. Var.resource group name going to be pointed. And this resource group name, if it is default, is there okay. If not, it's going to check it out in the TF Terraforms. Here it's going to be. So here I have to existing only if I want to check it out. This I have to refer it. So this is the way we have to modify in our projects. So this is only critical. If you ask me to create a manually main.tfl, I can do that within minutes. But in a project, if it is already exist, if you want to debug it, you have to go with this workflow. So the workflow will take place through first main.tf file. Okay, main.tf file. In the main.tf file, what variable you have to check it out? Check it out the variable. That variable name you have to find out in the variables.tf file. That variable.tf file name you can check it out in the tfvars. So nothing but what? If I pass this tfvars, it's going to be applied here. So this will be dynamic. It may be a dev environment, it may be an IT environment, it may be a prod, blah blah things I can able to use this. Okay, now we have done the same thing here. So resource group location. So we have to use, in our case, the East US. That's going to be pointed. See this here in the main.tf file. And the next location is what? So virtual network going to be created. VNet going to be created. This VNet going to be, see, yesterday we discussed about address space. Number of IPs I can able to create it by 6 into power of 6 and C. We are allocating that parameter. See, Azure Virtual Network. Azure Virtual Network is a resource. You can find it even, these all options are ready-made, friends. You can get it straight away. See this here, say virtual machine. You can get it straight away. Connect to console client and virtual machine. You can see this Azure Virtual Machine using Terraform. Straight away. You can go straight away registry. See, you can find it straight away from here. See, Azure Virtual Machine. If I want to create a Azure Virtual Machine, see this here, all options are open. Compute, resources, Azure availability, whatever resources are there, services are there, everything going to be gated. See, Azure RM remote, disk access, everything find it. Out of that, this Azure Virtual Machine. For that case, what we are going to do that, I can get a code straight away. See this here, straight away, everything is in place. We are not doing anything great. Just we are referring that. See this variables. This value going to be take it up. Variable prefix is equal to this prefix. Whoever is going to use it, see automatically came. Nothing but what I can declare in a single file itself variable. I can pass it out. Where that prefix, this value going to be used here. So this is the resource group. Next is see Azure Virtual Network, Azure Subnet, Azure Network Interface. We have seen these three components, and then Azure Virtual Machine. And all these parameters, I'm going to refer it to this Azure Resource Group dot main dot location, Azure Group dot main dot name, network IDs, Azure Network Interface. See, Azure RM Network Interface dot main then ID. That's what whatever ID going to be created, I'm referring that. Instead of giving hard-coded way, because it's going to create one interface. That interface we are referring here. And then storage image reference, storage OS disk, OS profile Linux config, all these are, see, different options. To create a Azure virtual machine, whatever parameters are required, they're all declaring here. And these values, sometimes straight away we can pass it out. Sometimes we have to derive it from existing resources. Or sometimes we have to pass as a variables. Only that you have to understand. If I just take it up this one, automatically it can work for me also. But same code it is here for series. Got it right? Azure Virtual Network. Azure Virtual Network, but just name will be different. You can give anything, but we are passing the address space, location, resource group name. Right? See this. Name, address space, location, resource group name. So these values yours. Your customized values. So that's about these in the main.tf file. One is about the resource group, virtual network. So parameters are as usual. Whatever we just added, environment equal to, you can give dev or product. It's just like a tag. And then subnet. So if you want to create a subnet, we are going to refer the virtual network name, this one. So that's the reason it's just a parameter. And then Azure resource name virtual network, this one we going to be pointed. VNet dot name. So interconnected, these are all like. To create a subnet, we are going to refer this same address space, but after that 24 we are going to add. Next step is, so what we have done, this is the resource group public IP and security group also we have added. The security rules. We have used one thing, inbound and outbound rules. See here. Only priority, SSH, 22 port number, port range is star, and from anywhere to I can able to access. So this is the name, and it, nothing but what, it's going to create one security group with this network security group name that is going to be here. And then that one, it's going to be over, it's going to be referred here. The network security group name, see this, network security group, type equal to string. Yes, it's just like a combination of characters. NSG name in Azure, and it will be applied here. And it will create next. As part of the virtual machine, if you come down here in the virtual machine, it's going to be referred that network security group. You can find it here. We are going to refer that. OS disk, network interface IDs, name, location, resource group, this is the part, and OS disk, source image reference, computer name, all these are going to be used, admin key, and boot day. Even it's going to be referred same. So here we have created network security group, but here it is not referred, right? Authentication, OS profile, storage image reference, interface IDs. But we have not created explicitly, say this here. There's an optional. That is optional. If you want to do that explicitly, see you can find it. Network security group. Virtual machines, extension scale set. This is the compute, right? And say data sources. Is there anything network, friends? Yeah. VNet I want to create, for example. Azure provider, authentication, authorization, automation, base batch, billing, improvements, broad, CDN, cognitive, computer, communication service, consumption. Okay, just calm down. I think NetApp network here. See this, all these are here. First, food, firewalls, local network, gateway, network connection monitor, Azure RM NAT gateway, public IP association, network info NAT rules. For VNet purpose, all we are going to use it. And here, argument references, you can find it. What are the options are there? Name, resource group. So required, see, required. Security rule is optional. Like that we can find it, optional, required. Description is equal to optional. Protocol is equal to required. Whatever required is nothing but those are like a mandatory parameters. Optionals are you can declare it according to your requirement. Then what you are going to do for VNet, how to create a VNet. Then check it out here in this part. So which if I want to create a virtual network, you can find it here, virtual network. You can take it up and say this. Automatically you can find it. Say this. Network security group, network DDoS protection plans, virtual network, and the DDoS protection plans, subnets, all are here. It is you can straight away you can use it. Take this and you can copy it. Next level, what is required? According to your manual steps, identified components, you can take it up all those resources and you can write it in a main.tf file and you can apply it. If that works fine, then once again you can destroy it, separate the data with the variables, with the TF vars. If everything is okay, you can apply it. Done your task. So this is the way you have to construct it one by one. Always, friends. So don't do that now itself. In the very first time itself, don't go with the TF vars. Don't go with the variables and all. Because if you resolve this issue itself, it's going to take time. You cannot reach your target. First, go with the hard-coded way. Nothing but that's the reason people going to use widely POC style first. I'm going to develop the POC. Very basic things I'm going to add it according for my requirement. If that works fine, then I can customize it to support for environments, to support for your project, right? So main idea you have to achieve it first. Then you will get a confident. Then easy, right? Variables and all according to the possibility and feasibility levels you can have. Does that make sense, everybody, friends? Is this clear, right? Now, if I just apply it, is this going to create a virtual network or not? I mean, virtual machine or not? We'll try it out. We'll debug this part. And also, I'm going to ask you what image we are using to create this virtual machine. We'll see that. See this? Of course, this is a network interface. Nothing but going to be allocate the subnet ID. It will automatically get the address ID, public address ID. And say security group association. We are going to associate it here, right? We are going to association. Network security group is an independent item component. That component I'm attaching where says network interface ID. Yesterday we saw that I went into the network interface. I checked out which security group so that it can be restricted. So there are two ways we can associate it. One is subnet level and the one is interface level. Nothing but we can associate with that public IP address, network card. And that what? Network security group ID, network interface automatically going to be associated. Okay, one more important one. So there is a random ID is creating. Quite interesting this one. So it's going to create a one random ID going to be attached byte length and resource group, and we are going to attach it keywords. Just like a random number. In a programmatically we are going to use it. So automatically generates randomly picking up the thing. And also one more important is create and display SSH key, TLS private key, example SSH, RSA 4096 byte. So it will going to generate this private key. I can copy into my local, then automatically going to be referred that. So this here, TLS private key going to be referred somewhere. So this here, private example SSH, public key open SSH going to be added. Cool. Now I can apply this part. We'll see how it is. So what commands I have to use it here? Same as this is. I can also do the Terraform format. If you check it out here, some syntax is proper, not there, for example. Okay. If you just take it up this main.tf file, not proper, for example, then simply say Terraform fmt. See, automatically going to be. The same way, if I go into the 6 part, I have this all file. Now, if I say that Terraform fmt, automatically going to be formatted. See, for example, I'll go something main.tf file. I'll just give some indent. It's not proper indentation. Okay, I'm just save this. If I say that Terraform format, see main.tf file modified. If you go into that file, see properly set. Quite interesting, right? Good. Then next level. Now, as usual, I should say that Terraform because I'm in a different directory now. Now I can say Terraform, but before that, can you see this? Check it out. Now say Terraform init. As usual, it's going to take it up. Plugins. See, finding the latest version of HashiCorp, finding the HashiCorp Azure version matching, finding the latest version of HashiCorp, all these things. Terraform has been successfully initialized. Now I can say, as usual, plan. Of course, I can do this way, out tf plan. As usual, it's a common part. Only thing is that you have to things that just maintain the files is important. Good. Now I can apply. So what should I say? tf plan. Automatically, it's going to create this watching machines. But this time we are not using, I think, a backend, right? Here we are using backend. No, blocked everything. It's okay because I'm the one on executing. It's not a problem. Until unless we worked as a team, then that time you have to use the backend. It's very important. So everybody is clear, right? What is a backend? So what is a backend? What is a provider? What is a resource? And as part of the resource, how can pass the parameters? With the parameters, with the variables, I can get the variables from the variables.tf file, or I can able to refer existing resources also sometime. For example, resource group we have created. In virtual network time also I have to use resource group. If I have to refer it, so I can get it resource itself. Instead of hard coding, instead of declaring each and every item from TFRs, not required every time. So whichever is minimal required, we just see this, friends. We got this private key. So you should copy this private key. So begin from here to TLS private key. As usual, you can copy this. You can give some name. What is the name it is referring? TLS underscore private underscore key. TLS underscore private underscore key. You can give it. You can update it. Just treat like it's like a PM file. Now we got this file. Okay. So is this applied, right? Now we have applied. See this 11 resources going to be added. And see, the state of your infrastructure has been saved to the path below. This state is required to modify and destroy your infrastructure. So keep it safe. To inspect the complete state, use the Terraform show. Can you see this? Terraform show. Public key files. All. Nothing but this will be showed up your TF state file. See, each and everything is created. Good. And you can check it out here. It is created or not. Resource groups. Under that resource group, you can refresh it. Are we use the same? We have used the same thing, right? If you go into our say vars files, my demo tf1. Yeah, exactly. So you can get it. You can get it. Just refresh it. It's not creating. See, it's created. I think different one. My Terraform RG, and then it's created. But why it is created my Terraform RG? Can you check it out? If it is this variables, okay, subnets, resource group name, and say main.tf file, resource group name, var.resource group name, var going to be pointed to the variable.tf file, and this is going to be text-based resource group name. So this resource group name is going to be find in this TFS. Okay, just a minute. Little confusion. Main.tf file, variables.tf file, tfvars is to yours. It's correct, right? Okay. My demo TF file. It's great. It's not referred existing one. It seems okay. Created here. It's my Terraform underscore RG. It's created. You can find it out. This see virtual machines are now created. And see NSG production public IP VNet and all it's created. Now if you go into the virtual machine and see it's Linux Ubuntu 18, all this 51 and all is created.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And then you can simply say connect SSH, see private key path, Azure and all. Now if it is everything is correct, I can take this IP address with the user and then come down. We have a private key already here. If it everything is correct, say change mode 400 TLS underscore private and then say SSH hyphen I, say TLS, and then you have to copy this. If everything is correct, it can connect. See this? Good. We are able to connect that virtual machine. And then you can switch to the root use. So I'll tell you why it is Terraform. It's not saved, friends. This is not saved, right? If not saved, what value going to be there? We'll see that. Don't save it. And if I say this part TFVars, it's created in West Europe. Can you check it out? Is this created in West Europe itself? Say resource groups. Say it's West Europe. It's my mistake. I'm not saved. I'm changed, but it's not saved. That's the reason it's created different region. That's the reason why it is created this RG. Nice. That's another point. There are other things also there. I wanted to talk about the what is a different environments. How can we handle it? Environments like this. How we are going to use it in a Terraform, like a dev environment I want to support, test environment I want to support, okay, and say production I want to support. How can I do that? Okay, and how we can able to maintain the state files for each and every environment. So that is also important. So for that case, what are the things are required? And what that is nothing but a workspace. If you get a chance, read about this. What is a workspace? What is an environment? Good. And we'll see some other examples. So just virtual machine is a basic one, right? I'm going to ask you, can you deploy a app service with application? So how can you take it up? This is very important, a little advanced and important one in a project requirement level. And also I'm going to install, like I said, right, Ansible is going to help you to install something. But whenever I bootstrap my virtual machine, I want to run some Ansible playbook. For that case, what we are going to use it, that also we'll talk about. The next step is, we can also create a containers. So anybody explain, friends, what is a container? Okay, by using the Terraform, you have to create a Azure container registry. So for that case, what is a container before that? So nothing but a Docker container. Container consists of images which have the details of the files and applications. So what is the purpose of using the containers? Nothing but what? We have to create a lightweight image. And I want to be quickly to launch an application within seconds. Quick launch. And the dynamic memory, I want to use it. If required 1 MB, only 1 MB I have to use it. And simple network, I have to enable it. Like yesterday we discussed about virtual machines, right? Virtual machine can able to create on top of the bare metal system. Containers, I can able to create it on top of the operating system. It may be a virtual machine, it may be a physical machine. And lightweight, meaning existing operating system only I'm going to refer it instead of adding the operating system as part of the image. That is nothing but a container. So this container is nothing but enables the OS level virtualization. I'm expecting this one. Read about this and let me know. What is a container? So the differences between the physical machine and virtual machine is virtual machines can create on top of the physical machine with the help of memory virtualization. Now container, if you take that on top of the operating system, I can able to create a containers with help of OS level virtualization. Why? Because I want to extract the operating system file from the image. If you take a virtual machine image, you will find the operating system. That operating system going to cause the heavy weight. I want to make a lightweight. I can go anywhere. I can go anywhere. I can pull that image. I can start a containers. So that's an advantage. OS level virtualization. So who is going to provide this kind of containerized technologies? Like a Docker is one of the part. Container D is another provider to create a containers. If you take a virtual machines, can provide by the hypervisors like Oracle Virtual Box kind of things. But in the same way, multiple vendors will be there to create a containers like a Docker, Container D, RKT, CRD, something will be there. By using that, we can able to create a containers. But now, Azure also going to provide that facility to start a containers to store your Docker images in a storage that is called as ACR. Here, you can come down, you can say ACR, or maybe you can say registry. You can search it out as a registry. Is getting something? See, container registry. Here, I can able to upload my images, Docker images. So this container registry, you have to create it through Terraform. And in the same time, if you want to launch a container, I need a Docker installation and all. Straight away, we can get it. This here, container service. See, container instances. I can able to create it. See, use Azure Container Instance to create and manage Docker containers in Azure without having to set up the virtual machines or manage additional infrastructure. To get started, create a container in Azure Container Instances. You can refer. And if I want to create an AKS cluster, for example, that's what Kubernetes service I want to deploy it. But normally I can go here, see AKS Kubernetes service, nothing but. I'll go create an option, blah, blah things. But I want to be do that through Terraform. And what should I need to do that further case? Will take it up some other options. Fine? Great.
Now I'll just talk about in this overview part. So keep it aside all these Azure, AWS or Google Cloud or cloud, blah, blah things, right? So you are, think over it now, you are an administrator. Okay? You are an administrator, maybe a Windows or it may be a Linux server, for example. You are a Linux administrator or a Windows administrator. So can anybody, friends, can you tell about what kind of task we are going to perform as part of that administration? Creating the users, permissions, nothing but accesses. Okay, configuration. So it's ultimately what we are going to that. We are going to say, I can say in a broader way, we are going to install some packages. Just in a broader way, if you take it up, right? We are going to install if required some software. We are going to configure some files if required, file permissions or creating the, creating the users, all right, and all, and the services you are going to maintain. So services are up and running or not. Ultimately, these things are going to take it up, as well as we're going to manage about the storage, like how much space is required. So that we are going to monitor it. If it is reaching 70% or 80%, what should I need to do that? Accordingly, I'm going to add a storage or I can bring it up another server, like that kind of things we are going to take it up. Super. Yes. Networking also we are going to maintain. Nice point. Networking, network configurations, creating the IP address, public IP address, private IP addresses, ACLs, right? Enabling the permissions, access control list. So networking part, storage part, computing part, okay, and permissions part. We're going to handle it with administration. That's nice. So now my requirement. So you have to bring it up 10 servers. How can you do that? So you are a pure Linux administrator. You don't have a cloud, for example. Think of it. How can you do this? So that is, I mean, next level. So it's a basic. I mean, I don't want to use an AI automation right now. You are just a basic administrator. You don't have any tools, Terraform, cloud. You don't have, for example, right? We are going to write some shell scripts, or you can say purely we can say commands, right? You are going to log in into the server or are going to execute the commands. If it is a Linux server already there, maybe a physical machine or maybe a virtual machine. That's nice. And these commands you are going to take it up. So nothing but what we are going to create a virtual machine, whatever source you are going to use it, and then you are going to log in that host and you are going to configure it according to your requirement and ensure that that will be there in the cluster because I need to because if I'm launching an application means what I'm as an administrator in the sense I have 100 servers because I need to support to my customer. So customer means what there are hundreds of customers going to be access my application. So I cannot deploy one application with one server. So I have to bring it up multiple servers. I need to load balance it just like a team management. Agree, right? If you take a team, what you're going to that I'm not going to maintain one person in my team. I'll maintain multiple people, and whenever I get a multiple request, I can distribute the task. Right? I'm going to distribute the task to the among the people, and I can able to get it done the task within time. The same thing here as well. So we need to create a multiple servers, and I need to enable the cluster. The cluster can have the capability a load balancer. Agree? Load balancers, and so to maintain the load balancer and all, I need to enable the monitoring. But if it is keep on increasing the number of users, I should able to launch new servers. If not, server may go down out of memory exceptions or performance issues you may face. Agree? So scaling is also important. So scaling, monitoring, load balancing, the cluster maintenance and creating the virtual machine, managing the storage part, CPU part and all, I have to take care about. Okay, that's really, these all things are will comes under as part of the administration. Fine. Now next step is, so this is if you are a base administrator, a core administrator, you're going to do these all activities. Now I have to take a next level evaluation. So if you take it in the last, I mean, 10 years before, if you take that, we don't have a cloud. We have our own data centers. We are going to create a virtual machines over there, either manually, either our own UI. We are going to create a virtual machine, but that is going to be a cost effective, right? If you maintain our own data center, so I'll take it up in this way. Okay, so why cloud is an important and in how Azure is going to be text based. Now I'll take it up in that way. Okay, assume that we are developing an application. Okay, we are going to start a new app, for example, or for our business purpose. So we need to launch that application now. Okay, we are in a startup mode, for example. So okay, so our company is a new company, and we are just starting the one new application. So what we are going to do? So we cannot manage our own data center. Agree, everybody? Even if I want to manage my own data center, I have to invest a lot of money. Agree? So if I ask that what is a data center? Yes. So for that case, I'm not pretty sure my application may get success or not. May get success or may not be. But if I invest it now itself to bring it up these all servers and all, so it's a huge cost. I have to buy new machines. I need to take the building. I need to maintain the networking, storage, all people, storage people and all. I have to maintain that server. Right? That's going to be a lot of time going to take. But if it is a big organizations, of course they're going to maintain, like an Apple, Google, Microsoft, all those people are going to maintain it. I mean, maximum mid-level organizations they can maintain. But if it is a small scale organizations, it's difficult to manage it. So for that case, okay, some providers are coming to that to provide a service that we call it as a cloud providers. For example, I want to launch my own site for my business. So I am not bothered about to bringing up the bare metal systems, configuring, deploying, and all. I have to use one service. Simple. In this way, I can tell you that in a simple words. Suppose you are shifted to different location, maybe a different country or maybe a different city. So I cannot immediately buy a new house, right? So according to your time, how many days you are going to spend, how many years you are going to spend, accordingly, we are going to take the house or hotel. If you're going to be spend months, then you're going to take a house. If you're going to spend only one week or one day or 2 weeks, then we are going to take a hotel. Like, I mean, depends on the situation, right? The same thing I want to be. I want to cross check it out immediately. My application is working or not, but I'm not going to launch. I'll just quickly take it off one server. I need to launch it and I need to test it and get done. So whatever charges are there, I have to pay for that. That's all. I don't want to take any more risk. And I want to start it slowly, one application with a minimal 100 users. So I'll just launch it, just like a taking a rent house. Suppose if you need more requirement, then you're going to take an apartment. Like that, I have to take it up. The same approach I want to be. That kind of facility is going to be I'm expecting. So that kind of expectations, that kind of business is going to provide by the cloud providers. So out of that cloud providers, so top people are going to be AWS, Azure. Of course, you can also start. You can also explore it. Your business point of view in cloud level. So if you take IBM Cloud, it is there one. DigitalOcean is there. There are so many things are there. But that is not this much level. I mean, Ali Cloud is also there, right? So there are so many. Okay, good. But out of the top, I mean, big providers point of view, if you take that in the top three, if you take that, these three are top three. AWS and Azure and GCP. Okay, but Azure is going to provide by who is implemented? It's a Microsoft. Okay, now just I want to know about Azure. So who know administration in Azure side? Okay, so let's take it up further here. So if I say Azure is a cloud platform, so then what are the things going to be there? So you take it in any cloud, you take it up, right? So we are going to use these services. Okay. So IaaS means what? Infrastructure as a service. PaaS means what? Platform as a service. SaaS in the sense software as a service. So what is an infrastructure as a service? So it's simple, right? So in its simple terms, if you say that we are going to take the machines, right? Virtual machines. We are not going to get any server configurations and applications and all. Just if you buy a laptop, what you are going to get it. Same thing I'm going to get it if I use an infrastructure as a service. So I can say example here, the virtual machine, Linux machine or maybe Windows machine or maybe SUSE machine, anything, I can able to create a virtual machine. So on top of it, I have to customize my own requirement. I have to install packages. I have to bring it up the servers. I need to deploy my application. I need to launch my application with that. Got it? The virtual machines. That we can call it as like a infrastructure as a service. The next level is, see, for example, you have started a business. Example, one core application, I mean, core engine you have started and you have launched an application. Okay. And you're delivered into the market. The next level, what you're going to think that you're going to take the feedback from the customer and what challenges they are facing and what if I give a new extra service, right? So customers can feel very happy to use our application. The same thing, evaluation is taken place here is also in the cloud. So initially only they have, I mean, cloud people can bring it up only bare metal systems. They will provide a console so that I can able to create a virtual machine. But next things, all other things are need to take care by the project people only. Now we they want to reduce the risk and effort. So for that case, they're going to use a platform as a service. Platform as a service. Nothing but what? Here they're going to get it VM plus server configuration. Server configuration, you're going to get it. So what is a server configuration here? So I can create a virtual machine. And if I want to launch an application, I need some installations. If it is a Java based application, I need to install Java. If it is a .NET based application, I need to install a .NET. And I need to install a IaaS servers. I need to install a Tomcat server. I need to install whatever is maybe HTTPD server, maybe an Nginx server. right? So those servers, I can able to get it straight away here itself. If I use a PaaS service, only my task is I need to take my application code. I should keep it over there in the server. That's all. My application will come up. No risk at all, user level. Because I'm the user, I'm developing my application. I need to launch it. So cloud is providing that platform, these two levels. If you just say that here, we are getting the server and we are getting the server with a configuration as well, like a database installation. I'm getting ready-made server. I just need to create my tables. I need to insert my data. That's all. I'm not bothered about other things, configurations and blah blah. In a PaaS, directly I'm getting a directory server database itself, a database server like a MySQL or Cosmos DB, or it may be Oracle. Anything I can directly get it. I just need to access it. That's all. I need to create my tables over there. Super. Okay, so that is about PaaS. So basically, for the customer, the experience is serverless because the vendor is taking care of it. Exactly. So everything is taken care by the vendor itself. What about this one SaaS? So here, even we are not going to develop an application also. We are just directly user. You will get a VM as usual. Server configuration also you are going to get it. And even application also going to be developed by the team itself, cloud team itself. Super. Gmail, Office 365, right? We are just going directly Office 365. I'm just accessing my application directly. I can use it straight away. Function app, super. App services, our example is PaaS, right? App service. If you take in an Azure, I'll talk about that. So SaaS is just you are a user. So you are directly doing your business over there. You're not developing an application and anything. Good. So you take it to any cloud. You take it Azure, you take it AWS, you take it Google Cloud. This is going to be takes place. That's nice. Okay, this is really good. We have understood. Now we can see that what are the different services are going to be provided by the Azure. We'll talk about that front. Okay, so if you take it in the Azure architecture, right? See, whenever we going to start something, you have to understand background, how it is their architecture. Then you have to go each and every component explicitly so that you can understand easily, right? So now if you take in Azure, how it is established, first we have to understand, right? If I straight away I can go because Azure have very well documented. If you see this here, Azure architecture. See right here. Just straight away you can able to get it. Okay. So if you just take it up here, infrastructure architecture. Now you can find it here. The different things are is provided straight away because I wanted to give it like a regions. Can you see this here? How it is there? See, so it's just simple. So Microsoft, nothing but Azure, they brought it up multiple data centers in different regions. Think of it, they have multiple buildings, data centers, we can call it as that. See, different regions. If you go here, see, find the Azure geography that meets your needs. Super. So in India, see this South India, Central India, West India, UAE, and see North Europe, West US, West US 2, West US, Central US, East US, all available regions. Pick one will be, see, West Central US, Central East, North Central US, and here in our case, West India, in China, in US, UK West, all these are. And next is availability zones going to be there. So zones are nothing but in one area. It's just like I'm just divided multiple areas like a south and north and all. Okay, and there we are going to use different cities and different, right? So for that case, we are going to use this. Cool, that's nice. So nothing but availability zone in the sense in one. For example, if you take example West India in Mumbai, there are multiple zones going to be there. I mean, in different cities, or it may be in a single city, multiple buildings going to be there, or data centers. That we can call it as availability zones. Okay, so this is the way it's going to be takes place multiple data centers, and each and everything going to be connected, can be reachable, can be selected. Perfect. So these all data centers are there. But as a user, how I am going to access it? Right? Agree, right? You have a multiple data. For example, assume that you created one data center. So I need to access your data center from my laptop, from my home. How can I do this? should able to provide an access point, right? I need to reach your data center to create a virtual machine. Nothing but you should provide one interface. That interface is nothing but a UI. Through UI, nothing but user interface, or through CLI, command line interface, or through SDKs, microservice, I mean endpoint URLs, nothing but APIs. Through programmatically, I can able to reach that. Cool. So it's nothing but what? They're going to write some programs. That program can be converted as an API. Then I can, if I use it on my PowerShell or in my shell script, if I write that script and if I invoke that URL, I can able to reach that configuration to, I mean, to create a configuration. Or I can directly go to the console, nothing but they're going to provide a URL, nothing but an application URL. I can log in over there. I can able to create a resources by using these all programming stuff. So that is nothing but whoever is going to provide the cloud people, they're going to provide APIs, application program interface. Good. That application program interfaces widely two ways. One is through UI, nothing but GUI, and the one is CLI. Good. So this is the way it's going to be take it up. Okay, this is one next level. So we have a data centers across the regions. We are going to access those regions to create a resources by using GUI or CLI. The second point, right? And what are the how I mean the cloud can divide the services. What kind of services they go into? I mean, just we have understood, of course, infrastructure as a service and a platform as a service and things. But apart from that, what are the other things they're going to do that in a component wise, right? If you take it in that front, say, can I say computing? They're going to provide computing, the basic service, infrastructure as a service. If I take it up, computing going to be there, networking going to be there, storage going to be there, security is going to be takes place, and the monitoring is going to be takes place. So you are an administrator, you are an Azure administrator, you are an Azure architect, as a cloud architect. Yes, you should be able to understand all these 5 topics. The next level it is PaaS services. But if you take it in the computing, so what is a computing? What is mean by computing? VM, VM virtualization. So by using the computing is nothing but what? I'll give you a big system, like a bare metal system or a laptop or a desktop. I'm going to ask you to create a multiple virtual machines with different operating systems. So how can you do this? That is nothing but a virtualization. Who is going to provide this kind of facility or technology? Hypervisors. Maybe you heard about somewhere. Hypervisors. So this hypervisor technology implemented by the VMware. What is this meaning? Simple. If I give a one laptop for you, for example, maybe a Mac or maybe a Windows, I'm going to ask you to install 2 operating systems in that machine. Maybe a desktop, it may be a laptop. Super. Hypervisor replicates the feature, nothing but a computer. Good. So I'm going to ask you to create 2 operating systems in my laptop. How can you do that, friends? I don't have any virtual concepts. I don't have any hypervisors. I don't have a VMware. I don't have anything. I'm going to give you a Windows machine or a Mac machine. I'm going to ask you to install OSs like Windows, and another one is Red Hat as an administrator, right? So what you are going to do that? I can, yes, we can do it. We can do that, right? I can partition the memory. I can partition the memory two part. I can create 2 partitions. One partition for Linux, another partition for Windows. Nothing but what? I'm going to divide the memory 2 parts. Then I can able to install it one part for Linux and the part for Windows. But I cannot able to use 2 at a time. If you take a physical machines, but what is my requirement? Because I cannot buy another laptop or another bare metal system or another desktop. But I need, my requirement is I need one Linux server, another one is Windows server. Just take an example. Just it's required 1 GB, 2 GB machines. I don't want too much of space. I mean CPU on this part. But my system can capable enough. But how can you do that? If I do that, I cannot use it 2 at a time. If you take it legacy mode, right? Cool. Now what I want is, I want two operating systems set in nothing, but indirectly I need two computers, two laptops. One is for operating system for Windows and the one is for Red Hat. But I cannot buy, I cannot afford on that front. I don't want to buy. It's a waste of money, but I want to be used it still. So there, memory, it's simple. The memory virtualization concept is coming to the picture. Here problem is what? This physical memory is a problem. Dividing the memory physically is a problem. If you do that virtually, yes, I can able to do that. But how can you do this? So some technology is required. Virtually, they have to refer the memory. Just like if I create a directory, that directory I want to use it with the different names, just like alias names, but directory will be same. How can you do that in the Linux? We are going to, if you take in Windows, we are going to give a shortcut name. But the directory going to be there in the C drive, but we are going to access from the desktop. Meaning, I'm pointed that link, soft link. The same way, I have a physical memory. Whenever I require some memory to create a virtual machine, I need to refer that from that memory. So virtually, soft link. So that kind of technology can provide by the hypervisors. Who is going to provide this technology? VMware. VMware team invented hypervisors technology to create a multiple VMs. Good. So here why I'm saying that M in the sense machine, virtual machine, physical machine. So physical machine means what? Physically we are going to directly install this operating system. But here I'm going to take a single bare metal system, but I'm going to create a multiple operating systems. I can able to access it as a machine. Each and every machine will be unique identity. Who is going to provide? Hypervisors platform can provide that facility. Nothing but what? If you take an architecture, you can understand easily this way. See, VM architecture. I'm straight away I'm using here, friends. Can you see how I'm doing that? Can you think here? Good. We are taking this part. Now just observe this architecture. So if you understand the architecture, bringing up some solution is not a big deal, right? If you know what you want to do that, if you know that, it's fair enough. You can get a command, it's not a big deal. See ya. So infrastructure. So this infrastructure who is providing now, in our case right now, Azure. That is nothing but a data center. On top of it, they have installed the hypervisor technology. That's their own risk. Of course, I can do that in my local machine also, right? We can also do that. See this. In my local, I can do that virtual box. If I install a virtual box tool in my local, I can able to create a multiple virtual machine. See this here? Cloud is doing same thing. But here, we are doing only limited capacity. That, I mean, cloud people can do that a bigger capacity with multiple regions in a global level. That's the difference. Cool. See this here. Infrastructure, hypervisor. On top of it, multiple virtual machines we are creating. They're providing facility to create a virtual machine. Cool. But if you take a virtual machine, what are the things are required? See this here. Virtual machine required application files, binary files, okay, libraries, and one operating system. It may be a Ubuntu, it may be a CentOS, it may be Red Hat, it may be Windows, anything. So that we call it as what? Virtual machines. So here, if I take it up in our case, what we are doing that is nothing but a computing. We call it as what? It's a computing. We are creating the virtual machines. So here we are allocating what? Memory, CPU, and core processors, whatever is required as part of the computing. How much memory? Just like whenever you buy a laptop, you're going to think, right? What is the processor? What is the CPU? What is the RAM size? What is the this size? Good. Hope everybody is cleared on this computing section. You take it any cloud, you take AWS, Google Cloud, anything. This is a common feature. Okay, that's nice. But of course, I'm created a virtual machine. For example, in my local, if I take it up, I have a virtual machine here, but I need to connect this virtual machine, right? I need to reach out that virtual machine to install something. If I deploy something, I should be able to access it. For example, I want to reach out one particular organization or a particular person. How can you do that? We are going to provide some identity or address, I can say. If you know address of that person, address of that company, we can reach out easily, right? For that case, who is going to provide? Anybody can suggest? I have created a virtual machine, but I need to reach out that virtual machine. How can I identify? I need to give an identity. That is nothing but address. Who is going to provide? This guy, networking. Got it? So networking, what it does, it's just simple. It's going to provide an IP addresses. If you're doing that something, for example, you're getting one address in the sense what, it's completely secure, right? So one region going to be there, one country going to be there, one state going to be there, one district going to be there, one city going to be there. All these are layers going to be there to reach out that part. It's secured manner. The same thing here also. So that kind of facility provided by the cloud networking. Because if I just give a simple IP address, anybody can able to reach it. But that is not the case. For example, you are in a US, for example. If I want to reach out to, if I want to stay, come to there, I need to get a permissions. If I want to physically to come to your place, for example, you're in a US, for example, or you're in India, for example. If you want to reach out to the person, so you should first of all reach out to the first country, and then after that state, after that district, after that something. I mean, you have whatever permissions, whatever is things required, authorization, authentications. For that case, we're going to provide facility here. So this IP addresses it can create it, but there are multiple things going to be involved. Same like how it is providing computing section point of view also, right? So here we call it as first step is VNet, virtual network going to be. So Azure going to provide virtual networks. For example, you are in a team. I cannot see your details directly. Only project manager only can do that. And project manager details, you cannot able to see that. His boss only can able to see that. That's what permissions, security, right? So same thing here also we are doing that part. Good. So in that case, we call it as VNet, virtual network. So virtual network, what it does, it's going to provide some boundary. Only set of IPs only can able to create it with this VNet. And I'm going to create NSG, network security groups. So I'm going to enable it only who need to access, from where need to access, whoever have the permissions, that level we are going to enable it here. Okay, so if you check it out, this VNet components, straight away we can get it. Azure VNet components. See this here. Multiple things are there. Straight away you can go Microsoft part. Don't go any other place. It's very well documented. Now onwards you can easily get it, whatever data you require in Azure services. See how I'm reaching that server's configurations and all. The portal, PowerShell, CLI, ARM templates. Good. Now if you just come down here, why use Azure? Communicate with the internet, communication between the Azure resources. We're going to use this. Virtual network endpoint, VNet peering. All these are things how we are going to use it. Good. And communicate with on-premise resources. See this here, VPNs and all. There are different types of communication channels will be there to reach from my own data center to Azure cloud. How I'm going to connect it, and in a secured way, how can I reach out my computing services and all using the virtual private networks, VPNs. All these are different components. And there is a route tables and border. I'll talk about while creating the virtual missions, so we can get to know little detail. Anyway, we are going to work on this area only. Okay, I'm just giving background. What is this all about? Good. See this here, multiple things we can use it. That's nice. So how can you create a virtual network? If you want to see that, so simply we're going into that. If you know what is a VNet, how to create it, everything step by step you can able to get it, how to do that. But you should know what is what each and every point you have to understand. Our components, you should understand it. Okay, so that is about the networking part. What is a storage? Why it is required storage? A repository is like a storage. So after that, if you take that in a Azure perspective, like what is the storage is, for example, whenever you take a laptop, example, so we are going to get a hard disk, right? Hard disk is nothing but a storage, right? Hard disk is nothing but you can able to GBs of data I can able to store there. So here also I'm going to use it multiple storages. Okay, so for that case, Azure is going to provide separate account. We call it as what? Storage account. So out of that storage account, once you created a storage account, what you are going to do that? What kind of things we are going to store it? I'm going to store my disks. I can take the backup of my virtual machines data that will be called as snapshots. And I want to store in a files that we call it as a blob storage. Nothing but I want to copy zip files or tar files, normal, whatever files, I can able to store it in a blob. There are multiple types of will be there. The file storages, we are going to use those all storages. So there are three things going to be there. Okay. One is disk, just like a disk memory. That is one storage type. Another one is you have to store your data and you want to use it. That is called as a blob storage. You can get the link, you can download it. Just like if I want to download a file, I'll use duplicate and that URL. I can download it. That is a blob storage. Have you heard about NFS anytime? What is that NFS? So for example, I have a 10 files in my local, in my mission, but we are in the same network. So you want to copy files from my local mission to your. So I'm going to enable Drive, right? I'm going to share one directory you can able to access. And that is a shareable directory. Just like example, Google Drive example, if you take that, right? We can store over their files and I can able to access it. Okay, the same way, but I have a laptop, but I have a low disk space. So what I'm going to do that I'm going to attach another disk and whatever log files or whatever files I want to share it, I can share it over there, or I can able to copy from there to my local. Good. Okay. Storage account types are like a containers, file share, tables, and queues. Perfect. So containers are not what you're storing the file. File share is nothing but a NFS. Multiple missions can able to share that directory. Tables, just like normal NoSQL databases and how it is going to be the same way. Queues are nothing but temporary caching memories. I want to communicate data and I want to exchange the data from one system to another system. I'm in between. I'm going to take a queues. That is about the a storage part. So if you go here in a storage, we can straight away we can get it here. See this storage. So this is completely high level. Okay, just see this here.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Multiple storages are here. If you get it here, I think I just got it. See queue, table, blob, file, disk. You can get it straight away from here. And that is also not correct. I mean, I'm sorry, this is correct. Can you see this here? Multiple things going to be takes place. See here. So it's durable, high available, secure, scalable, managed, and accessible storage services. See here. These four are different types of core storage services. Azure blobs, Azure files, Azure queues, Azure tables, and Azure Disk, block level storage volumes for Azure VMs. There are 5 types going to be takes place for a storage level. Good. This is the part. Good. Next important point, security. So why it is an important as security, right? If it is everything is open, so everybody can able to access your application and can do anything on top of it, right? So there is no security. If it is no security, there is no patches, there is no control over there. Anybody can able to do anything. They can do damage, they can share, they can theft, anything they can do that. So security is a top priority. You do it your own cloud, your own data center. Are you using the cloud? I'm not bothered. We are not bothered. But your application is secure or not? Is there anybody can able to trace your application or not? Is this that kind of restrictions are enabled or not? It's an important. So if you are an Azure architect, as a cloud architect, you should able to take care about the top priority security. So for that case, what we are going to do that? A lot of things we are going to take care about. We are going to manage the certificates. How you are going to control your services and all. How you are securing the things? Certificates, secrets. That is we called as here in Azure side, we call it as Azure Vault. SaaS tokens, nothing but secrets we can call it as tokens. And we are going to enable the ACLs, right? Network security groups are nothing but a security. DDoS attacks purpose, we are going to enable the firewalls, like example, WAF, web application firewalls. SSL certificates. That's nice. So VNet switching between subnets and all also, you're going to use it like these all enable thing, right? VNet peering. That's about permissions. And another important one is IAM roles, right? Policies, roles, users, and AD. Azure AD is one of the top service. Policies and all, we are going to use this part. Okay, nice. Nice. These all things are comes under security. There are so many things will be there if you go into the def, definition. See, Azure security. All are you can able to get it straight away. Cloud security. There are shared model going to be there. Few of things going to be taken care by the cloud itself. I mean Azure cloud itself, and we are going to take it up some of things. See, all are security center, key vault, Azure automation protection, Azure gateway, I'm sorry, application gateway, Microsoft attestation, and the confidential ledgers. All these are different options. Security products, these are all like. So why I'm saying that shared model, because see, we cannot able to handle the data center level monitoring and security and all. That will be taken care by the Azure itself. But your application perspective, Azure cannot do that. Azure can provide that facilities, but you have to opt it. You have to apply it, like a certificates, tokens, Azure key vaults, that ACLs, all this stuff. We are going to enable those. Sometimes we are going to enable our own security patches as well for our organization perspective. That's the reason we are going to manage an organization level separate team, security team that we call as information security, infosec. Good. So these are things that we are going to use it. Perfect. The last point is an important point. Why it is monitoring? If you're not enabled, so you may get up. Ultimately, our goal is what? High availability. If I want to make it a high availability, if something is going beyond the expectations or going below the expectations, you cannot reach your target. Meaning, if I deployed one virtual machine, it is reaching 90%, then automatically the performance is going to be degraded. Or if it is server itself is down, then complete application going to be down. But if it is going down in the sense, I should able to do that quickly to another machine so that I can take care about manually. Sometimes manually, but you should know about what is an issue or when it is getting that issue, because we never know that at what time that error may occur, right? So that's the reason we should able to just simple. If I do manually, I have to log in, I have to check it out each and every component, but I cannot check every minute or every 5 minutes. I cannot check it out 24 by 7. But if you enable some tools, some concepts, I mean frameworks, yes, I can able to get an alert. So that's the reason. Maybe you maybe already observed if it is in your application perspective, monitoring alerts. There are third-party monitoring tools going to be there, or in-house monitoring tools going to be there. If you take it in that front, Azure Monitor is one of the monitoring tool for Azure. Azure Monitor helps you maximize the availability, performance of your applications and services, and acting on telemetry from your cloud and on-premise environments. Super. So we are going to get some data. That data I'm going to store in a storage. Then I can able to monitor. I mean, I can able to collect it. I can create a dashboards, or I can send a mail if reaching a particular stage or particular threshold. So that's we call it as an monitoring. There are multiple tools there for monitoring point of view. Out of that, Azure Monitor, Kick Sites, Log Monitoring, and another one is activity logs. Also, we can able to do that. Meaning, in Azure, whatever you are going to perform an activity, you are creating a resource, you are creating a resource group, you are creating a virtual machine, you are logged in Azure. Everything is going to be logged. Everything can be trackable. How? By using these all monitoring stuff. There are, if you take it in Azure side, if you check it out, there is Azure activity logs. See this here? How you are doing that? See, Azure activity, Azure monitor only. How you are doing that? See, everything is can be fine. Activity log going to be in Azure monitor, activity log, you can able to find it, these things. Then later, whatever you want to automate or whatever you want to, you can get it easily. See this here. Overview, activity logs, resource logs, diagnostic settings, everything I can do that. And then, so this is about the Azure Monitor part. Okay. So these all combinations, we are going to use it. Now, so we have understood about what is a computing, what is a networking, what is a storage, what is a security, and what is a monitoring. Just in the broader way, we have just understood that. Now, I wanted to create a virtual machine, for example. How can I do this? Okay, we'll take it up manually first, and then later, how we can able to automate it by using the CLI, by using the Terraform, and we'll talk about one by one. Does that make sense, right? Perfect. Okay, so if I ask you that how to create a virtual machine first of all, so definitely I want to see complete services list and all. What I need to do, friends, first step is you need to get into the Azure portal. Is nothing but portal login. So how can you do that? It's very straight away, right? If you just go here, see this, I have logged in straight away. We can get it. Meaning, just if you go here, sign into the part, go to the portal, it will ask that your account details, just like your mail ID, and see, you can get it straight away. So for that case, it is everything. This is the UI. So this is the user. Okay, and you'll get it everything, and you can see all the. So this is we can treat like a dashboard, and you can see that left side in this options, all services list going to be shown up. So here in Azure point of view, if you take it up, if you see this all like a services, see this all services. You can filter it, you can search it on whatever service, monitor service, database service. That we call it as a service. But once you create a virtual machine, that we call it as a resource. So two differences. Service is nothing but a facility. With that facility, I'm going to create a resource. It may be a virtual machine, it may be a VNet, it may be a AKS cluster, it may be a Docker container, anything. Good. Now, if you take it in this, all these different servers, see, I just discussed it, computing, networking, storage, going forward, databases, containers, web applications, blockchain, analytics, see, security, DevOps, migrate, monitor, Intune, so many things are there. Good. So after that, so virtual machine scales at app services. These are all like a computing services. See, so many computing services. Function app, Kubernetes service, app services, cloud sample nodes, all these are there. So you are able, so just assume that we are able to create an account, and we have seen that all this, the UI part. Okay. So after that, if I want to create it manually, the virtual machine, so like we have understood that virtual machine is nothing but what? What are the things are required? If I want to create a virtual machine, one is what operating system is required. Okay. What CPU is required. What is the memory you need to allocate it. Okay. And what network I need to allocate it also is important. And another important point is what? Which region you are going to choose it also important. Cool. This is about the VM creation. But in Azure, there is a logical group going to be there. That we call it as resource group. Just treat like it's a organization. Just treat like a group. I'm just creating the group. Within the group, I can able to see my all the resources which I have created. That we call it as a resource group. So resource group going to be there, region going to be there. Another one is subscription is also going to be take place. What level of subscription? There are multiple subscriptions going to be there according to your usage. That we are going to set it up. So if you take it in that front, can you see here? There is a resource group. See quickly. Create a resource group here. Now see that. Create a resource. All these are things going forward. I can do that right as a code, as a CLI, either code. But just manually, if you just understand, you'll get to know what I'm doing further. If I take it up as a CLI, either Terraform going forward. See this here. I have a subscription. I have a subscription. Can you see this here? You can go into that home page once again. See this here? Subscriptions. You can create it a number of subscriptions and see cost and all going to be takes place here. You can add, manage policies and all. See this here. Add. See this here? Pay as you go. Azure for students. Free trial. But I don't have here. See this? You're not eligible for this offer. But if you create it very first time, you'll get this free trial. And pay as you go. Whatever you're going to use it, you're going to get a bill for this. And Azure for Students is innovate, explore, drive your career with Azure credits plus popular free products for 12 months. That is offer going to be there, but you have to give your student ID and all the stuff, required information. Good. Okay, now go into the home page once again. That is about the subscriptions. Now I'm going to create a resource group. So you see, just simply create a resource group, give some name, that's all. And you have to create a user region, which region you want to create. See, multiple regions going to be there. All these are whatever I saw that in our graph list. See, all these are different regions. See, US, ES, East US, East US 2, South Central, West US, West US 3. All these are going to be takes place. You can choose any one, not a problem. And just give that. Say, for example, my demo. See, is going to show it up. This is there or not in our account. If it is there, it's account level. Then just simply say review and credit, or tag also you can give it some. Just like it's like a label to identify that how many resource groups are based on the label. We can identify that. Good. Now say review and create it. Now what is saying that whatever options you given, it's going to validate it. Nothing but it's going to parse it. Everything is okay. Then it will ask to create it. Good. We are able to create it. That's nice. Right? That is my demo. Now we are able to create it. Now if you click on this my demo, you can see that how many resources created and all under this resource group. You can get to know that. See, activity logs, access logs, tags, events, deployment, security, policies, properties, logs. All these are cost analysis, cost alerts, budgets. You can able to set it up everything for this resource group. That's what just like a conditions or quota you can treat like. That's nice. Okay, now once it is resources group, right? Now we can create it. Just go into that home page and you can say my demo and you can add the resource. See, I mean, this is like a resource group, right? Just go on the home page, see, create a resource straight away. Or else you can come down, you can, whatever service you want, you can search it out. See this virtual machine. If I say that, if I say search it out, you can able to get whatever service you need. See, virtual machines. So as part of that virtual machine, what you can do that? See, I can create it virtual machine. See this, add, click on it. Multiple options, virtual machine, start with preset configurations, all options going to be, you can explore it. And you can see in the before that, here in the right side, the bell, there is an icon, you can see that notifications. So creating resource group, my demo is subscription Azure, and you can go into that automatically. It's going to be this, we call it as what? More events in the activity log. If you click on it, you can able to find the activity logs here. See, update resource group succeeded 2 minutes ago. Okay, this is the first step. Now, once again, I can go into the home page, create a resource. See, we can search it out. VM, virtual machines. See, there are multiple services are there. Windows Server, Ubuntu, Web App, SQL Database, Function App, Azure Cosmos DB, Kubernetes, DevOps Center, all this storage account. I can do that. After that, if you go into the compute section, you will find a virtual machine and a virtual machine scale set. Nothing but what? Virtual machine only going to create a one standalone virtual machine. If I use it second one, it's going to be a load balancer. So scale set, what it does, it automatically creates if one particular threshold is reached. Scale set, scaling going to be takes place. Let's say virtual machine, can you see this, how we are doing that? Just go into the virtual machine here. Now see, just you have to fill it up. Basics, this networking management, advanced tags and review creation. See this. Just if you go step by step, you can get to know. If you just observe this, subscription one, we are using that. See, automatically you can find it our resource group. And the next level it is virtual machine name. You can give some name. Say my demo. I'm just going to give today's date, say June, for example. And as usual, region going to come up. So availability options, no infrastructure redundancy required. availability zones, availability sets. You can use these options as well. See, availability zone in the sense physically separate your resources within a Azure region. Nothing but two different things going to be used. Another one is availability set. Automatically distribute your VMs across multiple fault domains. See this here? Physically separate your resources within Azure region. Availability set is automatically distribute your VMs across multiple fault domains. Nothing but what? It's going to be a different, it's within the region, but this is a different region is going to be expressed. You can find it. If you want to get its differences straight away, availability set in Azure. See ya. Whatever your question, it's there. So while availability sets are used to protect applications from hardware failures within an Azure data center. So availability zones means what? Protect applications from complete Azure data center failures. Simple. Within the data center, two different racks going to be there. Your virtual machines. If I'm creating two virtual machines, if one rack fail, you also not a problem. Another rack can take it up. That is availability set. Nothing but within the data center. But availability zones means what? Within the region level. Two things. Within the zone, within the data center, within the region. Region will have a multiple data centers. So that's the difference. So meaning what? Availability zones nothing but within the region. Availability section says within the data center, you're going to physically divide it. So this here. Protect applications from hardware failures within Azure data center. But here, availability zones protect applications from complete Azure data center failure. If one data center is failure, is happened, for example, it can take it up, another one automatically pick it up. That is availability zone. But availability set in the sense within the data center, one is went offline also not problem, another rack can take it up. That's the difference. Yeah. Here, two buildings in the regions is nothing but complete data center itself. So that's what we have seen that here. Physically separate your resources within your region, automatically distribute your VMs across multiple, think or it's different racks. That's about physical, two different physical machines, you can say, three availability set in the sites. But I'm not doing anything that. So straight away by default option is going to be text. Good. And which operating system you want to use it? Ubuntu, Windows, anything. See, all images you can able to find it here. See here, whichever option you want to choose it, you can. Ubuntu, Debian, Windows Server, LAMP, CentOS. All these are different options going to be takes place. According to your requirement, you can choose it. For example, if I say Ubuntu default one, I can go with this. Or anything, you can choose it. So I'll step back, for example. So once again, if I go here and say I just given the my demo VM. Okay, so possible there. So just using this straight away, generation 1 2004 and Azure Spot instance. So what is this? Azure itself is providing that facility. Already ready-made images are there built in. We are using those images, but required softwares cannot be there in that. Good. And then we're going to choose it. The Spot instance is nothing but just like I need only just 1 minute, and I want to get less cost. Okay, just like a tender is going to be there, right? So according to that, if it is there is no much demand is there for resources purpose. So what they're going to offer, right? For example, you intend at, for example, restaurant, hotel, for example. Okay, there are a lot of rooms are there. If there is a huge demand, so there is no discount at all. But there is not at all demand will be there. So they're going to give an offer, right? With less cost, you can use one or two rooms, for example. Instead of I required only one, but I can able to go in a luxury way. I can able to get another one with less cost. So I can use it. So that is a Spot instance here. See, Azure Spot offers unused Azure capacity at a discounted rate versus pay-as-you-go prices. But workloads should be tolerant to infrastructure loss, as Azure may recall capacity for pay-as-you-go with our workloads. Simple, right? See, for example, you are onboarded in a hotel, for example. They provided options and discounts, but they're going to tell that if it is demand is there, immediately they're going to recover that part. So that Same way here also. But if it's less usage, just I'm going to spend 1 hour, so not required. I can go with that and spend it and then come out of that if not required. But if you require compulsorily, then spot instances cannot work out. Okay, just to reduce your cost, and it's a very, I mean, not important work that is, but still you want to do that, then go with the spot instances. But it's a sensitive work and security important, and compulsorily I have to execute it. I cannot use it spot instances. That's the purpose of using. Even in AWS also there that kind of facility. Good. Now next type. I said right, we are going to use memory and all these things, right? Memory, CPU and all. Here, these there options. 2 CPUs, 8 GB memory. So per month this much is going to be charged. It's going to take this. But of course, we are not going to pay for that. We are just going to use 1 hour. After that, we are going to delete it. So it won't be chargeable. Less cost going to be takes place. But there are multiple sizes also going to be there. You can check it out that if you want. See. And the standard B2S, 2 vCPUs, 4 GB memory. Okay, and this is the standard B1S, 1 CPU, 1 GB, only 546 per month. And recommended by image publishers, see, these all options are going to be 4 CPUs, 2 CPUs, and all. For example, if I choose it this one, you have to check it out that image. The size region-wise also going to be takes place. Sometimes region-wise that kind of options may there or may not be there also. Got it? Okay, so those things also we have to be considered. That's nice. And the next step is here authentication type, SSH public key or password based. Good. For example, here I can give it, say, my demo user is my username, and then I can give a password. Same thing, I'll try to give it my demo user at 1 2 3 4 5. Same thing I'm just giving my demo user at 1 2 3 4 5. This is one way of doing that. Okay, good. And so once that this is very important, security. So this virtual machine, who is going to access? See, select which virtual machine network ports are accessible from public internet. You can specify more limited or granular network access to the networking tab. Good. Now see this here. Public inbound ports, I'm allocating 22 because I'm going to access through SSH port number. So I have to use 22. If I'm not enable this, you cannot able to access this. This will allow all IP addresses to access your virtual machine. Okay. And also see this here, use the advanced controls in the networking tab to create rules to limit inbound traffic to known IP addresses. And say next, disks. And see how much disk do you want to allocate it. It's a disk space. See here. So minimum will be there 30 GB. Okay. So we have chosen previously the CPU and RAM size, but here disk size. That is for to work on it regularly. I mean temporary cache required. For that case, CPU and RAM is required. And then whatever you want to store your files explicitly, the disk is important. Disk treat like it's in a hard disk. Okay, and the disk type premium. There are multiple types going to be there. Each and everything, if you read about, you can get to know that as part of the usage according to the requirement. Good. And then encryption type at rest with a perform managed by key. You can encrypt this also. And compatibilities, all our options going to be used. How safely you want to do that. And see this here. You can add and configure additional data disks also. Even you delete the virtual machine, you can separate it your disk. Your data cannot be lost. See this here. You can add and configure additional data disk for your virtual machine or attach existing disks, and this VMs also comes with a temporary disk. And see this here. Create and attach a new disk or attach an existing disk, and then come down. So there is an advanced. All these are options are going to take place. And then networking. So disk level, nothing but storage level we have allocated. Now see, networking. Nothing but VNet, virtual network. So this here, by default, automatically create a my demo VNet. Or else you can, if it is already, if it is there, I mean, of course, by default it's creating. But if it is already exists, automatically show it up here. Let's see that. I mean, automatically create. We'll see that what properties are going to see. It's a VNet and subnet. That's what I'm going to create a range of IPs. Under that range of IPs, I'm going to create a multiple groups that we called as a subnet groups. We called as private public subnets. So see here, subnet. So treat just like a, for example, you are going to create 100 IP addresses. From that, 50 IPs for one subnet group, another 150 IP addresses for another group. That is nothing but a subnet. It is also going to create it. And we need to select it one IP address from this subnet. I need to allocate one IP address to my virtual machine to reach that virtual machine, to connect that virtual machine. See, my demo VM automatically creating. And the next level it is, see, NIC network security group. See, we have allocated 22 port number, but if you want some other groups, if you want to allocate it, you want to allocate a permissions for port enablement. For example, I'm deployed Tomcat, I'm deployed IAS servers. So whatever port is required for to access that server, the service, we are going to restrict with the security group. Good. And public inbound ports. See here. So you said right there itself in the this section it is said you can check it out in the network side what ports you want to allocate it. Yeah, good. And see this one more. You can place the virtual machine in a backend pool of existing Azure load balancing solution. Place this virtual machine behind an existing load balancing solution. But I don't have right now. If I use a scale set, yes, this will be, you have to enable it. Okay, good. So VNet is just like an organization. On top of it, I can create a multiple groups. That is nothing but a subnet. Okay, push note. Yeah. And then simply next step you are going to take it up. Management. So this here. Your subscription is protected Azure Security Center basic plan. See, security automatically. Okay, monitoring, enable with managed storage account recommended. Or else you can also disable. You don't want to monitor, for example. But if you want to do that, you should enable it. Boot diagnostics. Okay, I'm not doing that right now. And enable OS guest diagnostics. No, I don't want. System assigned managed identity. Azure AD. I'm not doing that part. Okay, so RBAC role assignment of virtual machine administrator login or virtual machine user login is required when using Azure AD login. And then auto shutdown, enable auto shutdown series, configure your virtual machine to automatically shut down daily. And backup, enable to guard your virtual machine against accidental deletion and corruption. We can recommend that you configure backup on this virtual machine. Here, your virtual machine will be backed up to recovery services vault with the configured policy and will be charged as per backup pricing. So these all facilities can be provided by this virtual machine service. Okay, another important thing, patch orchestration options also can be do that, image default and all. See. Meaning automatically going to be, if any updates are going to be takes place as part of that image, it's going to be updated here in this virtual machine for security reasons. That's nice. Okay, the next level it is advanced section. This is quite interesting. Anybody can suggest what is this custom data and cloud in it? And series extensions provide post deployment configuration and automation. So can I say a bootstrapable scripts, right? It's nothing but bootstrap scripts. So this pass a cloud init script configuration file, and so that automatically required configuration going to be takes place, right? So you can add anything. You can add the scripts, you can add the files, you can add the configuration, I mean, shell scripts or anything, or shell scripts, anything, so that it can be automatically load. Okay, that's nice. Okay, all these options you can, which host group you want to use it, placement group you can use options. Okay, so generation, see this here, there are different types of generations. Generation 2 VM support features such as UEFI based boot architecture, increased memory, OS disk commits limits, something. I mean, so in the backend side, how much, what kind of memory remote and all, if you want to use it, we are going to use that. Okay, and then say tax. If you want to separate it, if you want to check it out, how many resources created for dev, how much charges are going to be take place, how much amount is taking place for one dev environment. based on these tags, I can able to calculate it. Am I right? For billing purpose or separating purpose. So review and create it. So if whatever you have chosen, if it is everything is okay, then it's going to tell that okay. So validation is fast. If something which is not feasible, you have entered the data, so it's going to validate it. Now see this here. Per hour, how much taking place? 0.7493 credits. Apply. Good. Now name, preferred, all these things are going to be taken up. What is this about? Terms. By clicking create, agree to the legal terms of the privacy statement associated with the marketplace offerings. All these are we are going to use it. Okay, so this create. So it's going to take a while. See this here, it's going on. Submitting deployment. Good. So it is created. See this. You can find it. See your deployment is complete. And create VM and all. See, and go to resource. See that your resource is created. The virtual machine. And out of that, this is public IP address, virtual network. All these options are here, whatever you have chosen. Now, if you go into the home page once again, if you go into the resource groups, see this, we have created my demo. Under that my net demo, and you can find it all the resources which you have created on this. See, disk network interface created, network security group is created, a public IP address created, virtual machine is created, virtual network also created. If you go into this virtual network, just click on it, my demo VNet. See, virtual network. And out of that, you can see that all the things like activity logs and access control. So we have not added anything. So default is no options. Okay. And you can see tags, are there anything? No. And you can see the diagnose and solve problems. If anything, it's going to show it up, explore the most common problems and all. It's going to tell it, but nothing will be there because we just created. But out of that, left side things are very important. See in the settings section. See, address space. So this VNet is going to be used, this range of IPs can be created. Nothing but 2 power of 16 IPs can be created. See this is the count. Out of that, connected devices, our virtual machine. So this my DMV, my demo VM connected this VNet. Another one, how many subnets are created? So this, so default. So this is the IPv4 range 24 series. 16 and then 24 means what? 2 power of 12. 2 power of 12 IPs can be created. So it's 250 for this subnet. And any DDoS protection is there or not? That's what firewalls. So protect your public IP resources in the virtual network from distributed denial of service attacks. Disabled as of now. But if you enable it, so I know my resource ID and DDoS protection plan, you have to allocate it, create a DDoS plan and all you have to, it's going to be chargeable. And firewalls, so that it can be restricted. Security. So security center going to be there. The cloud security posture management, all these are things are going to be there as part of that. Okay, good. And DNS servers, nothing but domain name service. It's going to give some domain name. So default is Azure provided. You can also create your own domain, something like a google.com. I mean, not exactly google.com. That is public domain is going to provide public DNS, but this is internal DS servers. Cool. And the peerings also I can able to do that in the VNet level. Nothing but what? Just assume that 2 VNets, nothing but assume that 2 buildings, 2 B sides are there. Okay. Normally, if I want to access, if I want to go into one building, I can go with the gate, right? Then I can able to access it, that building. In another building, if I want to go with that, then same, I have to go with the same gate. I mean, another gate, whatever have the building, and then we're going to take it. But these 2 buildings, people need to communicate each other, for example, without authentication, without gateway. So then we can go with the peering. But in between, I'm going to establish a tunnel. Whoever have authenticated one building, other people can, I mean, other building can be enabled to authenticate. I mean, access it. So these all going to be used here. On top of that, monitoring, task, diagnostics, cost, and all going to be shown up over here. Good. Now, if I go into this once again, my demo, this is the VNet is going to be there. See, same public IPs, networks. So this is very important security group. See, network security group. It's a separate group. So this security group, you can allocate it to your virtual machine level, subnet level, or VNet level. Cool. So after that, see how we are going to use it. See this. Okay, now this is going to be text. See here, there is a priority going to be there. So inbound security out of this, if it is a less number in the sense top priority. So 300 is going to be a top priority. Next level, these are see allow VNet inbound, allow Azure load balancer, deny. So different ports I'm going to enable. Allow, deny. So denying all inbound rules. For example, if I'm deleted this one, for example, inbound rules, nothing but whoever is want to access my IP, is in virtual machine, they need to get permission here. We need to allow here. Your group or your authentication is enabled here. Okay, your permissions are enabled here in a group level. You can able to get authentication here. Good. Then outbound security rules also there. See this here. Outbound in the sense I'm going to reach out to another service, another component. That is outbound. So outbound is you can enable it, right? It's not a problem. All traffic you can enable it. So I need to defend it. Who is going to be access my service? But I'm accessing to other services. It's not required to restrict it. That's the reason outbound security rule is going to be always allow. See this here, allow. So sometimes this one we call it as ingress, egress. Ingress in the sense I'm receiving the traffic. Egress in the sense I'm sending the traffic to another resource.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Inbound, outbound. It's important part. So this security group, see this inbound security rules, outbound security rules. You can allocate it, internet interfaces. See this, we can associate it. Right now, it is associated with your our virtual machine. If you take the subnets, see no results. So even I can do that. I can remove it. This one I can associate with the subnets also. So this, I can associate it. I'll just give a virtual network. See, my virtual network is demo net. See, automatically load default. If I say this, okay, automatically going to be allocated subnet level, this group. See this, allocated. If you don't want, just come down, deassociate it. That's all. So network security group is a separate entity. So whatever permissions, either individual virtual machine level or group level, we can able to allocate it. Good. And even sometimes we are going to, instead of unfortunately, unintentionally, sometimes we are going to delete it. Just click on the button, but we are not doing it. Just it's happened to the delete button. So we can lock it also. We can enable the locks. So that is also we can able to do that. Now, if I go into this, my demo, and if you check it out, the virtual machine here, so this here, virtual machine, click on it, a virtual machine. I can connect it. See, multiple options. So remote desktop protocol, bash and SSH. Three options are there to connect the virtual machine. I can say SSH. Okay, now see here. If I have public private keys, I can get it this way. But I don't have this public private keys. Right? So for that case, what I need to do that, I'll take this IP address with user, just go into the terminal. I'm using Mac machine, so I can get a Linux terminal. If it is a Windows machine, you can use Git bash shell if it is a Linux server. Or else you can install RDP if it is a Windows remote desktop protocol tool. And then simply say SSH, use this. See, it is asking. Yes, I want to connect it. It will ask the password. See, But if I would have created username and sorry, public private key, see, I can give -I private key path. With that, I can able to create it. Good. Now you can see here. So you can enter the password. So what we have given password. So I just given same demo user @12345 I have given. If everything is correct, I can able to connect it. Super. We are able to connect to this machine. Nice. Now whatever I want, I can do that. If I want to switch to the root user, I can switch to the root user. I am in the root user. So these all Linux commands we can use it. So till now, whatever we created virtual machines with a VNet, with security group, and with virtual machine with internet, network interface. So network interface is nothing but what? We are allocating the IP address with this. Is public IP is allocated and network interface. So out of that, see everything. Try to do that each and every resource settings option. Okay, settings. This is treat like a metadata, your actual specification, and monitoring part. And if you want to show some automations and other things, going to be there in the down. See, very well, maintain the menu, the left side. So top one will tell about the metadata, settings in the sense the configuration, monitoring, automation. Okay, if you take in the network interface is nothing but what? It's going to allocate a network to your VM. So if you see that IP configuration, DNS servers, network security group is allocated. Nothing but network part. So this what IP configuration is taking place. See, IP config 1, IPv4 primary. So this public private IPs are created. Fine? Great. Good. Now, the next part is if you check it out here. DNS server. See, it's created DNS server. So inherit from virtual network, custom applied, but nothing is allocated. And network security group, whatever we have allocated this here, it's going to tell us, see, it's allocated network security group. That we have seen that already. Good. What about these properties? Can you share that? Yes. Information about. That's great. So this the one we have done. Now we are just connected, right? So I want to same thing. I want to do that through CLI. So just till now we have done just through a console. But same thing I want to be within minutes. I want to be within seconds. I want to use it. I don't want to go these options one by one selecting and all. So for that case, we are going to use a CLI part. See that how it is going to be used as a command line interface. So for that case, if you just go here, if you want to create it a CLI, there are two things, friends. I can do that from my local machine or directly to Azure from the Azure Cloud CLI also you can use it. Yes, if you see that in the Cloud CLI, if you go here, see there is option Cloud Shell. Here itself I can able to get a Cloud Shell. See this. I'm going to use it, but it is going to create a one storage temporary account. Just create it. See, Azure Cloud Shell requires an Azure file share to persist files. So this will create a new storage account automatically creating this for you, and this will incur a small monthly cost. And it's going to create it. Good. See that. There are multiple options going to be there. You can able to use a PowerShell, or else you can also use Bash Shell. See, just use it, whichever you're comfortable. So it's a very good feature. Straight away, they're providing browser level itself, they're providing the terminal. And see this, PWD. And you can see that which AZ. Again, you can extract it from, instead of using here itself, you can say, make it out bigger size. And you can do here itself everything from the CLI. And you can see, but for that case, if you're using CLI in the sense I need to use a command. For that case, we are going to use AZ is a utility command. AZ is a utility CLI command. We are going to, with that utility command, I can able to create a number of resources, whatever created. For that case, we are going to use option series. All see, manage Linux Windows virtual machines by using automatically VM. I can create a resource group. You can see that resource group. manage Azure resources. You can create a resource group option going to be there. You can find somewhere. So this manage resource groups and template deployments. That's one thing. Straight away we can use it from here, or else we can do that from our local. So if I take it up another terminal, say for example, I'm just taking different color for just identification. See here. Can you see this? Here itself I can able to get it. See which AZ. Even in our terminal, whatever we are doing that here, right? I can able to get here also which AZ. I can able to use it, but it's not there here. But if you check it out in my local, I have installed. I can able to get the authentication, right? If I have a utility command, but I need to connect to my account. So for that case, we are going to use login, AZ login command. If I say that, see, automatically it will open the browser and I should able to give my details. See, automatically get up. You have lagged into the Microsoft Azure. Now you can close this window. We will redirect to Azure CLI documents in 10 seconds. See, you can set it up, install Azure CLI for Windows, Mac, Linux, and all. I'll show it up this one, but can you see this here? We got that right? See, my account is connected. So now I can able to perform anything now onwards from here itself in the terminal, from my local machine itself. Or if you want to do from, for example, we have created Windows, Mac, Docker, anything, here, or Cloud Shell. We have already opened this Cloud Shell here. Cloud Shell, RHL, Ubuntu, SUSE, script, anything. For example, right now it's on our case Ubuntu. Yes, that's going to be simple. With one command, it's going to. Multiple commands, if you want to do that, you can use these options. You'll get it. See, Azure CLI. You'll get it automatically, AZ login command. But if I do this same command with single step, it's going to take it up. It's nothing but they have written some script. If I do here in our virtual machine which we have created, you can get it. Now it's taking. It's done. Now can you see this? Which AZ? I got AZ command, our newly created virtual machine. And I can say AZ login. See, it cannot directly redirect to our browser because it's a CLI command. It's a CLI server. In my local, I have done, if I do here, AZ login, it is automatically open the browser because I'm in the local. But this is a virtual machine. There is no UI for this virtual machine. It's a CLI based one. So what it is saying that copy this one, device login, and enter the code, authentication purpose. Now just see that the differences. Because here it is not able to open the browser. That's the reason the provided option here. I need to open. I'll just take it up all these links, delete it. Okay. And you can open this link, enter. You can see just now, hit it. See code, your device code. So device code is here. See, take this device code and you can get it here and say next. You got it? Now see, it's pointing. If I say this one, automatically you'll get authentication over there. See, platform command line into you have signed into Microsoft Azure Cloud. You can see this. You'll get it automatically because I'm authenticated with this device. Now I'm able to communicate it. And now I can AZ, VM. You can check it out, help. Everything, try to use it help. You can get to know. Okay, now you can see this here. I said AZ, VM, and what are the options are there? See, availability set, boot diagnostics, all parameters you can give it. Commands, capture, delete, list IP addresses associated with a VM, sizes, all I can able to get it straight away. Now, if I say AZ VM list, how many are created? How can I get to know that? If I say that, what will happen? Will see that? Yeah, we got it. For example, if you have a multiple resources groups, then so you can also give this way also. Okay, take help and some more options also you can get it. See this, list all VMs and list all VMs by a resource group. You can see this here. You can use -G nothing but a group, resource group. My resource group is nothing but a demo. I can guess it. See, the resource group demo, because only we have it's creating all the information. Nothing but metadata information it is showing. Good. For example, if you want to create it separately with this AZ command itself, straight away, friends, you can able to get it here itself. You can come down, say this way, create VM in Azure CLI. See, you can get it everything from here itself. See, launch Azure Cloud Shell, or you can use it our own cloud. I mean, AZ command, and see this how to create it. Just observe this. So what you have to do that AZ group create name my resource group. You have to give it automatically going to create it. But where we are going that East US. But right now, where we have used here in our case, can you search it out? Option my demo. See East US only. Okay, so for example, AZ group create hyphen name. I can give my demo, same name. What will happen? We'll see that. Then hyphen location East US. This is the way it's going to be takes place. Now just check it out. What will happen? See, the following arguments are required. I'm sorry, it's a typo mistake. Location. Now see that. It's already there. But if I give it different name, for example, instead of demo 1, I can give it, or demo V1. So that's automatically going to create it. You can find it. See, it's created. If you go here, go into our watch part, okay, and just make it here, and you can go into the resource groups. Just refresh it here. See, it's not yet created, but it's going to create it very soon. Just refresh it. See, my demo V1. Got it right? Okay, cool. Cool. So once it is created, what are the next steps? I need to create a VM. For that case, see, it's very simple. Whatever options we have selected, we are just passing as a parameter. See, resource group we are passing, name we are passing, what name you want to give it, and image you are giving, and say username. And you can able to pass it up. So this, you will need to supply a password that meets the password requirements for Azure VMs. Using the example below, you will be prompted to enter the password at command line. And you could also add the admin parameter with a value of your password. That is also possible. And you can open the port explicitly for this resource group, for this name and port number. And if you want to connect that virtual machine, so this is how you are going to do this. Automatically can get it. That's nice. Okay, good. And if you want to delete it straight away, we can delete it. Okay. Now, if I take it in that front, so if I want to create it, I can simply use this. Okay. So just take this content. Okay, I'm just copying here quickly just to change the required parameters, right? We have to convert it our part. So just take it as this. Okay, cool. The first one, what you have used, my resource group I have used here. Okay, if you don't want to this is like a Windows machine, Win 2006 data center, or else we can also use, if you check it up this example. So what we have used here, can you take it up that image name, virtual machine, manage disk, image reference, canonical, image reference is this getting right? Okay. Okay, let it be. Same thing I want to use it. It's okay. We'll see that same thing. But only I need to modify here. So Azure user is okay. Name is also okay. You can give it, not a problem, but you can give this my demo 1. This we have given my demo V1. V1. You can see this. From straight away from here itself. My demo V1, we can use it here. This much. Then take it up straight away. Can you try it out? Is going to create or not? We can create it also. It's asking password. Okay, my demo V1 user at 1, 2, 3, 4, 5, something blah blah. I'm just giving. See that, right? It's going to create it. See that it's created straight away. Now you can find it here, and if you go into that my demo v1, you can see that all are those options. See, it's all created. See how simple it is, right? To create it. See, this is a virtual machine. Now you can connect it. Okay, just see, this is a connect option. So you can use it as such. Is there anything options? You can get to know that. Okay, and then we have just created. But if I want to delete it quickly, for example, simply az group delete. You can give a name. See, hyphen name is expecting. So what you want to do that? Just give a name, my demo v1. That's all. I'm going to say yes. It's going to take a while. Then it's automatically going to be deleted. So complete entire group itself with the virtual machines, whatever resources are created under this, is going to be deleted. Everything is going to be deleted. If you refresh it, the refresh button is here. It's going to take little time to delete it. So whatever you want to create it, okay, we can able to do that through CLI commands. So for that case, how to understand how to get it to that commands list and the syntax and all, it's very straight away. You can get it. If you see that multiple commands options going to be there, and if I say VM and take help, you'll get it all the options VM sub commands. You can see that. You can stop, you can delete it, you can reapply, you can redeploy. All these are options are going to be used. You have to prepare it as a command. Good. Okay.
Now we are going to talk about ACR. But if I want to create a ACR through Terraform, how can you do this? Simple, right? It's just a resource. Same as this, just like this part. If you come down here, just like we have used here, resource. Same way we are going to create that relevant resource. You can come down, you can search it out, you can find it. ACR Terraform. Just do this way. This here, Azure Container Registry. Straight away we can get it. Now see here. This is your resource group. Of course, we have that. Now see this, friends. What we are doing that? We are creating Azure RM Container Registry. The Container Registry 1, resource group name, location, SKU, admin enabled, geolocations. So these are all parameters. So with encryption also they are adding. So this is for encryption purpose. Just see that here. Both are same. Azure Container Registry, same thing. Name, resource group name, location, SKU, is nothing but a premium, and identity and encryption is also going to be enabled to make it more secure. And that one we are going to do multiple things like resource, data, other stuff. I'll talk about Azure Key Vault Key. What is this about? Nothing but I can able to access with vault keys. Nothing but secret keys, super secret. This super secret we are going to use it. But just simply one, see, Azure Container Registry. Name, resource group name, location, SKU, admin enabled, geolocation. Look, we can do this. Okay, is this push operation there or not? Can you check it out? Docker push? I don't think so. It can be enabled here. No, it won't be. That is a different one. That you have to do that explicitly. Docker push command. That time you have to use something local-exec command. We can do that as well. But here, see this here. If I use this, for example, what is going to take? It's going to create a container registry 1. It's going to create one registry 1, and the resource group name, location, it's going to be pointed based on this part, example resources. For example, if I take it up this example as it is, you can come down, you can create it our main.tf file, same file. You can come down, okay, but there are 2 times will be the resource group, so that I don't want. So just delete this. Second one will be I'm deleting. Cool. And here what I have to do that resource group name dot rg dot name rg dot location. It's okay. Both are same. Only what is going to be there here? You can see here container registry demo. I can give it. You get it automatically. This. Okay, and then just save this. Now you can apply it automatically, right? Terraform as usual, init, good, and then plan, say -out, say pf plan, good, right? Now I can apply it. This is going to create or not, let me see that. So what it is saying that container registry demo used for the container is need to be globally unique. It should be unique, is not available. The registry cannot contain demo is already in use. Okay, so you can come down, say open this file, just modify it. Where it is? Yes, yeah. I can give to date 09/06/21. Okay, I just given different name, and now you can once again plan it because it's based on the PF plan only going to be takes place. Okay, good. Now you can apply it. Now see this here, created. See, container registry is created. Now if you go here and you can come down, say ACR, nothing but registry. You can search it out. Container registry is there. See this. The container registry, see this here? It's created. My first resource group. Now if you go here, say for example, whatever we pushed it over there. I mean, we have created image. I can able to use this. I can able to push it here. See this here. If I want to use this, what I have to do? So this is the registry. Then if I want to connect it, ACR build, run, push and patch containers in Azure, ACR task, this part. But for that case, what I have to do? There is an instructions going to be there. Say access keys, encryption, repositories. See this here? It's not there, right? Okay, just give me one more. If you go here, take it up this selection, refresh it here, just click on it, you will get a URL. Overview we are getting. Okay, see login server, resource group, subscription, premium, and included SKU. Okay, cool. Just give me steps wise. If I want to connect, if I want to push my data, there is a URL going to be there. It's going to provide. If I want to do that, just click on this overview. You can get it. So this ACR task scenarios, quick start, and schedule, multi-step task, context. All these things are there, right? This here, build, push, and run image CLI. So this is the one we are just. So this is we have created. Now we have created this example. This is created. Nothing but our Terraform is created this part. Then build and push in the sense. For example, we are going to use a Docker file and we are going to build it. It's going to create a Docker image like this. It's going to create a one Docker image. Then ACR run registry command. You are going to run it. Same like I have done, right? Docker run command. We can also do this one. ACR. The following example use registry to specify the registry where you run the command. Okay, and it's going to start it, your application. And then it's going to delete it, right? But I want to be push, right? Where it is pushing things, you can see a run image, Docker, I mean ACR build, just overview only, right? And then the overview. See here, container is this one, my registry and Docker file. It's going to build it, but I want to be push, right? Just a minute. What is doing this one? Okay, my container registry, it is automatically taking, say this run dependency, run ID was successfully after 10 seconds and is going to use it. See registry sample hello world.v1. So this command is doing that work, but we are not building, right? We are not building that, but through AZ command is doing that. But if you want to create a container, this is the way we are doing right now. We have done this ACR create, log into the registry. See, you have to log into the registry, ACR login, and then push this part. So this is the way we have to do that. Now for that case, what I have to do, I'll just take this because anyway in my local it is already there. I'll just need to take it up another terminal. Okay, so say Docker images, for example, we have already Terraform. Now see this here, Docker ACR login -name. What I have to do, registry name. What registry name we have given here? If you see here, the registry name is what we have given. This is the one. because it's a globally unique. That's the reason it's thrown an error. So it can able to identify that. Yes. Cool. Login succeeded. Nothing but I'm able to authenticate it. Now I need to Docker tag, use this existing one image and take this name. See this mcrmicrosoft.com hello world. We are using login succeeded and Docker pull, and you have to use this login server / hello world.v1. So it's nothing but this is the one. So for that case, we have to use this login server. So login server / our image name colon. You can give any version, but I can give 1.000. Okay. Now see this here. Tag going to be created. If you see the Docker images, we'll get it, right? Now I can able to push it. How can I push it? Docker push command also can work. Or what is this guy saying that? You can use, see, Docker push. Because we are authenticated now. So Docker push, what I need to do that? I need to use this URL. Colon 1.00. Now see this. Okay. It is pushing. It's too much of space, huh? 1.4 GB. Oh my God. We would have given small one, actually, right? This one we would have given. It's better. Instead of doing this, I'll do one thing. Instead of taking too much of time, right? So just Control C. I'll just stop it. Okay. I can Docker tag. I'll remove this. Docker rm rmi. Docker rmi means what? Removing the image with colon what? 1.00. Okay. Untag. That's okay. Now what I want to tag it? Small one I want to tag it. So this one I want to tag it. So Docker tag, use this. Nothing but I'm just taking the same name with a different image just for sample purpose. Okay. Now you can see this Docker images. It's a less size, right? This is the one, just 106 MB. It's okay. Now I have to push it. So it will be very quick. Does not exist container registry. I think latest, right? Yeah. It's not required. Yeah, you can use this. By default, it's going to take a latest. Yeah. Okay. This is really good. It can be done. No problem. So if you go here, you can able to find that registry, and you can refresh it. Access key, identity, repositories. You can able to find that part. Workbooks, applications, tasks, tokens, content trust, automation. Just see this. Tags are there or not? Let me see that. It's not yet pushed. Okay, now it's pushed, right? Okay, just refresh it. Okay, now this is the part. Good. Just go into this tab. Container registry, no changes. How can I get it? This quite interesting. Overview. Okay, latest we got. This is the URL we have to use, and source group change subscription. No, something it is missing. I'm missing something. The URL going to be get it. Services. See this. Now we got it. So this is the repository. See, latest version. If you click on this latest, see, this is the way it's going to be text. So this is the URL you are going to use it. Docker pull. Got it? Docker pull container registry demo Azure Terraform latest going to be text. Now if you do that, I can able to get a Terraform image. So this is the one. But I want to do that. So quite interesting. Half part we have done automated fashion, nothing but through Terraform. But remaining part is right. What we have done, remaining part is nothing but Docker push, Docker AZACR login command. So this is the command I have used. Second command. First, after creating the Docker registry through Terraform, I have executed this one so that I can get the authentication. After that, I have used the Docker tag command. This Docker tag command. Okay. Now, anybody suggest me if I run a Terraform apply command, should able to do these activities also. I mean to say here I should able to, before tagging, I should, if it is not there, that image, it will be thrown an error. I should be able to do this one as well. Docker pull, something simple one, Alpine I can give it. A very lightweight image. So I want to take it up this one also as a Azure tag with this Alpine here, I can give it. Okay, and this is also Alpine. And this is also Alpine. I want to create as a Alpine, I want to push it. If I want to do this one as well through Terraform, how can I do this? Anybody? Through Terraform only I want to do that. Nothing but some extra commands I have to perform through Terraform once it is created this here. Nothing but what? Here we have main.tf file. Here we are the registry, but only registry is creating. But how about creation? I mean, a Docker image push into this registry. That normally Ansible can do that, and the Jenkins can do that, and Azure DevOps can do that. But how about Terraform? How if I want to do that through Terraform, for example? So for that case, maybe I have to check it out. Is there any resource, or is there any provisioner to do this activity? Yes, there is one resource will be there. That resource is nothing but a null resource in Terraform. See this null resource. You can see that what we can do that with this null resource. Good friends, see this AWS instance is doing something. Can you see here? Resource, null resource, cluster, and the triggers whenever it is created, and connection, and is doing remote connection. It is executing something on top of the EC2. It is executing bootstrap cluster data sh. In the same way, there is a null data source is also there. It's fine, but I want to use this part. There's a one resource called local_ex resource Terraform. So local exec Terraform will be there. Can you see this? With this, I can able to provision, right? It is installing something in the sense, it's nothing but I have to run some shell commands or whatever commands you want to do that through this local exec. So definitely this local exec is going to be there. If you go into in a project, if you check it out, any one code Terraform scripts, somewhere you can find this local exec or remote exec. That's what we just understood here. Remote exec. See here, there is a remote exe. So what is this one? It's going to execute something. See this bootstrap script called with private IP of each node in the cluster. This is a different one. I have another example. If you come down here, just take this example. I have already shared this document. You can find it something called data sources main.tf file. See here, resource, null resource. Same thing. But I want to be used local. See here, same null resource only, but the local exec command will be there. See this here, command. In the null resource is nothing but what? It cannot create any resource. Meaning here it is, for example, if you take it here, multiple resources are there. Nothing but it's going to create one resource in an Azure side. Null resource means what? It cannot create any resource. It just execute whatever command you are going to give it here. Interpreter is PowerShell and a command. You can able to give your shell part, so that if I copy this one, it can able to execute it. Okay, so now same thing right here also you can find it local exec. Just now we saw that here local exec. You can find it. See, local provisioner, local exec command, some command you can give it. You can give multiple commands here. Interpreter is optional, working directory is optional, command is required. See, yesterday we have one of friend is asked about like what are the parameters are there. See, environment is optional. And another interpreter example, see this resource, null resource, provisioner, command, PowerShell. And this is an AWS instance. Okay, it is using AWS here at the top. It's okay. Now you can see that you can execute it and it will going to use some environment. Good. Is this clear, right? So here interpreters is not required. You can give it our commands. It will going to be takes place or not. We'll see that. Okay. Shall we try this one? Same thing. Here also it's there. Same thing. So I'll just take it up this as usual, we can go into our code here, right? In the main.tf file, everything is in a single file. It's absolutely no problem. While testing time, so whenever you got a requirement, first do just single with the main.tf file, quickly test it, is that working or not, check it out. Then you can do that customization. Always recommended, friends, now onwards. Okay, so it's better, easily we can able to get, first you will get a confident. For example, whatever task is provided, if you do that a hard-coded way, if it is working fine, we are good. Customization is not a big deal. If you ask anybody also can help, or you can try it out. If you take little time and you can show it out. Because you have done already actual task. Core engineering you have done, core task. Later customizations. Good. Now if I take it up here, I'm just copying this content. You can give it here Docker. I'm just giving some name, simple. Instead of doing the time now, I can use Docker execution or a Docker push. I'm just giving that, or a Docker CMDs, local execution. So interpreter is not required, optional. So I can give it delete. Anyway, in my local, I have a AZ command because it is going to be execute in a local, in the current directory, in the current mission. Wherever I'm executing Terraform, there only it's going to be executed. So local execution and a command section, what I need to do, friends? Whatever I have executed here, these commands. The first step I'll try quickly. Say Docker AZ login, this part I can take it up because same one we have used in it, right?
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Come down here, same thing, right? Same thing. So only I have to come here. I'll just take it up this command. Next step, friends. I want to do that multiple commands. Ampersand. That's what second command. What is the second command? I should use Docker pull command. Docker pull alfine. So it's going to take very less time going to be takes place. So for that case, I can come down Docker pull alfine, the basic one. Then ampersand Docker tag and take this name as usual. Docker tag we have used here. See this one, and you can get it here. Good, very basic things. And then say alfine latest. It's going to tag it. After that, I can give it one more ampersand, nothing but another command. What I need to do that, I should be able to push it, right? See this Docker push command, I should be able to take it up. Docker push up to this level, I can take it up. If everything is correct, it's going to alfine latest, because this image is going to be pushed. Good. Now just save this. So before applying that, I want to, because here already we have Terraform, right? So Terraform, I should say destroy based on the, okay. So Terraform required plugin going to be downloaded. Null, see this. Null is downloaded. Okay. Now say first destroy it. It's going to tell that what are the things are there. So tag command is used for renaming. Tag is just alias name. It's just like a alias name. It's a Docker tag. For example, you have some ABC, right? If you want to give a different name, you can give XYZ. ABC alias name with XYZ. Okay. Yes. Now see this here. It's destroying now. Okay. Still destroying. Can check it out. Refresh it. Yeah, it's gone now. It's deleted. Right? See this. Done. Destroy complete resource to destroyed. Okay, now let's take it up. I have done already in it, of course, but still I'm doing. Good. Next step is I have to say plan out. Okay, got it. Before that, can you see this series is just done, right? So null resource is executed. Resource null resource backend known for after apply plan 3 added. Now you can see here, so local execution and warning. So provisioning with the local exec, you may want to use AZ login this part expose token to get an access token which does not require Docker to be installed. Okay, you cannot require to install a Docker client. Okay, an error occurred, Docker command error. Please verify if Docker client is installed and running and creating, and it's going to take it up. Let's see that what will happen. What it is saying that local exec provisioner error. What it is saying that with null resource Docker CMD on main.f line 35 provisioner error running az acr login this and docker pull alfine docker tag. So what it is saying that exist status output you may want to use az acr login -n expose token to get an access token which does not require Docker to be installed. Okay, I can take it up this value. We can modify this. Maybe this is the way we have to work on it. So just come down. I think that is expose token. If I do that, fair enough. I think I have to give full path also. Docker full path, but let it be, not a problem. Now you can say Terraform plan out. Okay, plan one to add, one to change, one to destroy. Okay, and say access token we got it. Login server, good. But Docker not found. See this? There is a command problem. It's okay. We can give that full path. So Docker command only the problem. Okay, not an issue. Which Docker? Got it. The problem is we cannot able to install Docker here, right? Makes sense, right? So this script I have to do from my local machine instead of here. So for that case, what I have to do, say first you can say destroy. Got it right? What is the problem? If you want to do that, say vi main.tf file. Okay, before that I just want to copy. Is this done? Vi main.tf file. Let me try this first. Okay, I'll show it up that as well. Okay, so Terraform and say out -out tf plan. I'm sorry, plan I have to give it. You can get it. Good. Now you can see this here. Apply. It's going to be text based. Cool. Now, if I take it in the Docker container itself, if I want to do that, so these all things are not required, right? Yes, it's a simple file I want to create it. The main.tf file. These all things are not required. Resource groups and all. It has no dependency for this. So local resource means what? In the current machine only it's going to be executed. Okay, cool. In this, I'm going to give simple echo hello world. Okay, simple echo hello world, and I'll create a file. Echo hello world, and then simply say a.text file. Going to be created or not? Let me see that. Okay, and then simply say Terraform plan. What is saying that one file is going to be created. Now you can say apply it. I'm doing in the Docker container. Now see this. Executed. See how simple it is. It's executed successfully. You can find it a.text file is created or not. See, a.text file is created. You can find that what content is there. This hello world. Getting right? We are trying that one. But here in the Docker command, which Docker is not there. That's the reason it's a problem. Let me try. Why can't we try that, right? We'll see is this possible or not. I'm not pretty sure. Definitely it's going to be fail. But still, I want to try. I want to install a Docker package. Say what is there? Docker. Yeah, I'll just take Docker. This is the command I have to use it to install a Docker package in a Ubuntu machine. I'm just trying now. Say yes. Quite interesting if it works. If it works. Okay, let it be. In meantime, what is happening here? Can you see this? What it is saying here? Can you see what is an error? Token Docker pull alfine Docker tag did not issue a challenge. Connectivity challenge error. So in that case, I have to come here. It is getting only the problem here. Only I'll do the Docker pull command, but I'll remove the Docker push command. Only up to 2 tasks only I'll perform. Let me take that. If you take it for example authentication here, you can straight away we can get it another one. ACR login it is getting, right? Through Docker command itself also we can do that. You can find it, Docker push. Okay, push and pull an image, Azure container, AZ login, ACR login, my registry, login. Okay, I want to search Docker login. Okay, in all Azure documentation. Private registry credentials, password method, retrieve authentication options, private registry credentials. Okay, let me see this. Now see that plan we have executed. Let me try. If the Docker commands works fine, then let's see. It's going to work on that. Only in that scenario, authentication is a problem, right? It seems it's working. See, it's pulling the Docker image. Means what? There is no problem with the Docker command in the local. It is modifications complete after resource providers Dockerful Alpine, Docker tag, Alpine latest. It is missed something. I understood that problem. Problem is with our code. If you come down here, Shift G, see friends here, what is missing here? Docker tag. What is a source? We have given just directly target. Source is nothing but Alpine. Alpine container registry. Now it can work. Plan. So provisioning part, little limitation will be there with the Terraform. Ansible will be faster for provisioning part, but in resource creation and all, Terraform is stronger. Okay, now you can say apply. You can get. Now it can work. Okay, pulling a library Alpine, modifying container registry demo 090621. Okay, cool, super. Only problem is what here? AZ login. I mean, authentication is the problem. So authentication, if I take it up, this is the one we have used, right? Name I have to take it up. In a silent mode, I want to take it up, right? See this, or else, see, you can also log in with a Docker login. For example, you might have assigned a service principal to your registry for an automation scenario. Then when you run the following command, interactively provided a service principal app ID, username and password when prompted. For best practices to manage login credentials, see Docker login command reference. Okay, see this is the command I have to use it in that scenario. So just take this Docker login. We'll try one more time. Here, say Docker login, the URL. What is that URL? Login server here. Go into the container registry, refresh it. You can click on it. You can see the login server. Copy this. Docker login you can do, because already we have done that part. And then ampersand. Now this can work. Simple. You have to debug it. You can able to get it. Right? It's done. See this. Docker login is success. Now can I try one more command? What is that command now? Actual command. So Shift G, say this is our container registry URL, and then Shift G, Shift A, ampersand, take it up, Docker, push this part. Right? Now it can work. Terraform plan. Why it is taking? Hey, one changed. You can say Terraform plan. Okay. So 0 to add, 1 to change, 0 to destroy. You can apply it. Cool, right? So one changed. You can check it out that here what I need to do that if I go here in the repositories, if I found it, the repository name, fine. What is happened? It's not yet pushed. Should come automatically. But it is get success, right? It's not thrown in any error. Cat main.pf file. Docker push, Docker Alpine, Docker tag, all these are in place. So if I say that Docker images, so it's created. But I'll just try to, okay, nothing will be there now. Okay, and even I can say Docker rm Alpine, rmi, nothing but image. It's done. Now say Docker images, nothing will be there. Now if you say Terraform plan, we'll get to know. Good. Say Terraform apply. Good. So modifications are happened. See this Docker images. See, you got it or not? Actually, I'll check it out in offline. This is actually what is causing. Just a minute. The Terraform exes. I mean, ampersand it's not okay. Because we have given multiple commands in a single, right? So that is also sometimes cause the issue. It's okay. It is saying no error, but it's not showing the output here. It's not pulling. It's not executing. It's nothing but just trying something, and it's not pushing over there. Okay. So the provisioner part, if you check it out manually, see this is the perfect way we are doing that. But here the command we have to execute it, but it's going to take a single command. It seems not multiple commands. But if you see here another way, local-exec, you have to echo this part, data, and see multiple commands you are using, join with the join options. So this is the way also sometimes it can work. See what is doing here, join space, every space is going to take it, echo my machine address and data.http IP body going to be get the value into this location. So it can work automatically if I use this. But this is a simple command. But that also can work only if I use it a single command. Meaning if I go here in the main.tf file, shift G, here only something problem is there. So if I go here, well, I'll find all these commands, it can work. Okay, just last attempt I'll try. If not, I don't want to waste our time. So good. So one to change. The state of the infrastructure has been saved to the path below Terraform show command. But here, of course, it cannot show it at that result because it's a local command execution. This is here. Null resource. ID is created successfully. Okay. And then say Docker images location. If you see that, it's not showing that. So remote execution is going to be exposed. It's okay. I'll just cross check it out. What is this local-exec if I want to use a Docker and in offline time, not a problem. So that is, I mean, you can keep on build it one thing, and but only null resource in the local execution is not what it is going to be execute. Meaning, if you take it this example, for example, just it's going to fill it up some data. What is going to be takes place? Join. This is the variable is going to be get it from where? See this somewhere. Data HTTP. Then value it is looking for data dot my IP body. So we are going to get that value and then it will print it as a variable. There are two things will be there, remote execution as well as local execution. So if I ask you that what is the difference between the local exec versus remote exec, you can get to know that. You just straight away will get it. So this is, see the remote execution provision to run commands on the resource, but local, it's going to be execute in the local resource. Cool. You can see that here. You can find that example. See, remote execution. Provisioner invokes a script on a remote resource after it is created. For example, I'm created a virtual machine. On top of it, if you want to execute some scripts, yes, it's going to be takes place here. You saw that just now, right? So this provisioner remote execution in line, it's going to be executed. Where? On top of this resource. Just like if you take in Azure, we are going to use a init scripts, right? While creating the virtual machine, we are going to use a init script. Init script is nothing but a bootstrapable. So this bootstrap is going to be executed. So remote execution and local execution, but these are not going to be identified by TF state files. TF state files cannot identify because it's a script. In Ansible, we are going to use command and shell. but that is not going to provide idempotent behavior. Nothing but what? Desired state cannot going to be checked if I in between whatever you are going to execute it. That's the reason every time whenever you do that, whenever I am executing, every time it is checking one state changed something, right? If you see here, every time it is asking one changed. But normally if you do that second time, it should show as 0 changed, but it is saying one change. Nothing but it will every time going to be execute if you do that number of times Terraform apply command. So it cannot be considered like a desired state. So it's just like if you want to boot up something on top of it, while if you want to install something while boot up itself, you can use this. But sometimes we are going to use straight away Ansible scripts. So that is best to use it. Instead of using shell script here in this location, okay, instead of doing here in the remote location, if you see that here in the remote side, you can use here, you can run Ansible commands. You can check it out. Terraform with integration with Ansible. In the remote execution only, we are going to run an Ansible command. Next topic I want to take it up. One is service principle. Another one is environments. Another one is I want to take about modules. We'll see these three things, and another one is workspaces. We'll target these 4 topics. We'll see how it is going to be next. Okay, so service principle. Like if I don't want to use a AZ command, because right now authentication is taking place through AZ command, but I don't want to use a AZ login. I want to use directly, I want to provide a dummy user. That is nothing but a service principle. We'll take it up that service principle. And environments, if I have a multiple environments, how I need to switch it for different environments. And the third one is workspaces, and about another one is modules also will take it up. As part of the resource, you're going to use any kind of, you can check it out, a health check by using the HTTP. You can use a remote execution, or also you can use local execution. Local execution going to be expressed in the local, remote in the sense created resource on top of it's going to be executed remote side. Fine, good. That's one thing. Okay, so what is a service principle? Why we are going to use this? So using service principle to connect to a directory to PowerShell, how we are going to do this? We are going to get it straight away, but I want to be search straight away, not this way. I want to give a little introduction on that front. I can get it from there itself. Service principle in Azure. See here, using Azure principle with this part, you can come down. So authentication methods. Out of that, create a service principle. Credentials context going to be takes place. Can you see here? So automated tools that use Azure services should always have restricted permissions. Instead of having application sign in as a fully privileged user like a administrator, but Azure offers service principles. See this here. An Azure service principle is an identity created for use with applications, hosted services, automated tools to access Azure resources. How we are going to create it? See this here. Create a service principle with a new AZ-AD service principle commandlet. It's a PowerShell. When creating a service principle, you choose the type of sign-in authentication it uses. Password-based authentication, so this display name, and you'll get it automatically here. Certificate-based authentication, you can give this certificate and you can pass that certificate. You'll get a service principal name. There are two options. One is password-based and one is certificate-based. And get an existing service principal, if you want to do that, get AZ role assignment, new AZ role assignment, remove AZ role assignments. We are going to get it. And then automatically we are going to connect it by using this command. Whatever you want to tenant ID, you are going to get it. But I want to do that through CLI commands, for example. Create. Okay, so create service principal using Azure CLI. Okay, AZ command, nothing but. You can see here. You can find it now. Simple. So password based authentication, AZ-AD-SP create for RBAC service principal name. And certificate based one, see this, AZ-AD create for RBAC certificate name and begin and end. Nothing but you have to give your private public keys. Or you can say this another way. Azure CLI, you can give the path of the certificate PM file. Automatically we can use it. So once it is used, see this, we can get it. If I use this, for example, create set also, it's going to be get it. So to create a self-signed certificate for authentication, you can create it this, so that you can get it. Content of the new file going to be look like this. Private set self-certificate going to be created. See this here, new file, and then you can use that certificate next term onwards. See this key vaults and all. Okay, now nothing but what if I create it, automatically you can get this part. Now whenever I want to run it Terraform, I don't want to use this part AZ command, right? If I say that login, you're going to get it authentication. See this automatically finding, and you're getting that part. See that. Now I can able to, all this information we are getting, now I can able to access it. Cool. Now we'll see one example how we can able to use it. For that case, can you see this example? There is an example in this list. Maybe you have here. Just come down. There is a AD command going to be there. See here, arba. Okay, so this here main.tf file. It's going to create it. Azure Key Vault Secrets resource. But can you see that providers first thing, right? In the providers, not this one, I think so. Just a minute. Azure Key Vault side providers.tf file. In that one example, you can come down main.tf file. I can say this. So if you want to, a basic way, if you want to do that without AZ command, see friends here, we are adding that information here. Subscription ID, client secret, tenant ID. But in the previous cases, we don't have that. See, if you see here, we don't have that. Directly we are using provider. But in this case, if you see that here, we are just adding as per the provider features and then adding that information. Let's try this one example so that we can get to know how to use this, right? So take it up that we go here. Okay, now go to this part. Here it is, the module called 80. Just check it out. Main.tf file. Okay, so first what I need to do that first of all I have to create Azure service principal, right? For that case, there is a command here. See that same command azadsp create some name you can give it. Take it this command. Okay, so it's going to create a contributor command. Let's see that. If you go into the Azure side home page, okay, and then see this here, there are resource groups. IAM roles going to be there, right? You can come down IAM, and here we can able to get it some contributor roles, role assignments and all. Custom role, very deny assignments. All these are grant access control and all. We can say role assignments, roles. What are there? See, different roles are there. So grant full access to manage all resources. So contributor role is important for Terraform because we are going to create a resources. Okay, so the role assignments also going to be there. See, right now DevOps March 120 because that is a contributor role subscription. Okay, if I create it, now this service principal, it's going to be created one. Let me take it up that example. So if you just take it up, command take it up this one. Okay, and I'll go here. So this changing Terraform SPN to valid URI, which is required format used service principal names, creating a role assignment under the scope. This is the one, our subscription, and then see retrying role assignments and blah blah things. So it's created. So it's nothing but main.tf file, subscription ID. If I want to get a subscription ID, what I need to do that? Check it out here. If you go here, the subscription ID is this. You should take it up the subscription ID. You can replace it. Okay. And what else need to take it up next? What is there in that here? Display name, password and tenant. See, tenant you can take it up here, and you can update it here in the tenant ID. And the client secret, what is provided here? Password, that is nothing but. Okay, now you can take it up this. How about client ID? Client ID is nothing but an app ID. Now you can take it up this. You can take it. Now we are able to Now what I need to do that is this working or not? How can I check it out? It's going to create what? Azure resource group and Azure RM storage account. But I don't want to create a resource group. I can comment right now. Okay, just comment it. I'm just commented. Say command S. Only resource group only going to be. Okay, now that's fine. Now you can come down here. See, the code is here. But just time being, you can copy this content somewhere. I can keep it in this commands location on the top. Time being, I can save this. Okay, now let's see that. Now what I need to do that, I have this main.tf file, simple one. What is going to do that? Now this one. Now what I need to do that, first of all, I need to AZ log out. Then how can you test it, right? If I want to test it, is this subscription ID, client ID and all these are working on it. If I want to check it out, I should be able to log out. Okay. So it cannot use the AZ default authentication. I just logged out. Okay, cool. Now say I'm in this location, say Terraform init. Good. That is fine. Terraform has been successfully initialized. The next step is what? As usual, we know this part. Hyphen out, say tf plan. It's going to be express. Good. Resource part going to be executed. Now I should apply it. Let's see, is this going to work or not? That's nice. It's working. Okay, so it's nothing but what? AZ command is not required. Because if I use it AZ command, I have to do that explicitly. AZ login command, I need to authenticate it. Now you just use the URLs. That's all. Okay, so this is the way we can able to handle it. Okay, and the next step is I want it to be maintain multiple environments. So how can I do this? Right, we are going to separate the data from the actual templates, right, from the resources, nothing but. If you take a main.tf file, till now we have done hard-coded way. But if I want to use it, if I want to pass it out dynamically at the time of runtime only, at the time of execution only, I want to pass the parameters, the actual values. For that case, what we have understood, variables.tf files we are going to use it. Variables.tf file, what it does, it can maintain the variables like a key value pairs. I'm going to declare keys with default values if required. As part of the variables.tf file, of course, you can declare here also, but it's unnecessarily messed up, right? That's the reason we're going to use a variables.tf file, keys, and if you want to use a default values, you can also pass a default values or mandatory values. You can declare it simply. See here, variables.tf file, but we are not passing any default values. Simple variable name, and type is equal to description. This is also not mandatory, but description is going to give you the what is the purpose of doing that. I mean, right? You can understand. Cool. And this variable, what we are going to pass it out as part of the main.tf file, right? As part of the main.tf file, each and every time see where that is going to be text. That is a variables. But how can you pass that variables values? But of course, variable that you may get doubt. So you are created main.tf file and variable.tf file. But how can you pass it? We are going to run a command called terraform apply. But how can you pass that parameters? I mean, actual key is equal to value. I have to pass it out. So for that case, we are going to use an extra file called terraform.tfvars. Terraform.tfvars. If it is variables, it is there in the sense automatically Terraform going to check it out, terraform.tfvars. If you want to override it, still you have a Terraform TFVars, but still you want to override it, what we have to do that in that side? Because Terraform.tfvars is nothing but a default values. But I'm going to maintain in my real projects multiple environments like dev, test, pre-prod, right? Pre-prod and prod. Then in that scenario, how can I take it up? How can I pass dev related parameters, test related parameters? Because just like resource group, I want to give resource group hyphen dev. If it is a resource group hyphen test, resource group hyphen pre-prod, resource hyphen equal to prod, based on the environment. So we are going to use the same. Here we are explicitly using by default it is looking the terraform.tf-vars. We are going to give what? Different name, dev.tf-vars. But you have to explicitly pass it out, right? You can pass it out something like this. So here, terraform apply help. You can find the options. See this? You can do that one by one parameter also. You can do that -var foo is equal to bar, set a variable in the Terraform configuration. This flag can be set multiple times. So we're going to use TF-vars, or sometimes we are going to use workspaces. Okay, let's see how we can able to see that this example. See this here. By default, set variables in the Terraform configuration from a file. If terraform.files are tf-vars are available, or any .atto tf-vars files are present, they will be automatically loaded. Now, if you take it in that example, can you see here? There is a, just observe this code, main.tf file will be there. We know that simple one. I mean, I'm not taking too much of configuration because we have to understand clearly the concept. Number of resources, var.resource group name. It will get it from the variables.tf file. Of course, this is, we know that. The values, I'm going to use a tf-vars, terraform.tf-vars, but it is not there. In this part, not there, for example. But this here, dev, prod, test. Just create explicitly 3 directories. Out of that, can you go into that dev.tf-vars? See, what is the name we are passing here? Can you see this here? dev.rg. If I say, for example, production, different name, see, prod rg. It's just a sample, but you can give hundreds of parameters according to the requirement. And another one, test, if you take it up, test.tf-vars. And then you can get to know. So if you take it in that front, what command I have to use it if I want to run it? Terraform apply command. Can you see this here? Simple example. See here, terraform plan. Of course, till this plan we are okay. But what we are doing that, I'm going into this dev directory, I'm passing dev.tf plan instead of simple tf plan. Simple. I'm just adding the environment name, right? We are using environment name. And then state I'm just declaring. And var file, see, var file we are just what we have understood here, same thing, right? Var file. You are passing that parameter. If I just take it up, can you see it? As usual, variable.tf file going to be there, and dev going to be there, main.tf file. So this main.tf file going to be refer variable, but we are going to pass it out these parameters explicitly. Now what I can do that, say for example, if I want to create it, dev environment, for example, so these values going to be used. That's what dev rg going to be created. For that case, terraform, simple. As usual, just a smarter way we are doing that, simple. Terraform plan -out, okay, -out. What I'm passing now, instead of doing in the current directory, I'm going to use dev. I mean, straight away you can say dev, and then dev.tf plan. Good. And what else other command? If you want to give a state file, yes, you can give it state file -state dev, and you can give the name of the file. See this here, dev.tf state. It's going to be created now instead of terraform.tf state, terraform.tf-vars. Those are all default values. But this is, we are customizing. Good. Another one is what? I have to take it up -var file. -var file. Just we have seen that here. This var file parameter. And another one is a state. State, I'm just taking it up. Another one is out. Out is going to be takes place in the plan section. Now say dev/dev.tf-vars. Now nothing but what? Whatever output is going to generate, I want to be stored in a dev environment itself. I don't want to mess it up. Why? Because if I can give it directly dev.tf plan, dev.tf state, and var file is equal to dev.tf-vars. But what is that problem is, if not find, for example, so automatically it's going to be refer the in the current directory, right? So state files and all. That's the reason we are explicitly giving the dev.tf state. But if not give it, automatically going to create terraform.tf state file. So please remember this. If you are not giving any parameter, -state is equal to, it's going to use the terraform.tf state. For example, variable section also, if you're not declared -var file, it's going to check it out terraform.tf vars. Good. Let's see this. Could not load plugin. Which plugin it's looking for? Can you see this here? Terraform automatically discovers providers requirement and all. Registry terraform.io. It's going to be check it out. Terraform providers. Okay. So Terraform init. I can use it. We are able to do this. And then I can say, as usual, this command I'm going to plan command I'm going to take it up. What it is saying that error building Azure RM client to obtain subscription from Azure CLI, error parsing JSON result from the Azure CLI, error waiting for the Azure CLI, existing status 1, no subscription found, AZ account set to selector. We have AZ logout we have done. But if you check it out in the main.tf file here, we are not using, right? We are not passed any subscription. Okay, so for that case, what I have to do? I should go this commands.sh. I have to pass these parameters, right? So for that case, what I have to do? I'll just add it right here. I can take it up straight away. This I will go here in this 22 location in the main.tf file. Either I can AZ login also, I can do that, not a problem, but I can do it here and pass that part. Now let's try Terraform plan. So now what we have understood, Terraform plan, what it does, it's going to run a dry run. It's going to check it out in the remote, nothing but. Now it's done successfully. See, one to add, one to change. Now see that, is this created or not in the dev section? See, dev.plan. Just simple, just as separating the things, that's all. Cool. Now you can say apply. So for that case, what I have to do that, in place of plan, I can simply use it apply. Okay. So what it is saying that apply purpose, it's throwing an error. Terraform apply. Good. I don't want to pass it out, right? This -out is not going to take. So Control A, I should avoid this part. Good. But var file going to be take it up as usual. State file going to be take it up as usual. State path. Okay. Now let's see that. Still the mini command line arguments, configuration path expected. Configuration path expected. Where we are right now? Of course, current location. Terraform apply dev/dev/tflan state and var file. Okay, just give me 1 minute. So Terraform apply state plan not required tf vars because it is already applied. Cool. Now just I missed out this part. So this is not required, last one. Okay, let's see that. What is causing -state? Same thing, right? I just given state equal to this tf.state df plan. Okay. Say Terraform apply. I'll just do manually. Dev dot df plan. Okay. -state. Okay. I will think I have to give state and plan. Okay. Cool. -state dev say dev df state. That's the reason. See this here. Too many command line arguments. Configuration path expected. We are able to do this. Now you can check it out. The state file created or not. Say dev. Df state files, right? Say star dev.tf vars tf plan state file. Easy, right? Just you have to. It is very important. Even use it Ansible. If you take it Puppet, you take it. This concept is similar because I have multiple environments. Even you do it if you use it Kubernetes also. Same process. You have to maintain the data separately. If you write a business code also, even if you write a .NET code or Java code or anything code, Python code, you should able to separate the data. Data should not be there with the code. the data should be injected according to the requirement, according to the environment. So nothing but what we are doing right now by using this concept, simply this is the way I'm achieving. Cool. So my code is going to be here. Okay, my code is going to be here. That code contains main.tf file, providers.tf file, variables.tf file, all are here. Okay, but what I'm doing that if I want to do that dev environment, I'm going to pass the dev variables. Nothing but I just need to take it up this way. Here I'm going to pass the dev vars. Here I'm going to pass the dev.tf vars. Simple. If I want a test environment, then I'm going to take it up here, and this way I can able to inject it. This is for say test.tf vars. And here I'm going to take it it's a prod dot. Advantage is what here? I'm not going to, if for example this concept is not there, for example, so this copy I need to take it up 3 times, right? I need to take like this. We have to add code it here itself in the main.tf. That time it's not required this variables. You should add it here itself, here itself, here itself. But now we are keeping here separate. Only at the time of runtime only we are going to do that. Even TFRs also, if you don't want, if it is a 1 or 2 parameters, that is also not required. These also not required. You can simply use this concept, var concept. Var file means what? I have to maintain the file. If I use a -var, single variable. -var, some value if you can give it. Terraform apply, -var, something. Does that make sense, friends? Okay. This is one approach. Okay. This is going to be a one approach. The next step I want to take it up. Okay. So what I want is, instead of using this explicitly maintaining the dev, test, prod and all, I'm going to use a workspace. Same like if you compare with a git branches. So what is a git branch, friends? How can you switch it out one branch to another branch? So git branch, it will going to list it down the number of branches. Then if you want to switch to master branch to dev to test, something blah blah, different releases, for example, I can check out, right? Simply git checkout, say dev, automatically switch to dev. Then dev related changes only going to be there. Now dev commits going to be there. If I want to switch to master, for example, git checkout master, then master code going to be there. Same kind of concept. I have multiple environments like dev, test, right? Dev, test, prod, pre-prod, for example. So for that case, what we are going to do, now what we are doing that with the environments, I'm passing the parameters explicitly here, right? This is the command we are using explicitly. We are passing this exactly Terraform plan command. You can take it up. Quite interesting. Right, this is the command. If you check it out, what we are doing that explicitly, I have to declare it dev df plan. I don't want that. If you take it in this scenario, I'm just using explicitly passing the dev tf plan, dev tf state. If I forgot it, it will take default values. I don't want to too much of maintenance. Should be simple. So in that scenario, same way how I am checkout, git checkout to another branch, I can also switch to different environments. That we call it as workspace. Can you read about this quickly? Okay, you can come down here, say workspace Terraform. See this here, straight away you can get it. How we are doing this? See here, workspaces, jump to section. So each Terraform configuration and associated backend that defines how operations are executed and where persistent data such as Terraform state are stored. So the persistent data stored in the backend belongs to workspace. Initially, the backend has only one workspace called default, and thus there is only one Terraform state associated with that configuration. But certain backend supports multiple named workspaces, allowing multiple states to be associated with a single configuration. For that case, what we have to do this? See this, using workspace. Terraform workspace is a separate command going to. You can check it out here. There is a, see this Terraform, take it help. See this friends, workspace management. You can take it up, Terraform workspace. So new list, show, select and delete Terraform workspaces. You can see that list command. By default, it's going to be a default. I think yes. Same like a git branch. If I want to create it, you can simply say new, say for example dev. Created and switch it to workspace dev. Same like a git branch, right? And see this here. You are in a new empty workspace. Workspaces isolate their state. So if you run Terraform plan, Terraform will not see any existing state up for this configuration. And then you can simply say, if I want to switch. Now, if you say that list command, you can find it. I'm in the dev now. Okay, and can you see that show command? What is the what it does? This show command, dev. And if I want to select it, you can say select default. We switch. Same like git checkout command. Terraform workspace new name. If you give it, it's just like a git branch name. And this one Terraform workspace workspace name you can give it. That's nice. And if I want to go once again to dev, I can create it there. Switch it to workspace dev. And then of course is going to be tell that see this new bar, created a switch bar something. And then current workspace interpolation, if you want to see that, see you can get to know that. Example, Terraform workspace default 5:1. Then it's going to be get it. You can give also resource AWS instance example where Terraform workspace going to be used. When to use multiple workspaces, how can you do this? You can use the reusable modules and all, you're going to use it. It's nice. So we'll take it a simple example. If you come down, see here, environments, right? Just we have done this environment same as it is, the workspaces. Same stuff, main.tf file going to be there. Everything is same, okay? But we are going to just see this here. Terraform workspace list, Terraform new dev and list, and then we are going to apply as usual. And if you see, automatically you can apply. But even dev.tf plan also not required. You can give dev.tf, but just for understanding purpose. If you switch it to the new test, see this test.tf plan, test.tf plan. If I say production, I can do that workspace new production and I can do it. Same, but main.tf file going to be as usual. See, required providers, resource group names, all going to be used. It's not straight away. It's just like a branch, we cannot able to see that, right? Just like it's a kind of a if you ask me in the local, there are multiple branches are there, but it is kind of a whenever you clone the repository, whenever you see that git branches can be listed, but you cannot able to see that explicitly separate directories, right? The same way, but you can just check it out. -a, is there anything? Okay, now we are in this location. See this, can you go, what is this about, right? Terraform tf state.d, you can go, what is going to be there? Dev will be there because only one we have executed explicitly, right? That is dev. Okay, just a minute, one step back. Terraform, see that what is there in that environments, plugins will be there, but this is like a plugins and all going to take place. It's just a environment, right? Nothing dev environment will be there. Okay, cool. Just step back. Let me try workspaces. Say new test created. For example, prod created. Okay. Now see it's created here. The state file. I mean it's going to be stored here. So if you go into that dev, what is there? Nothing. Because we have not executed yet. Okay, let me try one more. I'll try to execute it this part. Okay. Now I am here. Step back. Okay. Now say Terraform plan -out, say dev.tf plan. Now let's see what is going to be text. So where dot resource group name, enter a value. Something assume that dev.rg. Okay, where that resource group name, right? So rg underscore dev. or else I can give it like this. Dev. So where it is going to be stored, we'll see that. Cool. But first of all, where I am right now, Terraform, say workspace, list. So prod it will be there, right? But where it is executed, this one I want to check it out because we have planned, right? So we are in a prod now. So this dev tf plan is created here itself because the best practice is what you have to do that just remove this dev tf plan. What you have to do that production you have to use it because I'm in the prod environment, prod workspace, and just do this something rg prod create terraform apply tf prod. Now you can apply it, okay, and then say prod dot tf plan. Good, it's created. But this tf state file where it is created, I want to check it out. See, prod tf plan is there, but what about state file? It's not here. Can you check it out? ls terraform and say prod and say start. See friends, here terraform state file is storing in this location. Is this clear now? So workspace separate directory going to be created. So according to your selected environment, you automatically going to be stored into this location. So if you want to do that automated way, for example, through Azure DevOps, for example, tomorrow. So what I have to do that before executing Terraform init, Terraform plan, Terraform apply, what I should need to do that Terraform workspace select and particular environment name so that it will be maintained very well. That's nice. Okay, so if you get a chance, little read about this part. These 4 points examples. When to use multiple workspaces. Named workspaces allow conveniently switching between multiple instances of a single configuration within the single backend. They are convenient in a number of situations but cannot solve all the problems. But if you read about it a little bit, you can get to know more things on this one. Okay, so these two are very, very important, especially for customization purpose, right? If it is a single environment, don't bother about workspace and environments. But in our real projects, we are going to maintain multiple environments. Hence, we need to use these two options. One is environments and the one is workspace. Now, I'll talk about next one is about the modules concept. Quite interesting this one. We'll see first of all problem statement. Okay, and then how we can able to use these modules we'll see quickly. Let's see how we can able to take it up to this part. Now, first of all, right now, what is the problem you have to understand, right? If you take it in a diagrammatical way, if you here, check it out, right? Now, what we are doing that, friends, if I want different resources, I want to create a multiple, for example, if I want to create, think over it, I want to create Azure virtual machine. I want to create VNet. I want to create ACR. Okay, VNet. I want to create, for example, AKS cluster. I want to create app service, nothing but web app service. I want to create it, for example, something like that. Whatever. For example, I'm going to create a storage account. But just observe this. For example, if I want to create 10 storage accounts, I want to create it, for example, in different timings. But you have to use resource 10 times, right? If you say, for example, if I want to create a virtual network, then I have to declare virtual network like the resource, virtual network, assume that just proper naming convention you can give it, and then VNet 1 something, and then you're going to declare the parameters here. For example, tomorrow if required something else, different virtual network, I need to take it what? Once again, I have to take it up this one repetitively multiple times with a different, if it is a different parameters. If it is a different, if it is the same parameter, I can give it a random number, it automatically give count equal to 10, if it automatically going to create it 10. But I want different parameters, different CIDR, CIDRs, different subnet group IPs. So in the scenario, I have to declare 10 times with the resource. Nothing but what? We are doing the repetitive ways. Agree, right? We are doing same thing multiple times. Nothing but you are declaring duplicate time. You are using duplicated way. So what I want is I want to reusable. I want to be a reusable component. Just like think in this way. I have a method. If I just pass the parameters, whatever task it is going to be performed, I want to just like example add method if I want to take it up. And if I pass it out int a comma int b, if I pass it out, then automatically it's going to return a plus b value. But if this approach is not there, if you don't have a parameters, if you're not doing that logic, what I have to do that every time I have to do that sum is equal to 10 plus 20, 30. Every time I have to write it. Sum is equal to 20 plus 30 something. I have to do that. Instead of that, if you just pass it out parameters 10 comma 20, another one add method to 30 comma 40, another one add 50 comma 60. Simple. This is the way we are going to use it. So nothing but what I need to group it. Whatever repetitive tasks are there or repetitive resources are we are going to use it, those resources we call it as we have to group it. That group is nothing but a margin. Nothing but this is the way it's going to be take it up. If you take a diagrammatical way, just like what we have shown, same thing. It is going to be a multiple resources I'm going to use it. For example, here, as part of that, if I want to use a VNet or virtual machine or a AKS cluster, okay, I'm going to declare here itself. So here, I'm going to declare, for example, main.tf file, variables, okay, variables.tf file. Another one is provider.tf files, provider.tf file. Like that, I can use it n number of files we are going to use it. So this will be normally what I'm going to do. I'm going to create a multiple files. I'm going to use it in the main.tf file. Everything is going to be performed, right? As part of the main.tf itself, I'm going to declare VNet. I'm going to declare AKS, and all I'm going to do that.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
But that is not the best practice. Now what I need to do that, I'll just write it on all these things will be treated like this is treated like a module. So each module contains the main.tf file variables and providers, whatever files you want to create it. You can create it, but we are going to call those modules from our main.tf file. I have here main.tf file. From here, I can able to pass it. Like that, I can able to create a multiple modules. One is for one module for VNet module. Okay. Another one we can take it up, say virtual machine module, VM module. Another one I can create it like a, say what you can call it as ACR modules. And then I can able to declare it from here to here and I'm here to here. But here itself I'm going to declare my module. Modules will be there separately. We can keep it in a GitHub, we can keep it in a registry, we can keep it in our local, and then we are going to call this. Okay, so it is this concept is there in a configuration management tools also, like Ansible or Puppet, Chef. All these are the module concept will be there. But there we called as roles. Here we're going to call module. Module contains the multiple. Each module going to do a unique task. Nothing but what? I'm just creating one unique task. And by passing the, if I declare it, automatically that going to be called up and it will be referred. Just we are organizing in a reusable manner. So in the main.tf file, I'm going to declare module, and then that module name with the parameters I'm going to pass it out here. So source going to be takes place. That source is either this, whichever you're going to use it for. And then I'm going to pass the parameter name, IP, security group, whatever required, you can able to pass it. So these values going to be assigned here, automatically going to be there. Okay, little other customization on top of the environment variables. Just take it up that way. So how we can able to take it up this concept? How we are going to write it? It's a simple one. We are just making one group. It's nothing but we are just grouping the instead of declaring each and every time in our code, in our main.tf file, we are keeping separately and we are referring that. That is, we can, you people know about Jenkins files pipelines. As part of that, did you find any time shared libraries and reference libraries? Shared library, nothing but I'm going to write a groovy code, just simple. If you take it in our Jenkins pipelines, we are going to use a methods, DSL methods, like a git method, sh method, right? Those will be called as a methods. We are going to declare as part of the Jenkins file. But if I want to use my own custom method, so what I'm going to do that, I can write it in a GitHub, one shared library. There I can write it all the groovy functions, and I can able to declare it in a Jenkins as a shared library. I can import it. Simple, man. If you take a Python, we are going to import the modules. If you take a Java, we are going to import the utilities, just like a java.io something. Right? We are going to import it. The same thing, we are importing. We are importing already developed modules, and we are referring straight away without writing once again the code. Nothing but reusability. We are already developed some module. That module we are importing, we are referring, and we are just passing the parameter. That's all what we want to create it accordingly to code. Nothing but what? In Azure, whatever resources required, you can able to create it your own module. Already you will get a modules. Just refer that modules and pass the parameters. Done your task. Life going to be a smoother if you use a modules. Okay, if you take it to that concept, we can see quickly one example here itself straight away. Modules, Terraform, and say this here. So try to refer to, always try to use this. Terraform part. Say this here. Modules, a container for multiple resources that are used together. Nothing but a grouping things. Now calling a child module. See this, how we are calling this in. Instead of resource, I'm going to use a module. Some name you can, module name you have to give it, and give the path, and then whatever parameters are required, you can see this. So this module going to be there. This is app cluster. It is just like our Terraform module, Terraform code. It contains variables. It contains main.tf file. It contains .tf files. That's all. Nothing but what? We are separating the things, everything. Okay, let's see that how it is going to be taken up. Source. Source is an argument which is a meta argument defined by Terraform. Its value is either path to the local directory containing the module configuration files, or a remote module source that Terraform should download and use it. Okay, so version is also going to be there. Which version you want to use it? If it is use a registry, Terraform registry. Cool. See, that is a registry here. HashiCorp console AWS. It's provided by the HashiCorp itself. Nice. So if you want to use a multiple instances at a time, you can use count for each providers. It's automatically get it. See this here. Instances module server.instance IDs automatically going to be allowed. So transferring resource state into modules. Nothing but. Cool. But how we can use it, we'll see one example. So if I go here, okay, modules, simple example, say this here. As usual, same thing going to be there. Only extra thing is that modules directory. If you want to do that in the local itself. Okay, so here modules contains all the, see, as usual, main.tf file, outputs, variables, all this stuff. Modules. As usual, backend is nothing but we know that what is a backend. Remote state going to be maintained. Right? Providers is nothing but you are going to point it to the which provider you want to choose it. If you check it out main.tf file, what we are doing there. Can you observe this? What we are doing that, this is as usual, we know this. This is not a bother at all. But just observe this, what we are doing that. Module vnet. It's a directory under modules. So that we are calling that. Source is nothing but. So it's nothing but if I take it up this way, for example, new window, all these things are keep it aside. Okay. Now just create one directory, new folder, for example. Okay. So here, as usual, I'm going to create a file like a main.pf file. Okay. Under that, I'm going to create a folder called modules. Under that modules, I can create what? You can create some name. I can create a RG. Yeah, I'm just create a RG. But just I need to delete this. Okay, just delete it. Okay, under modules, new folder, say RG. Under that RG, I can create a file called main.tf file. So here I'm going to declare my resources. So what I can declare it resources, if you take it in that front, right, I can take it up this resource as usual. Simple one. You can come down, take it up. Cool. I'm done. So this module where I'm going to call it up, here I'm going to call. So how can I call it up module? Just say module name, nothing but RG, and just pass it out like this. Say source, say dot modules slash RG. And then if you want to pass a parameters, I can able to pass the parameters. How can I pass the parameters? If you see that example, see this here. Source, I'm just giving that, for example, resource group name here. That resource group name, I'm going to pass it out as part of the modules you can see here in this main.tf file. As usual, we are going to give it name. Just an example, you take it up this resource group name. That resource group is nothing but what? Variables going to be added. It's the same thing. Cool. If you just take it up that example, so I have to declare what? In the modules, RG, main.tf file. In this place, I'm going to declare this way. Cool. It's a variable as usual. In this case, I have to create one new file called variables.tf file. As part of the variables.tf file, I'm going to take it up these variables, nothing but resource group name. Cool. Just have to declare it. As usual, previously whatever we written, as part of the modules, I'm going to declare variables main.tf file. I just automatically refer this var.tso is fine, variables.tf file going to be referred. This is going to be done. Modules. This module, I'm going to call it up from main.tf file. So here what I have to declare, according to this variable, nothing but resource group name, I have to pass it out as a variable. That's all. Done your module deployment, right? You're just passing that parameter. Cool. So for that case, I'm just going to take it up this part. Something A, B, C, X, Y, Z or something like that. So this module going to be called. Like that I can, if I have a multiple in a single module direct modules that you can create n number of modules. RG, VNet, virtual machine, AKS, blah blah things, n number of things you can do that. From here you can able to call it up those modules. I mean from here. So what is an advantage, friends, if I use this approach? So without writing too much of code, you just call it up and declare it, right? So whatever, just you have to understand what manual resources are, I mean, what are the components are required to bring it up your requirement infrastructure. Just collect that service names and just call it up that service names with the help of module. Nothing but what? I'm going to maintain each and every resource in this modules directory. And then just I'm going to call it up, that's all. If I know 4 services required, and 4 services I can declare it in the main.tf file. Only you have to pass the parameters. You have to pass the just parameters. In this part, if you just observe that, you have to just pass the parameter and the module directory path. And then in the main.tf file, of course, as usual, I have to provide a provider. So for that case, you can take it up this provider, you can declare it, because we are doing that, right? Change. I mean, you can separately, you can create a provider.tf file also, as usual, you can create it. That's better. So just close this, Terraform, not in this, sorry, escape, module demo, here, in the module section, here, say backend is not, this is the one, right? Backend is okay. The module demo here, and the main.tf file will be there. Of course, I can declare it here itself. For that case, we can take it up, copy, take it up this, paste. Now you can come down, take it up, say demo, and say we can go into that where we went into. Can you check it out? We are in this location, right? Okay. Just move 06 to demo to current directory. Okay, we can get it. So under that modules demo, You should go into this modules demo. You can find it out. Simple one. Say Terraform init. What it is saying that, friends? Missing required argument on main.tf line 6 in module rg:6. The argument source is required, but no definition was found. Maybe I'm done source wrong part, but we can find it here. Just use the source, this format. Okay, so for that case, we can go here. We just need to take it up instead of this. We can declare it. Say rg. You want a different name? You can also give it that. We are going to declare this way. Now I'm just save this, and once again do one thing. If the syntax is correct or not, format is correct or not, if you want to do that, Terraform FMT invalid expression. I think it is not saved, right? It is not saved. Main.tf file it is deleted. Why it is deleted? No, should not be deleted. Okay, got it. It moved, right? That's the reason. So you should come down here, modules, say main.tf file. You should change it here. Say ng, sorry, rg. Yes, so in the variable.tf file, it's not there. Main.tf file, you have declared. One thing I have to take, right? I think I missed out. Variables, it's not saved. So copy this, modules, variables.tf file. Same resource group name should be here, and variables pointed, and here it is we pointed that resource name. So here I need to point it, right? The variable name point I need to point it. So where that resource group, so that is this resource group name. I should take it up and we can declare it as a variable. Now it works well. Cool. You can come down and say, cool, it's working. Now you can say init. Now modules part is going to be expressed. That's nice. So rg in module rg, and it is taking up. Now you can say what? As usual, it cannot change anything. Terraform plan out. Say tf plan. Now what is saying that? Okay, I'll just do that quickly. Az login. Okay, good. I'm just pointing that. Done. Logged into that. We're going to get it. Say done. Out plan. Okay. In meantime, I have done some changes right here. I have to delete that change. Terraform state main.tf file. Just a minute. Here. I'll go into services. Container instances. Home page. Source groups. Say dev rg. Created my first resource group. RG prod. All these things, right? Just go here. And container registration replications and all, right? So you should delete this. Delete resource group. Okay, better. It's going to be take place. So it's okay, fine. Now you can come down. See, we can apply it. Terraform plan. Let's see that is going to work or not. See this. Plan 1 to add, 0 to change, 0 to destroy. Good. Now we are able to. The state of your instruction infrastructure has been saved to the path below. We are able to. Yeah. So state path is created. Now if you go here, is this created or not? You can check it out. What is the name I have given? My module example. You can see the resource groups and just refresh it. See, is this created or not? It's going to take a little time, right? Okay. And you can also show it up. Terraform show. And see this here. Module example. So module.rg.azure RM resource group is created. Is this clear, right, everybody? So just what we have to do that, nothing but you can write it explicitly, or we can also going forward, I can use it existing one also. So that is Terraform registry going to be takes place. There you can find it a hell lot of modules straight away. Good. Okay. Can you see this? Is this created or not? Let me check that one more time. See friends, module example is created. That's nice. Cool. Next. If you don't want, just simply say destroy. Now, if I want to use existing resources, for example, see there are two things you can. If it is already GitHub location, it is there, for example, we can able to give in the location, we can give the path. For example, if you take it in this module section, right here, okay, so modules we can use this way. and we can able to point it straight away in the module section. I mean, in this part, we can give a different path location. See, like this also I can do that. We can declare remote side one also I can do that. This is, it's nothing but Terraform going to provide a registry. See this here, Terraform registry. You can search it out here, Terraform registry. See this, registry.terraform.io. Same like a Docker registry, same like a ACR, same like a Nexus repository. You can find it all the modules. See this here, modules, browser providers and all. If you click on it, the Terraform registry. Discover Terraform provider that power all of Terraform resource types and find modules for quickly deploying common infrastructure configurations. Now you can see, browse the modules. They all are here. But these are all like a AWS module. See, IAM module, EKS module, security group module. Nothing but what? If it is a common infrastructure, if you required, so you can just refer this part. But I want, for example, provider type is equal to, say, Azure RM. Straight away we can get it. See, regions, AGF mod, of Key Vault, RG, Terraform module for Azure Resource Group, what you have done, and Azure Network, C, CAF Diagnostics, VNet, see, VNet, we can use it. That's what the point here. If you click on it, you can get to know what we have to do that. There are multiple versions also going to be there. See, version 2.4 or 2.3 or 2.1, all this we can do that. Okay, so how can we use it also? It's going to tell that, see this, how to use it. As usual, we know this part, provider part, and this is actually explicitly using, but this is also we can do that through module. We can declare n number of modules. Okay, so module is treated like it's like a resource. Okay, but module is just treated like a resource, but resource going to be performed one task. Module can perform multiple tasks. There's a difference. Okay, resource can perform only single task. Maybe virtual network going to be created, maybe security group going to be created, maybe AKS cluster going to be created, but blah blah things. If required, multiple components, multiple resources are going to be involved to create a particular service, then module going to be held. So it's nothing but what? See this here, module VNet pointing this. What we are doing that? We are not doing anything. We are just passing the parameters. Resource group name, address space. So this resource group as usual, Azure resource group dot example dot name, and then address space. All these are passing. Subnet endpoints, tags, depends on. Okay, one question: why it is using depends on this part? Because if it is executed, for example, module itself, for example, chances are there thrown an error. So whatever interdependencies are there, we can also use it this. But if you take it in the 0.12 version, there is no dependency. It's automatically going to be executed. But what about how can you check it out this module? We cannot find it because this is provided by the Terraform. Terraform itself, this VNet module is provided. But if you want to see that code, you can see this here, source code, github.com, Azure Terraform, Azure RM, VNet. Can you click on it? We can see that code or not? Cool. Azure repository. Under that, Terraform, Azure RM, VNet, and all it is used to see. Little, I mean, because it is Terraform is providing in the sense, definitely they will write it everything, right? In a tested way and all. It is create a basic virtual network as usual. Resource. This is example, but if you see here in the code, if you check it out, what are the things are there? Main.tf file, variables, outputs, all are there. If you go to the main.tf file, see resource group, Azure virtual network, Azure subnet, locals, Azure subnet network security group association. Yesterday, whatever we saw that manual steps, everything is in that. Nothing but what? We are just grouping. We are just grouping all these things. We are calling through main.tf file. That is nothing but this. We are, all these are things are there. That is called as a VNet. And now we are calling this VNet, Terraform Azure VNet, right? We are calling here as a module VNet and say source and resource group name. Whatever we are going to pass before with TF vars, we are passing through module parameters. Those module parameters going to be override with the vars. Agree? See, vars. Everything is a variable. So if you go and in a project, if you check it out, definitely modules only going to be used. So it's very, very important. This is one thing. But how you are pointing this one straight away, these guys are providing, right? Facility, how to use it and all. So this here. Azure is nothing but a GitHub repository, VNet, Azure RM. Not only this one, VNet, not only VNet, right? We can once again go back here. For example, I want to create a AKS cluster or app service. Everything we can search it out here. Everything we can search it out. What we have to search it out? Is there any way? Searching things you can see here. AKS. AKS is nothing but a Azure Kubernetes service. You can click on it, so you can able to find it somewhere. It's not searching. Okay. Go back. Go back. It's searching this part. Providers. Azure RM. You can find it. Key vault is there. This is a Terraform module for Azure Resource Group. Azure Network, VNet. So there are so many things are there, but I want to search it out, right? So these all Azure Network Security Group, separate naming convention, all. But I want to search Kubernetes. See this here, Kubernetes, AKS. It's there, AKS cluster. As part of that AKS cluster, if you want to see that, just come down here. Okay, see there is one cluster, Kubernetes AKS cluster. AKS means what? It's a Kubernetes service. Same like a Docker, but we are going to make a cluster. So for that case, what are the things are we using now? See this is completely manual. The main.tf1. Azure RM Kubernetes cluster. Resource only. Resource. We are passing the name, location, blah blah things. Node to pools and all. Network profiles. CR9. And of course, providers, outputs, we are just using straight away. And Terraform TFVARs, we are just passing the parameter. What is the resource group name, location, cluster name, Kubernetes version, system node count, node resource group, all these things are we going to use it. So now this is like we can able to do that two ways. We can, if you suppose if it is not sufficient, module is not working as expected, for example, yes, you can create it your own module, or directly you can create it your own resources straight away. We can declare it. It's absolutely, there is no restriction. Only use a module always. No, it's a strategy. The best way is always use that module, but you will use it your own module or Azure provided modules. I mean Terraform provided modules. It's absolutely yours. Or maybe organization level, in your organization, in your project level, if it is a common modules are there, you can also use those modules also, not a problem. And then how we are going to take it up now? Just we are going to execute as usual. We are going to execute a Terraform plan, and we are going to use a Terraform apply. But same way, if you take it here also, see this code is as usual. It is going to be there. So nothing but what? We are not bothered about to write it. You have to identify. You have to write it explicitly the code and all. No, you know about Azure service concept. What is a AKS? What is a ACR? What is a security group? I mean network security group. What is a virtual network? What is a virtual machine? What is a Azure recovery workspace? Those things, if you know that, fair enough. We can get to all this. This is code. It is here. Azure part AKS cluster. And as part of that cluster, can you observe this? All this stuff. Apart from that, see this here, main.tf file. As part of the main.tf file, what we are doing that, see this, if you observe this, resource group as usual, it is adding module SSH key and cluster. See, even whenever you write a main.tf file, even in the module also, I can call module, not like Docker. Docker container cannot execute a Docker commands. But here, see this, in our declaration, I can able to call another module also. That modules are, see this here, within that modules directory will be there. If you go here, see, here it's a modules, SSH keys, main.tf file. How it is generating? See, resource TLS private key, local file, private key. It's going to be copied. So try to walk through that. Can anybody explain, friends, what is this happening here? In this scenario, if you check it out, what is happening here? It's a condition. Agree? Santoshi, Praneeth, Kushnor. It's a condition. If the condition, the public key is empty, if the value var.public key is empty, what it does? If this condition is success, the first one can be executed. If the condition is failed, nothing but else block, it will go to print 0. Nothing but count equal to. If it is empty, if it is an empty, count equal to 1 going to be generated. If the already public SSH key is already exist, it's not empty, then it's going to return 0. Count equal to 0. It cannot generate. Got it? It cannot generate. See this content TLS private key. This one SSH private key PEM. But when it is going to be executed according to this part conditions. And the same thing output. If I want to only output generated SSH public key, this empty generated. When it is going to be generated, var.public SSH key not empty. Then if it is not empty, it's going to be generated. It's going to be referred. If it is empty, for example, this is empty, so nothing but it's going to be failed. If it is empty, the public data public SSH key is empty, for example, the condition going to be failed, then it's going to refer. If it is not empty, then it cannot take it up anything. Value is equal to public SSH key because already there. Well, if it is already there, why should I refer it? So that's what it's a dependency. If the already public keys exist, it cannot generate. If it is not exist, it can generate. That will be referred here. And the same thing public SSH variables. See, in a single location, I can declare it. It's also a module. Then if you come down and if you refer it here in the main.tf file, and we can get to know that. It is referring module, it will go to get a public SSH key. This public key module.ssh key.public SSH key, we are going to use it somewhere. See that somewhere you can refer it. I'll just search it. You can search it out. SSH key. So nothing but module. Module used. That module going to be called, right? Have to call, right? Public SSH key. See this here. Public SSH key is equal to, observe this, module, nothing but this one, dot SSH key, and public SSH key, and you are going to get it. If this var.public SSH key is empty, then going to be take it up this. Okay, that is one thing. Can anybody see this here? If you observe this, within the block, we have a multiple blocks. See this? So that is also. So it's overall, if you take it up this main part, under that also dynamic node pools, because if I require to pass multiple parameters, within that also I can able to declare it. Instead of referring from outside, directly within the, just like a anonymous class or inner class, I can say that. Just like an inner class, how you are going to that inner method, we can treat like it's going to be referred. But we are not bothered about all these things. But if you want to learn little deeper side, yes, you have to refer it. But sometimes if something is wrong, it cannot work, but you should be able to debug it. So that is also little, I mean, it is going to become as complex if you go into the module side. But module is not throwing an error, only your parameter side only going to be. So nothing but, for example, in your project, all are modules, for example, all are modules. Okay. And you getting some error. It's throwing some exception, for example. So what you have to do that first step? First step is check it out your variables are correct and the dependencies are correct. In a sense, topper level. In the topper level, nothing but main.tf file. But still you are getting some issue. But whatever passed variables are correct. The values for variables. But still you are getting the problem. So variables and dependencies you have checked out, if that is correct. Now what you have to do that? You have to check it out in the modules. As part of the modules, properly declared or not. Normally, if it is Terraform modules, if you use it, there is no issue, but there is no chance to modify because it is not going to feasible for your requirement. You're still getting the error. In that case, what you have to do that, you can download it, you can modify it, you can set it up your own GitHub repository and point it that as a source. As a source. For example, how can I do that source? If you take a modules like GitHub repository. So for that case, somewhere it will be pointed. This is a HashiCorp console AWS, nothing but this is a Azure registry site. But I want to point it instances, right? Just calm down. GitHub source for Terraform module. You can find it now. You are going to give a GitHub repository URL. Module sources is see local paths, Terraform registry, GitHub, Bitbucket, see Git and Mercurial, and HTTP URLs, S3 buckets, GCS buckets. Okay, if you see that in the GitHub, you'll get to know how to use it. The local paths are like this, very straightforward. And if you take a Terraform registry, this is the Terraform registry. Okay, good. So it HashiCorp and console AWS. The above example will use the console module for AWS. For example, for module hosted in other registries, prefix the source address. Same like Docker registry. And host name, example, all these things are we are going to declare. Simple. See this in a different location. Fine. Okay. Another one is what? GitHub location. See, github.com, HashiCorp, example. So Terraform will recognize unprefixed github.com URLs and interpret them automatically as Git repository sources. Like the above address scheme will clone over HTTPS. This is going to be HTTPS. To clone over SSH, there, right? If you check it out at github.com, there are two things going to be there. If you check it out, if you go here, if you want to clone it, see SSH, HTTPS. I'm not enabled with HTTPS, for example, then I have to use SSH. So in that scenario, we are going to declare full path. We are going to declare full path. And then, so you can use this option as well. See, another on Bitbucket. As well as normal, you can use a URL, nothing but GitHub URL, Bitbucket. So you can see that GitLab and all. So arbitrary Git repositories can be used by prefixing the address with a special double quote prefix. After this prefix, any valid Git URL can select one of the protocols supported by Git. Also, these are many ways we can use it. Not only that, if you use it this way, by default, latest one going to be picked up, but a particular revision required. Nothing but we are going to use a multiple commits, right? Here, if you check it out, multiple commits going to be there. If you see here, multiple 82 commits are there. If you want a particular commit, if you want to refer it, say 101, 100 and all, blah, blah. So what you are going to do that? See, revision going to be declared. Tag, that is nothing but. You can declare a tag. There are multiple sources going to be there. If you check it out on the top, so these are the different sources. You can use it. Even S3 bucket location also we can see that. Even Git Mercurial, Bitbucket, GitHub, Terraform, local paths, GCS buckets, you can refer it. Nothing but S3 buckets, if you take it out, for example, see S3 URL will be going, but that is a zip file. But if you take it out, for example, say GCS, for example, GCS bucket, see GCS bucket also is going to be. So that's quite interesting. We can use those sources. Okay. So if you get a chance, what you have to look up, what is a if condition? I mean, if else conditions for each. Okay, just have a look these features also, if you get a chance. Okay, not only that, I can able to generate some random names or random numbers. All we can also generate it. See this here, random. See, random pet, random password, random number. You can use it. For example, random pet. This is a resource. You can check it out. We can generate it. This here resources like a random ID, random integer, random password, random pet, random shuffle, random string, random UID. For example, I want to generate a multiple virtual machines. I have only one resource. In that scenario, see this here, we can use it. Example usage. So this here, AWS instance server. I'm going to give what? Web server random pet server ID. It's going to generate one random pet name. That pet name we are going to use it here. Name. Okay. So that's the way it's going to be taken. So keepers are nothing but map of string, arbitrary map of values that when changed will trigger recreation of resource, length, prefix, separator and all. We're going to use it. And even see, random ID also can generate it. Random ID, keepers, aim ID, okay, that name is going to be iterated. These are like a features. You can treat like a number of Terraform features. Read about Terraform features, automatically you can get it. That's what if else condition, for each loops, random numbers and all, multiple resources if you want to create it. You're going to use it dynamically. That's another part. So that example, if you want to see that, just quickly, you can see that there is a random numbers part which is going to be there. See friends here, main.tf file. We are going to use it here. See for each. How you are using? For each dot key, each dot code. So Azure resource group going to be created. If it is a dev, East US, test, West US 2, production, West US. It's going to be executed. Name, location, nothing but what? If it is, for example, 3 items are there, nothing but 3 times going to be executed. Okay, each dot key, each dot value, each dot key in the sense dev, each dot value in the sense East US. See how smart it is. If not, I have to do that 3 times. Declare it. Just like a for loop. Good. Count also we just saw that, right? Count equal to, I need to create 3 resource groups, but a count equal to 3 given. But how can you do that? We have to give a different name. So here it is. I need specific names, but I want a random name. See this. It's going to be used random count dot index app1, app2, app3, like that's going to be. And a count and list also we can do that. Length, names, then count dot index. Just like an array. Just like a array or a list going to be text. So we can declare the type equal to list of strings, app names, that going to be get it. Where? In our variables. Of course, it's a variable, right? This variable we are going to declare here, Terraform TFS. Keep app names. It's not declared yet, but it's going to be their app names. Multiple app names going to be get it. We are going to pass it out. In the same way, if else condition. Just now we have discussed about this. If else, if going to be random string also we can use it. So based on this special characters, it's going to regular, just treat like it's a regular expression. Randomly going to generate one string that we are going to pass it out.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
2 things. One is Packer. The second one is Azure DevOps. So how can we take it at we'll see this. Quite interesting. So why we have to use a Packer? So what is an advantage of using the Packer? So the requirement before taking the Packer, what I want is, I want to create a virtual machine image. Just we discussed about. If I want to required configurations, if I want a required configuration with provisioning time itself, I don't want to install explicitly because it's a common for 100 machines. It's a common for 100 machines. How can we do this? So if you keep on do that each and every machine creation as part of the scale set, it going to, normally virtual machine itself is going to take a 2 to 3 minutes to provision. But if you install some softwares and all, it's going to take 5 to 10 minutes. It's a huge time. Agree? It's a huge time to take it up. So for that case, what we have to do that? I have to create ready-made image itself with required configuration, with required packages and all. Packer is going to help you to build a images. Okay, so for that case, just come down here, Packer. So you can see that Packer is something like packer.io. Azure Resource Manager Builder is nothing but it's going to create a VM image. So for that case, what we are going to use it? See, there are multiple things are see. Packer is providing, just like a Terraform is how it is providing, Packer is providing same thing to create an image. See, you can use Amazon, you can use Azure, you can use Docker, DigitalOcean, CloudStack, Google Cloud. See, multiple things are there, providers for Packer perspective. See, VirtualBox, VMware, custom, everything to create an image. So nothing but what Packer is widely used one to build a image. Okay, if you want to see the Docker also, let me try. What is there in that? So Docker builder. Normally we can use Docker build command, but what is going to be there here? We'll see that. So Docker Ubuntu image tag. Then basic example commit. Docker Ubuntu true. Change the metadata. So we are going to create a one JSON file, and then we are going to execute it. See this, all this information. You are passing that all this information, and then you are going to use the Packer command. Somewhere you can find it. Processor types. See Docker import registry latest artifact data. You can add additional tags and push the image as usual, Docker tag and Docker push. We can get it out. Nothing but what? I can able to create a fresh Docker image also, we can able to create it. In the same way, if you come up here and see this here, Azure, we can get it. Okay, before that, I want to take about this one. So what is doing that? Builders are responsible for creating machines and generating images from them for various platforms. For example, there are separate builders for EC2, VMware, VirtualBox. Packer comes with many builders by default. Okay, so that case we are using this part, Amazon EC2. This is separate one. If you see this Amazon plugin supports the following builders at the moment. See this Amazon instance, you can get EBS, chroot, EBS subroot. You can surrogate, you can use it. The same way, if you come down into the Azure, you can get it. There are two things are there. Packer can create Azure virtual machine images through variety of ways depending on the strategy that you want to use building the images. Packer supports the following builders for Azure images at the moment. Azure ARM uses Azure Resource Manager to launch via virtual machines. Okay, so what is doing that? Azure ARM use Azure Resource Manager to launch a virtual machine from which a new image is captured after provisioning. So if in doubt, use this builder. It is easiest builder to get started with. Good. So this is the way we can do that. Then what we are going to do that first, how can you do this? First of all, of course, Packer is a utility command. We need to get it. That's the first prerequisites. After that, authentication for Azure, because whenever you build it, we need to pull it some base images. On top of it, required configurations, we have to do that. So for that case, we are going to get it managed like a service principal. Okay, that is nothing but instead of using your own account, you can use robot user, nothing like. You can treat like it's a robot user, a dummy user, whatever you can name it as. Cool. So that's the one thing. Now, if I take it up in that front, right here, so we have to get authentication. SPN point of view, what we have done, what are the things we have used? One is client ID, subscription ID, password, right? 3 parameters we have used. Same thing, see this here. Identity, managed identity, Discover interactive login. Interactive login is available, something like this part. Service principal. So once it is getting, we are going to use it. The Azure Active Directory interactive login, managed identity, and Active Directory service principal. We are going to get it these 4 parameters. Set path and all blah blah. Then you are going to get the Azure CLI AZ login command or AZ. See, there are two things. AZ login, service principal, username, password, tenant ID. so that we can get authentication. Then once it is getting that Azure CLI part, we are going to use this. We are going to build an image. See this image publisher, image offers. There are multiple things are there. Azure ARM builder specific options. We're going to create it. See, if you just execute this command, it's going to list it down the what are the images are available, right? Okay, but image publisher, name of the publisher to use for your base image, Azure Marketplace images only. And CLI example, this is going to be display. And offers, name of the publisher's offer to use you for your base image. You can use this also command to get the offers part. Another one is image SQ of the image offer to use for your base image. You can get it this command. And then image URL also you are going to get URL to custom VHD. You can get it. And managed image name, image resource group name. All these are we are going to get it. And once is getting that, right? Azure account list locations and all these are. And once getting that, we are going to see the shared library and all. We are going to get nothing but we are collecting all the information to build a Packer image. Okay, so once it is collecting all this information, just come down. See, we are going to get this part. See this here. We are going to get complete everything. We are going to get it. See this, all the information: client ID, tenant ID, subscription ID, storage account, resource group name, client secret, and all. We are going to collect it in the form of JSON. Okay, so nothing but what we are collecting all the information to build a custom image, right? So whenever you create a virtual machine, you are going to refer some base image. So this we are referring OS type is equal to Linux, image publisher, image offer, image SQ. Same thing, right? We have just done here. See this here. These values we are declaring as part of the JSON file to build a virtual image. Okay, then Azure tags and all we are going to collect it, and then provisioning going to be there. Deprovisioning and provisioning going to be there with provisioners, and you have to install the software required. Why we are creating the virtual machine image, VM image? Nothing but what required configurations. I want to add it on top of it. So whenever you create a virtual machine, automatically those all required software is going to be there. Same like a Docker image. Docker image contains what base image going to be there. On top of it, I can save it. I can install it. I can save that as an image. We are doing same thing with the Packer for virtual machines, for Docker images. Anything I can use it. Cool. So what are the things are required now? If you observe this is for basic information, right? Here is the basic example for Azure. We are getting that. It's a one block. It's a one block. See this here. And then provisioning is the another block, provisioner. As part of the provisioner, see this type equal to PowerShell, then PowerShell script going to be executed over there. Once it is, so indirectly nothing but what it does, Packer can create a virtual machine, it will install the software and it will be build that image, same like a Docker build command. But we are doing that Packer build command. Good. So for that case, is going to be text. For Linux, we are going to use provisioners execution command in line. Says we are doing bin install type equal to shell, so that it can be executed. So once it is done, what we are going to do, the basic steps to build are create a resource group, validate and deploy the VM template, execute provision defined by the user, typically shell commands, power off and capture the VM, delete the resource group, delete the temporary VM OS disk. That's all. We can get it. So once it is done, we are going to use a Packer command. That Packer it is not showing, but you can go a little up, right? ARM chroot. We are going to get it. How does it work? Just to check it out is source device, subscription ID, resource ID. We are going to get this. It is here. Now we got it finally. Simple, right? If I ask me to do the Docker, for example, what I'm going to create it simple. I'm just simulating. Okay, easy to understand. Docker file, I can write it. Here, all instructions going to be there. What image you required, what are the softwares you required, what port need to enable, all those. Then after that, what I'll do that Docker build name something abc dot colon 1.00 and then dot. We're going to use this way. Okay, the same thing. Now if you see this packer command, packer, what is doing that? Packer build referring that JSON file. As part of the JSON file itself, everything is there. You come down as this packer build example, this part JSON files, pkr.json files, this part. So that is JSON file going to be here. So build provisioner and Azure CH JSON file also, it's going to be the same as this builders provisioners. So what we are doing that we are pulling the image and we are creating the virtual machine, okay, and then we are passing this provisioners. Simple. Okay, we'll see one example for this, and then how we can able to automate it through Terraform. We'll see that as well. Quite interesting. It's very simple. Okay, but we are not going to do widely. But even if it is want to do that also, it's not a big deal. It's not a big deal. We'll take it up there further. So ultimately, what are the things are required if I want to use a packer? First, you need to install packer utility. Packer utility, you should pull it. You have to set it up. Meaning, if I go here, I should be able to get which packer. First step. It's not there. Why should I get? I should get it. Next, what I need to that? I need to create a JSON file. JSON file, you need to create it. As part of the JSON file, what are the things are required? Builder information, provisioner information, you have to give it. That's all. Provisioner information, you have to give it. So builder section, what I'm going to give it? I'm going to give details about the Azure authentication. And here, what configuration you want to install it. That's nice. Okay. Like, for example, whenever you create a virtual machine, we are using this image, right? Basic Ubuntu server. I want to use a Ubuntu, but on top of it, I need to configure something. Like we just discussed, right, about here. Set. Here we are going to install it. Nothing but it's going to work like a bootstrap. Nothing but what? Instead of doing the bootstrap, if I use it base image, if I require a software as part of the virtual machine creation time itself, then we are going to use a bootstrap, right? That bootstrap, if you take a Terraform, then I'm going to use remote exec. There you have to execute some scripts. That's bootstrap scripts, nothing but. Okay. Instead of that, because whenever you create 100 missions, 100 times going to be execute that remote execution script. Okay, it may execute, sometimes it may not be execute. I'm not pretty sure, right? It should be dynamic in the sense on that particular time if the image is changed, for example, to say the Ubuntu latest version is changed or a minor version is changed. Definitely we are going to fetch it from the marketplace and we are going to use it as part of the execution time, provisioning time. But if it is some changes are there, but remote execution if it is failed, then everything is going to be lost. But instead of that, before execution itself, virtual machine itself, I want to create an image. I can able to test it before adding into this part, launch configuration section itself, right? So that image we're going to use it. So to do that, I'm going to use a particular stable version Ubuntu base image, and then I'm going to install required configuration, required installations. I'm provisioning required things here. Whenever you do that upgrade, if it is not compatible, if it is not working as expected, you should be able to roll back also. So these kind of things normally, example, say Jenkins, example, any tools you have to use it, for example, especially these third-party tools and all we are going to use, right? So that time we are going to face this kind of issues. Even combinations also we can use it. So combination in the sense, like same thing, remote execution, we are doing that, right? See this here. You can search it out here this way. Terraform, Ansible. So this Ansible provisioner. You can get it straight away. How to Ansible with the Terraform for configuration. See this, you can get it here. Very simple. You take it anything, it's fine. Just I'm searching straight away. You can come down here. Just observe this. What you understood about this one? As usual, just leave it about all those stuff. Just .tf file. It's going to create one image, assume that. Now what we are doing that Ansible playbook. As part of the Ansible playbook, what we are going to write it like say this is a provider.ef file is okay, and Apache install.sh. In this case, we are going to use task. So Apache install task name user. So these all things are authorized keys, and upgrade packages. We are going to use apt command upgrade cache and all. That's what you are installing the packages. So this is very good installation perspective. So overall looks like this. You are installing the software, you are bringing up the server, and you are restarting the server. So this is actual playbook. So this playbook we are going to use it here. You just come down, see same thing, right? Remote execution, and we are getting the connection. See this connection. What if we are getting the connection from here? Droplet some connection host is equal to self dot IPv4 address. We are getting that. That's what we are connecting that server. Connection. Provisioner, remote execution. See here, as part of the provisioner, see, playbook we are executing. So how I am getting that input? Self IPv4 is an input. And then authenticating, running the playbook. You can read about articles, you will find it. I mean, Terraform and Ansible. The both are complements each other. Okay, you may ask, Ansible also can able to create a virtual machines. Yes, it can be possible, but it cannot maintain desired state. That is only the problem. So this is the one thing we are able to do that. So same thing, right? If you check it out here also, we are doing same thing. Just come down, come down. This is the actual playbook. Playbook what is doing that? Host all task, whatever task you want to perform. If you want to restart something, you have to use handlers, and then you will get it. Provisioner, but where it is executing, just check now. Web. It's not closed to this block. This block is not closed. So that's the reason is not used null resource. Is using this resource. Okay. And then this block is where it is closing. I think here. This part, this is the one, and this is the one, right? This is going to be here. So if you take it in that front, provisioner, remote execution, nothing but from web. Okay. And then it's going to be execute. So inline, some script is executing. And here, provisioner, the resource is what? So always recommended, you can check it out. I mean, whenever you debugging or when you walk through it, if it is provisioner, local execution, remote execution is there in the sense, okay, you check it out what resource it is using on top of it. In which block it is there that, I mean, these two are in which resource it is there, you can check it out. Is this null resource or is it remote? But remote point of view, it's not a problem. It's not a big deal. Anyway, it's going to connect it. So that's the reason it is saying that, see this self IPv4 address, because it's a self. And then here provisioner, straight away it's going to be executed. So this provisioner, and it contains the playbook and all, it's going to be executed over there. Okay, so build image with Packer, image builder, shared image galleries, Windows custom images, Linux custom. So many things are there. It's a very clear way it's explained. Okay, if you just check it out, Linux custom images. Okay, you can come down, say this, creating a Linux images in Azure. Difference between managed disk and images. These all things are, keep it aside, all these. Specialized image storage options, shared image gallery going to be there, and sharing images at scale. Okay, gallery going to be there. See, hypervisor technology to create to start the virtual machines. Cool. Now, if you want to create it, for example, say example in that Ubuntu, I'm going to use it for example. Let's come down here. So prepare an Ubuntu virtual machine for Azure. How it is going to be there? Steps. We are going to get that. So in the center pane Hyper-V manager, select the virtual machine, connect to that, blah blah things are it's going to be takes place. After updating the things, okay, configure cloud init. So cloud init is nothing but provisioning the system using Azure data source going to be takes place. And then later, sudo cloud init, Azure Linux agent runtime artifacts and logs going to be generated. After that, you're going to shut down and you're going to use this hyper manager and only accept the wait. But this is a different case. But if you come down Packer side, just Linux and Windows, both are there. See this. If you take it up, what we are doing that, friends? We are just, as usual, this is, we know that. It's a group creation, resource group. And then create Azure credentials. So we need to authenticate and we have to, because contributor role is required, right? Contributor role required, and we are going to pull the images, right? Base image also required. We need to start a, I mean, how can you provision it? How can you install required software? You have to start a virtual machine, right? See, Packer building in the sense what? It cannot directly add the content over into the image. Indirectly, in the background, what it does is, it's going to start the virtual machine. On top of it will be installed and then save the image. Even Docker also doing same thing. Docker file, if you use it, we are going to pull the Docker image, the base image like Alpine, Ubuntu, CentOS, whatever, blah blah, base images. We are going to pull it. On top of it, I'm going to install the softwares, expose the port numbers, create the directories, copying the files, everything I'm done step by step as part of the container. As part of the container, not in the image. Because if you already packaged the image, how can you install it over there? You cannot. You have to start it, you have to install it, and then save that as an image. Doing same. For that case, nothing but I need to provision, I need to create it. See this. Packer authenticates the with Azure using service principal. Of course, we know what is a service principal. Is a security identity that you can use with apps, services, automation tools like Packer. You control and define the permissions as you to what operation the service principal can perform in Azure. Of course, we know that it's a role, right? And then it's going to use it. It's going to give the output. See this here, output client ID, client secret, tenant ID, automatically going to query. That's why it's going to create service principal. I'm querying, the output will come. Okay, then to authenticate to Azure, you can also need to obtain Azure subscription ID. See, AZ account show, because already we got this. So AZ account show, subscription ID will come. That's about what? Already we have AZ login. See, without AZ login, how can you create a role? Right? So once it is AZ login, execute this, you will get a service principal. Then you can get the subscription ID. Of course, you can go there and you can also do that straight away, not a problem. And then see, define Packer template. So template is nothing but it contains the builder as well as provisioners. See this here, builders, provisioners. Two parts going to be there. Okay. So as part of that, just if you take it in this in a simple way, then come down, create it, new file, some JSON file. Say I'm going to say Ubuntu JSON file. Here you can paste it. Good. So this here. So this first step is builder and provisioner. Two parts. It's a template. If you say Docker file example, just for too easy to understand, I'm just picking up. Okay, in between I'm bringing that concept. Okay, see this here, Docker file example. Can you see this here? If I want to create an image, what I'm doing that I'm pulling the required image. So it's example here, node. After that, required software, nothing but provisioning, installing the software, creating the directory, copying the content, installing some package, and provisioning this JS file. I mean, it will bootstrap the JS file while starting the container. Nothing but these all commands can install on top of the container. What container? Node. So whenever I say Docker build command, it will pull this image. It will install all these things. Same thing if you take it up here. Whenever you want to build it, whenever you want to build a image, VM image, it's going to refer all these things as part of the builder. If you check it out here in the builder section, okay, here builder section, what are the things are there? So this type as usual, otherwise it's going to point it to Azure. Then what I'm doing that we are collecting this information. Simple. I think we have this somewhere, we have used in our case, not TF state service principal, right? We have used a service principal. And see, managed image resource group, managed image name. Nothing but what? It's going to create this image. Cool. And of course, these four parameters we know now. We just saw that here in the main.tf file. If you come down, see, right? These four parameters. to use the existing image. So that's what the point here. So this code OS type, publisher, offer, SQ. So this here, publisher, offer, SQ version. So we are referring the base image, same like what we have here understood from Docker part, from this example. Then once you're getting that, what are the other things are different? It is creating Azure tags, image deployment engineering, and then location East US. VM size should be standard DSV2 always. So nothing but what it's going to pull, and it's going to start the virtual machine by referring these parameters we understood. How? Because it's going to create this image, it's going to create a tags, it's going to create in the East US with standard DSV2 VM size. Nothing but what? It's nothing but like what CPU you want to use and what processor you want to use. We are referring this. Nothing but what? Indirectly, Packer can create a virtual machine on top of it. By using this information, it's going to create a virtual machine. Nothing but what? We are providing the required information to start a virtual machine. To what? Packer. Then Packer what is doing? Once it is creating the virtual machine, this guy is doing this command. Now you can get it. Very simple, right? If you divide it into two parts, one is a builder part and one is a provisioner. As part of the provisioner series, as usual, remote execution, what is doing? It is doing this guy. Okay, cool. Now I need to take it up this code. But where I can do that, I'm just thinking. If I do it in my local machine, how can I get the Packer? So what are the prerequisites required now? I should able to get it first of all, Packer utility, right? Packer utility, I need to get it first. So how can I get it, Packer utility? Let me see that. Hey, it is somewhere, it is there. See this here? Let me click on it. Super. Download Packer. Mac OS, Windows, Linux, FreeBSD, OpenBSD, Solaris. I'm going to do in my local now, for example. Okay. So package manager. Through package manager, if I want to do that, brew tab, Ashicorp tab, brew install Packer. So I'll try this straight away. If you want to do that Windows, see this. You have to download it and you have to set the path. If it is a Linux, say execute these commands, you will get it. See, apt get installer Packer. You can try, anything is fine. Okay, what is this homebrew? Brew command is there. Brew command, same. So I'll just try, let me try in my local. Okay, I'm just doing good. Okay, not a problem. And then second command, Packer, you can get it. Can you see this here? Which Packer? And do this. Now we got it Packer now. Simple, how simple it is. See. So once it is getting that Packer, say Packer --help. See this commands. Multiple things are there. Says inspect, see components of a template, validate, check that a template is valid. Version, prints the Packer version. Install missing plugins or upgrade plugins. Same, it looks like same as it is like Terraform, right? Cool. Now what I need to do now, I should pick it up now. So if you go here, I'll take this as usual, this part. Anyway, I just copied it already. Maybe it is chances are there. I'll do one thing. In the location called VM06. Okay. CD. Okay, I got same location. Here we have ubuntu.json file. What happened? I think I'm not saying. Okay, cool. Yes, yeah, now you can get it. So this is the one you can get it. So now the point is ubuntu.json file we have, but we need to fill it up all these details. Okay, let's see that first of all. So Packer I have, that's nice. And say I need to build it, right? So for that case, what we are going to do, that what command we have to use it? Packer build command we have to use it. We just saw that here. Of course, here it is going to be there here itself. So once it is getting that, just observe this. Build Packer image. Packer build ubuntu.json. So an example of the output from the looks like this is here. So running a builder, creating Azure Resource Manager, creating resource group, after that resource group name, location, engineering, image deployment, validating the deployment template, resource group name, blah blah things. Okay. See, network connection, public endpoint, Packer public IP address. See, it's connecting. It's creating nothing but getting the VM's IP address and provisioning. After that, capturing the image, deleting the resource group, deleting the temporary build, just like a build. So builds finished. The artifacts of successful builds are this is the image. That is name is my resource group, my Packer image. Location East US. It takes a few minutes for Packer to build the VM, run the provisioners, and clean up the deploy. After that, once it is this image is created, right? So this here. AZ VM create resource group, my VM, see my package image. My package image. After that, you can see that to allow web traffic to reach your VM, so we are going to use this open port. Then you can see that output will come. Nothing but whatever you provisioned here in this image. We are doing what? Provisioning, apt update, upgrade, nginx. Simple one. Cool. Right? So we'll take it up this part, but I need to take it up these points, right? So for that case, you can get it from here. I think command main.tf file. Yeah, these are the points. These things we know that. So I can get it. Copy this. 4 items. We'll go into our ubuntu.json file. Ubuntu.json file. Right here. You can copy it. And after that you can replace it. Tenant ID, client secret, client ID, subscription ID. See this. I can copy this as usual. We can subscription ID, you can take it up. And client ID, you can pick it up. You can store it here. Client secret, you can pick it up and you can store it here. And tenant ID, you can pick it up, store it in the tenant ID. Good, right? And I'm done. I just remove this. So required information we have given. Cool. And my resource group is going to be created. My package image is going to be created. All these things as usual. I'm just referring. Save as. But what is saying that before this, before executing the build image, but he's creating, right? See, I think we have this already. So only thing is that I need to create this because it is not there because I'm kept empty everything. Where is here? See this resource groups. Everything is empty because I'm building. So now I need to take it up this. So here AZ login I need to take. Cool. I'm authenticating. I'm done. Cool. Got it. Right? Now you can create it. This manual approach. Done. Okay. ID, location, managed by name, properties and all we have done. Cool. Good. Then it's created. You can check it out. Refresh. Yes, my resource group is created. East US location. That's nice. Next step is what I need to do that. Next step is I have to go here. This is of course not required. We have done already. Okay, if it is failed, then we'll see that what's the problem. And I want to see that subscription ID is same as it is or not. Let me check it out. Of course, you only get it right here. Subscription. See this? This is a subscription C1. Let me check it out. See C1. You can check it out in our code. C1. Good. No worries. It's common. Next. I just replied. So it's going to create my Packer image now. Now you should come down. Okay. So what I need to do the next step is Packer build then ubuntu.json. That's all. Very simple. We're just executing command. Let me see, is this going to be created or not? Okay, let me. And also I want to check it out. Is the storage account also going to be created? Okay. Violating the deployment template, resource group, deployment name, deployment template, resource group, public IP address. Cool. And become available, connecting to SSH, provisioning, Packer account and entire home directory will be deleted. Carrying the mission properties, everything is in place. Computer name, managed OS disk, resource group name, computer name, capturing image, resource group name, compute name, all these are done. Image location east US, image name, image resource, compute location, and all these are coming. After that, it's getting it. No, it's not using any storage. Okay, let me try. This is going to happen now. See friends, as usual, running the builder, getting the tokens using client secret, creating Azure Resource Manager, super. And zone resilience may not be supported in East US. Check out something availability zones, blah blah blah. Creating the resource group. Cool. Resource group name, Packer, location East US, tax, engineering. It will take little time. Image deployment, validating the deployment, resource group name, deployment name. Cool. Deployment name, PKR all. Okay, just hold on few minutes. We can get it. Managed image resource group. So of course, this is where you want to run this. We are getting, virtual machine creation, and then managed image name, OS type. Like this is like a OS type. Like what base image I want to use it. It's a Linux type, canonical, Ubuntu server. Even virtual machine creation time also we are going to use this. Okay, and then tag is going to be used. Location. Yes, simple, right? Only what you want to create a virtual machine, what you want to, that points we have just taken it up. On top of it, see in the provisioner section, in the square brackets, execute command, in between, we are adding that one. Here, in the square brackets in between, the command is going to be executed. Here, dot path, dot vars is nothing but, these are all like a environment variables. We'll get it out. So this here, chmod sudo command, because where you want to run this is nothing but sudo only, right? That's the reason. It's a default option from back. So type is equal to shell and bash shell. It's going to be run this bash shell. Now it's going to be executed.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Let me check it out. Is this virtual machine is created or not? Right? It is provisioning virtual machine in the sense you can come down, resource groups, refresh it. Still, it's I think deployment name it is taking. It's not yet created, right? It seems it's taking a little time, but it will come up. Still going on. Okay, cool, going on. But why it is getting this error? Can you see that? Unable to initialize front end dialog, blah blah things are okay. Failing back front end deadline, Emacs, okay, that's okay. Fetching, all these things, preparing, unpack, that's nice. Processing triggered, cool. Setting up, preparing. Let me see that. Here is then, maybe it is show it or not. Resource groups, refresh it, cool. See, all are there. See, Packer resource group. If you go here, now you can find it here. Super, right? Virtual machine is created. So Packer is creating the virtual machine. See, this virtual machine is created. That's nice. So provisioning is done or not? Can you see that? Querying the machine's properties, resource group name, compute name, managed OS disk, machine additional disk properties, computer name, powering off machine. No, nothing but it's done. Let's go a little up. The following new packages will be installed. See, it is got the metadata. Now it is trying now. See, Azure Archive Ubuntu, nothing but what? It's a repositories. It is apt update command. After that, trying to installing, unpacking, blah blah things. And once it is done, here you can see that Nginx somewhere it's going to be installed. See this here, system D, UFW, service and all. Then root password will be disabled. You will be able to log in as root. Good. Packer out entire home directory will be deleted. Nothing but query the machine properties and all. Power off machine, capturing the image. See, it's capturing the image. Image location going to be here. My package image. Got it. My package image. Nothing but what? It is deleting the virtual machine now. Whatever it is created, it is going to be so this refresh it now. See, It's going to be delete. Even this packer also going to be delete. Still going on, I think, right? It's not completed. Removing the created deployment object, PKR, the things. Deleting the resource group C. It's going to be delete. This packer resource group is going to be delete. Still doing that. But before that, can you click on it? See, everything is deleted till now. Right? Once disk is deleted, it will go into the text-based data. So wait completed after 10 minutes 35 seconds. Build finished. The artifacts of successful builds are, see here, Azure Resource Management VM image is nothing but my resource group, my packer image. Output. This is just like an output. We got it. So this is the image, my packer image. It's going to be available in the East US region. That's nice. Then what you have to do, that next step is, see, it is refresh. It's gone. Now I want to create a virtual machine. Of course, you can straight away, you can declare it in our main.tf file itself here as an image, or else just come down here. It is just giving the straight away information. Here, build packer image. We have done this part. See here, VM create. You can get it. So let it as it is. I can take it up. I'm not doing anything great. I'm just taking as it is because it's a CLI command. It's a default one, right? So here, use this, the 54650. Okay, this is okay, fine. SSH public key, or else you can use password. You can give some name, username. For example, I can give my packer user. Anyway, I'm not going to connect my packer user. Same, I can give my packer user at 12345, and same thing at the rate 12345. Cool. I just got it. Port numbers, public inbound ports, allow selected ports, SSH 22. We can do that. And licensing and all, blah blah. Review and create it. So good. It's getting right now. Create it. Instead of doing, what I'm doing, instead of executing this command, I'm just doing manual. Deployment in progress. Here also we can see that status. Cool. Going on. Resource group, VNet, all are creating. Nice. Network group. So 22 port number is enabled, but I need to, if I want to get an output, right? What I need to do, I need to execute this. My VM. Okay, you can also do this one also command. Let me try. Or else you can add port number. In the inbound rules, if I want to add it, see, succeeded. No problem. I can directly connect that machine. So what I need to do, that home page, resource groups, my resource group, say virtual machine. Okay, now I can connect it. SSH it. You'll get a public IP address. So this is a public IP address. I can take it up straight away, and you can come down. I'll take it up another tab. Different color I can take it. Okay, and say window, merge it, and I can take it up this SSH. Use this. Anyway, 22 port number is enabled. Good. Say yes. I'm connected. So it's going to ask the password. So my packer user at the rate 12345. Good. We are connected. Let me check it out. System CTL status Nginx. Good. It's running. Automatically provision Nginx. If you want to see that, curl -i http localhost, because I'm in the local only, :80. See, I got output or not? Welcome to Nginx. If I take it out this public IP address, go into the browser, :80, hit it. It's not come because 80 port number is not enabled. In that scenario, what you have to do, friends? NSG. I have to go into the NSG go into NSG group. See, you can find it NSG network security group. You can go here, come down. There is an inbound security rules. See, 80 port number is not there. I can add it. Any source port ranges. So here I can give destination port is 80. Okay. Priority is as usual port 80, and then you can just add it. Fair enough. Creating security rule. Okay. Refresh it. See, it's got it. Now you can go hit it. You'll get it. Why it is taking? I think 80 I have to enter, right? Yeah, it's missed up. Why it is not taking? HTTP colon 80 HTTP colon. Yeah, we got it, right? We got it. Good. We are good in that. So this is the one. But for example, same thing I want to do that through Terraform. Okay. I want to do that in the Terraform. So what I can do that in that scenario, just take it up sample example. I think Packer demo. I just search it out in Google only. I'm not done anything great. Okay. I'm just referring here. See friends, just assume that packer demo.json is nothing but a ubuntu.json file. Okay, this is just like I said, this provisioner, blah 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 things and all, everything is just like a ubuntu.json file. Take it up that, and then if you go here, Jenkins Terraform sh file. Okay, so what is doing? Can you see this here? Actually, these all things are not required. But what is this guy doing? Is getting that artifact information by you running the packer build command. This is a different case. This is for AWS example, but we can same thing we can convert as an Ubuntu Azure. But just whatever we have executed packer build command, you can give it. And these all things are not required still. Actually, these all things are not required. But once it is getting that artifact, is just collecting the AMI ID because it's an AWS part. AMI ID we are picking. See, it's a simple shell script. By executing this packer build command, is extracting the artifact ID name. Nothing but artifact, nothing but image. That artifact is nothing but a AMI ID. And then after that, what is going to do that? If you go here, take it up scripts, deploy.sh. So this is going to be service, nginx, blah blah things are all going to be execute as part of the packer.demo.sh. So this here, deploy.sh. We have done explicitly over there, but this guy is doing a script straight away. Okay, so once done that, okay, in the demo just a file, it's automatically going to create. But same thing, I can able to keep it in a that image. You can keep it in where we can keep it. That one we can keep it in as part of the Terra main.tf file. That image name you can declare it. That's all. Same as it is. There are multiple things are there. You can, if you want to refer it, there are multiple examples you can find. Packer Azure RM. Here you can find it. How you can do this. So multiple JSON files are available. So take it one example, Apache example, Packer Apache. As usual, builder, whatever we have taken, and a provisioner. As per the provisioner, HTTP. In place of Nginx, it's going to be HTTP. Okay, this one, once it is, what is going to be generated here? Image publisher and all. It's going to use capture container name, packer stan, container name, image stan. It's used. Okay, location, tags, provisioners. It's going to be generated. So once it is generated, it's going to be used as part of the TF file. You can take it up any TF file, and you can able to use it that. But this is different. This is also resource, Azure Agent, and chainer. It's not using, but you can refer that as usual in the main.tf file itself. Now we need to discuss about the Azure, nothing but say continuous deployment. If something is modified, I want to trigger it, or I want to do that automatically. So for that case, we can use different options. I can go with the Jenkins. Okay, I can go with the Jenkins to trigger the Terraform scripts as a Terraform plan, Terraform apply, blah blah things, or I can able to use any other tools like a Azure DevOps, or say AWS code pipeline. Even I can able to use GitHub Actions. There are so many tools are there. Okay, I mean, so deployment tools we can treat like it's just like a CD tools, continuous deployment tools. So advantage is what? Whenever something, if you something pushed into the GitHub, automatically these things can pick it up and can be applied over there. Good. For example, simple example, I can take it up. GitHub, for example, if I do that, okay, say github.com if I have, for example, okay, say I have a repository called, I'll just go here, okay, and just create it one simple one, say Terraform demo, okay, I'm just creating this, create a repository, right? I'm just created the repository. So here, assume that I'm going to create a one file called main.tf file, for example, okay, main.tf file, or else you can say tf slash main.tf file. I'm creating here. As usual, the content I can add it. Say which one I can add it. Do one thing. I'll go last one, main.tf. This is quite interesting, right? So provisioner, resource group. Fair enough. Everything is in the single file. I'm just adding here. Okay, and say commit new files. Good. So here the content is there. The tf main.tf file will be there. Normally Terraform init, Terraform apply. If I do that, I mean plan and apply. If I do that, I can get it. Okay. Now I want to run it a simple way to run it, because normally what we are going to do, we need a Terraform utility command, az login command, and then we have to execute it, Terraform init, Terraform apply. But see this, GitHub is providing that facility to run it straight away. Straight away we can run it Terraform's up commands as a pipeline, See this here. Can you go into that actions? Okay, you can create it actions. See this. Get started with GitHub actions. Build, test, deploy your code. Make code reviews, branch management, triaging work, and anything you can do that. Out of that, see this. Set up the workflow. Simple workflow will be there. Node.js will be there. See, deploy Alibaba Cloud ACK, deploy Amazon ECS. There are so many options. Build and deploy GKE, deploy IBM Cloud, OpenShift. See, triage, Terraform. So nothing but what? Required platform can provide by the GitHub itself. Nothing but what? Indirectly, it's going to point it to the Azure only, because GitHub is owned by the Microsoft. See this here. Set up Terraform CLI in your GitHub Actions workflow. See how simple it is. We got it. The terraform.yaml file. You can as usual keep it. You just come down. The Terraform is a pipeline name. On, push, branches, main. If I modify the main branch, okay, automatically going to be triggered. Or pull request also, it's fine. Now, jobs. So this is the way it's going to be takes place, friends. Same like jobs going to be there. As part of the jobs, Terraform is a job name. Job name is Terraform. Then out of that, where you want to run it, it's going to run on Ubuntu. Environment equal to production. Name equal to Terraform. Just it's a naming convention. That's what prerequisites going to be get it automatically. Automatically create Ubuntu virtual machine. Then defaults run bash. Bash shell going to be set it up. Then come down. Steps. Because we need a Terraform script, right? So for that case, it's going to check out this, the first task. Check out the repository in the GitHub Actions runner. You're going to get it. So what we understood, like that I can create n number of jobs. First job, second job, like that I can create it. Now out of that, see this setup Terraform. We need to install Terraform package. We are going to do that normally in our local. Same thing. It's going to be get it. Terraform. Okay. So it's going to install the latest version of Terraform CLI and configure the Terraform CLI command. Good. So once it is done, see this as usual. Terraform init, Terraform format check. Check all the Terraform configuration files are there to canonical format. It's okay. It's optional. and Terraform plan. So generate an execution plan for Terraform. Then after that, what you have to do that? Terraform apply. But when do you want to execute it? GitHub reference is equal to main branch and GitHub event name is equal to push. Okay, so on push to main, build or change infrastructure according to Terraform configuration files. Then it's going to be executed. Terraform apply auto approve. See, normally it's going to print, right? It will ask yes or no kind of. See, auto approve. Done. That's all. On push branches main. Nothing but whenever you push it, see, it's a declarative approach. Simple. They're providing this declarative, just you have to declare it. That's all. If I, for example, save it, automatically going to be trigger this. See this. If I start commit, anyway, I'm doing in the main branch only, right? This is where it is there. Yeah, let it be start commit. See main branch. Commit directly in the main branch. I'm doing now. Okay, I'm just saved it. Right? If you go into the actions, you can able to find it. Here itself, you go to run. See, create Terraform YAML. It's running same. You not do anything. Need not required. Automatically going to run. See this. Click on it. Starting workflow on. So if everything is correct, okay, it's failed. Terraform plan failed. What could be the problem? Can you see this here? No configuration files. I'll tell you why. It is looking into the current directory. Am I right? It's looking into the current directory, main.tf file. That's the reason it is failed. So for that case, what I have to do, I have to go into the code. Either I have to copy this TF directory, nothing but I have to change working directory. I have to go here, terraform.yaml file, and I need to change working directory as this. I need to go each and every place wherever we are running the Terraform, any Terraform, FarmMart and all. So I need to change working directory, right? Just I'll get it how to do this. Working directory. Working. There is option will be there. Working directory. GitHub actions. You'll get it. See, use working directory for entire job. How to do this is going to help you here. See this here. Job 1. See, you have the same thing, right? Jobs, Ubuntu, environment, working directory. Like this, I have to add it. Or else you can go each and every task you should give it. But better, this is the best one, right? Working directory. Environment colon working directory colon dot directory one. I'll go here. Where I have to do? In this location. Environment equal to production, it is there. I just need to edit it. Come down. Runs on Ubuntu name. Just check it out. env. It's not taking. Runs on same location working directory going to be there. Let me try. But it is not taking. This value cannot be null. Right. Working directory colon space tf. Yeah, it's gone. Right now it can work because every time it's a global level I have given, so it's going to take it up automatically. Now start commit the change. Cool. Now if you go into the actions, it will start automatically because we main branch only just updated Terraform. So what is the problem? Still not able to find, but Terraform init is okay. It's not taking, it seems. It seems this is not taking a / directory steps and all. Let me see any other option. What is there? My project, jobs, runs on CP, but where it is mentioned? Okay, using every time in the CD directory. This is not good solution. So what I want is working directory. Every time is adding the working directory. Cool. Steps are there. Defaults you have to add. This is the best option. Let me last attempt. Can I try? Go here. View a file, flow file, edit it. It's not taking, I don't know. Should take it actually. Default already there, right? So here I have to add it. Control X, Control V. Remove this. This works, but not app. It's a TF. Okay, you saved. It's getting success or not? Hope so. Good. Terraform has been successfully started. Format is done. Terraform plan is going on. If this is create, good. Now Terraform apply. See how simple. Everything is going to be as usual. That's nice. Done. What content going to be generated? If you take it here, SPN Terraform RG. Let me see that in our Azure resource groups. Refresh it. We'll get it. See this SPN resource. That's nice. Okay, timing. I can delete this because unnecessary, right? Say my resource and delete it. And one more important, we have done this, right? Build image, but created image, how to clean up. So build packer image, create a VM, test VM, and you can also use existing packer provisioner scripts with Azure image builders. Cloud init Azure virtual machines. Okay, this is different. Okay, cool. Now is this done or not? It's created, right? Resource part. Yeah, it's created. Cool. Now you can get it. And even you don't want to delete it, I mean, you want to delete it from here itself, you can go here, view workflow file, you can do this. Here only we can add it, delete part as well. But if I do this now, say Terraform apply, GitHub part and all, and I can simply say, take it up, edit it, I want to delete it. So it's going to be deleted. Destroy. And then say destroy. Then start the commit the changes. Now if you go to the actions, you'll get updated Terraform was successful last time. Now if you go here, you can get it. It will be very quick because it's everything is in place. Hope so. Create Terraform apply. Hey, it's going to add one more. What it is saying that Terraform user selected providers to generate the following execution. Terraform will perform the following action. Yeah. So here it is saying that it's already exists. The resource with the name already exists. Then it will be failed. It's going to be failed. In that scenario, what should I need to do? I have to go edit. I have to go edit option. Then you can come down. Just comment it. Okay, it cannot take a edit it. Can come down. Good. Just commented everything. Start commits. Okay, cool. So is this executed or not? If you want to check it out, last one, see this. Leave this page. Still it is failed. No. Can you check it out? Is this not executed? Just a minute. Terraform code workflow terraform.yaml file. Can you see this here? I think it is not saved. Can say comment, and destroy going to be takes place. Push operation, start commit. Okay, actions. Now it's triggering. Even if you have a Jenkins also, same thing you can do that. Not a problem. Now, anyway, this is going to be happen, not a problem. It's going to be very quick. Yeah, I understood that. TF state file is not there. We have to use in this scenario backend. If you use a backend, it's going to be referred from the central location and they do that because every time whenever you execute it, it will create a fresh one. Every time platform going to be new one. So no content files going to be there, previous existing files. So that's the reason you have to use a backend in this scenario. It can work. That's okay. We're not bothered about all these things. Now, if I go here, right? If I delete it, it's straight away, right? You can come down, delete the resource group, take it up. As well, I'm going to delete it because we're not using central location. So be always try to keep it your Terraform TF state files in your backend side. Nothing but container side. That's important. Okay, that's fine. Now, same kind of configuration I wanted to do that through DevOps, Azure DevOps. In meantime, quickly I can do one thing. Docker run itd Jenkins / Jenkins. Also, I can show it up. You can go to -p 8080:8080 and say -hyphen name. Say gentf. I can do just for understand purpose. Okay. Now, what it is saying that Jenkins. I'm sorry. spelling mistake. Okay, it will come up. Just give me one. Now, if you go here, if I want to perform same config, whatever I have triggered in the GitHub Actions, if I want to do that through Azure DevOps, what we have to do, we have to go Azure DevOps portal. Okay, if you see here, you will find that. Can you see somewhere? Here it is there anything Azure DevOps not showing? Okay, no problem. Just go into the microservices. I think it will be there normally. Okay, no worries. I can say DevOps. Okay, now if you click on that Azure DevOps organization, you can automatically switch here. Okay, now start it here. My Azure DevOps organization. It's a different site. You'll get it this page. So your management, your project management, everything we can control from here itself. I have already this part, for example. Click on it, organization. Okay, I have already this project, or else just take it up this one. Already I have, I think so. Organizations, I don't have. Visibility, project name and all I have to give it up. Okay, this one I'll take it up. Nothing will be there. So I can give a project name, say my demo on Terraform. Just example. My demo I can give it. Okay, say create a project. See this here? It's created. So you can pull that repositories. You can create a boards. You can create a like a Jira boards, GitHub issues, how we are going to do that, right? We can create it here. Boards, backlogs, sprints, queries, agile, everything we can maintain it here. Okay, and then repos also we can do that series. GitHub Actions, how we are doing that? We can create our own repository. See, straight away we can get it. My demo is empty. You can generate Git credentials and all. You can do that. You can also push it here, code. And then second step is pipelines. Can you click on that pipelines? So create a pipeline. Okay, and also you can use release pipelines. Also you can create it straight away. See, new pipeline. Okay, automatically you can get it here. So what you want to do that here, select a template. So you can search it out Terraform, for example. See, Terraform. You may get. It's not showing. Azure Apps. Terraform template. No. I'll get it somewhere. I think this is not possible here. Okay, I'll go straight away pipelines. All pipelines. Leave it. Pipelines. Okay, create a pipeline. So see that here from. I can point it from my GitHub. Instead of Azure repositories, I can point it GitHub. I can get authentication. Cool. Select a repository. There are so many are there out of this. Out of that, I want to get QF. VFS user 1, VSM user 1 is there. VSM cloud is there. Showing that the most recently used repositories where you are in a collaborative. If you can't find repository, make sure you have provide access. Provide access. Not in this, right? I want to be used. Granted. Say this. I'm just given grant, right? Now, if you go here, you will find it. Done. Azure pipelines. Now you can go into the pipelines. You can search it out here. You will find it. Somewhere you can find it. Refresh it. My repositories. You will get it here. You may also select a specific connection. It's not coming. All repositories. Cool. I got it. Right? Transform them. Terraform them. We'll get it. See this here. Select a repositories. So what I want is Terraform, right? Terraform demo. I have selected, right, already. Here you have to select it. Which one I need to select it? Terraform demo. You should come here. Terraform. Okay. Approve install Azure pipeline. Approve install on your array organizations, QFIT solutions, all repositories. metadata. Yeah, it's already suggested. This is the one, right? Suggested. Read access to metadata and do that. Approve and install it. Now see that automatically going to create. I'm just pointing that. Good. So starter pipeline existing. I don't have right at all. Now I can use it. Starter pipelines. So you'll get it. See, as it is like a GitHub Actions YAML files only. See this? Ubuntu latest. Echo hello world. Run one line script you can use it. See this, echo add other tasks to build and akka.yaml files, run multi-line script and all, you can use it. So if you see this here, if you see this code, what are the things we have done here? If you see this, removing all these things, we can remove it. All this stuff not required, just remove it. Okay, and you can do this condition, some conditions and all, you can do that. Start commit. Cool. So, but if you observe here, what we are doing that we are getting installation as well, Terraform installation. But same thing we have to do here also. Okay. So for that case, we can come down here. There is TF file. See, same pool image, Ubuntu latest, Terraform apply, the same job. See job. As part of that, multiple steps going to be there. After that, first task, second task, third task, fourth task, fifth task, all are here. And then if you check it out here, download TF plan, right? Anyway, it is a Ubuntu only, right? On the top, what we have used, Ubuntu only we have used. Now I should get a Terraform installer, and then Terraform init command, and then Terraform plan command. As usual, everything is just like a task, separate task, and script. This is optional because it's going to give Terraform plan. You want to execute it or not? You want it's going to check it out, and then publish and wait for validation, and then Terraform apply. It's going to take it another stage. Apply stage. This stage is what? Terraform init plan. 2 stages. And where it is going to be executed whenever main branch modified, automatically going to be this triggered. But here, what are the things required? Stage, VM image, Terraform init plan, going to be take it up. But observe this here. What are the things that we are doing? Default directory, backend service, Terraform, backend Azure resource group name, storage account name. All these are we are giving. Automatically it's going to store there. And then Terraform task V1. What is it? It's a plan. What is going to be there? So environment service name Azure RM, out plan, going to be get it. System default directory 01 resource. We're going to get it from there itself. So this is going to be wait for validation. And then in the same thing, see Ubuntu latest, Terraform apply. As usual, download the Terraform current stage. Let's copy the files and execute it. So this Terraform installer, Terraform init command, and it's going to be applied. It's the same command. Provider is RM command, working directory, command options, TF plan, and environment. Take it up this content as usual. You can come down. You can replace it. Just replace it. Automatically going to take it. See this. Control A, Control C. Right? It's done. But just observe this. What is there? Do not .NET core CLI is deprecated. Build test and also. Okay. Terraform installer. Terraform version. Provider. Maybe some issues are there, but it's okay. Apply. Going to be take it up. But working directory, what is there? Working directory, can you see this here? The working directory 01TF. In place of here, wherever it is there, 6 places. So you can replace as TF because we have kept TF. Just enter. That's all. Done. If everything is okay, then it's going to be work. Maybe this resource container name and all maybe cannot work because see backend Azure RM resource group name, backend, but it's going to create or not, we are not pretty sure. It's going to fail. Anyway, no problem. Save and just run it. See how simple it is. Automatically, this pipeline going to be created in this case. See here. Terraform demo. See, Azure pipelines.yaml file created. Whatever we triggered. See, cool. So once done, but can you see that is executing or not? So you can find it. It's missing. Set up CI Azure pipelines. A task is missing. The pipeline reference task called Terraform installer. This usually indicates the task is not installed. It's giving some problem. It's okay, but still, I have seen somewhere yesterday. If you come down, say AKS Terraform. I mean AKS module Terraform. Yesterday we saw that this. As part of that, if you go into this GitHub repository, hey, can you observe this? There is a Docker file will be there. See, Azure pipeline.yaml file. Got it right? Azure pipeline.yaml file. Same as it is, but simple one. But why this guy is doing Docker build? Nice. See, Terraform Azure AKS, image name, build ID, variables is passing okay. Docker run, break builds, Docker run, and condition. I think this is different purpose. This is a Docker build command going to execute. Simple one. See, EVM image, variables, scripts, blah blah. Okay, I'll do one thing. I'll search it out directly with Google. Say Terraform Azure DevOps pipeline. I want to get it from Microsoft Azure DevOps Labs. You can find it. Simple one I want. You can find it. See how to use Terraform, local PC, blah blah blah. These things are okay, but I want a pipeline, right? So just come down pipeline. Cool. See Terraform file. This is we know that. Okay, Azure CI pipeline. If I want to do that, Azure CI pipelines, pipeline, Terraform CI, and click edit. Build your application using Azure CI pipelines. Where it is getting? Okay, Terraform CI is its name, but it is not clearly mentioned, right? Copy Terraform files to artifacts. See, automatically same as this is going to be get it. So this here Terraform installer, display Terraform version. So install latest version going to be this task going to be takes place. Install Terraform. Of course, install not provided task default, so latest going to take it out. Okay. Specific version if you want use this. Okay. And check Terraform version is okay. Then Azure service connection Terraform apply, and automatic. I mean, of course, we have done this is Azure service connection we have, and automatically get it. And execute Azure CLI from local-exec provisioners. Azure CLI. Okay. Terraform CLI, Terraform apply, run AZ login true.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Okay, local needs. This is from okay, good. See, this is a different one, same, but it's going to be a service principal. Here it is a AZ login command, RG login, and this is also same thing. Apply, and this should allow the following template configuration to run using the task. Azure storage account, provisional location, and all these are going to be taken up. So Terraform backend, secure variable secrets, all are. I'm looking single location, everything. Terraform plan view, all these are changed detection. Nice actually. This everything is in the single location, right? Marketplace visuals view. So in that scenario, what we can do first only we'll take it to, but plan. So this is a plan and apply. How about init? Init is there anywhere? Let's go top version init and all right. Okay. So we'll take it up this first and we'll go here and remain task location. This is the one I need to modify. Okay, good. Just edit it. Instead of this is okay, right? This version is okay, but latest display syntax is very important. Input and okay. Then how about this Terraform task? Where we have mentioned all this stuff. What is this Terraform Azure case plan things? This is also not required. This is not required. Which one we have used? Here used, right? Okay, cool. So this is the latest. Next, we want check version is okay, and apply. Where it is in init? Yeah, it is in init. But if Azure RM selected, the task will prompt for a service connection and storage account details to use for the backend. Local default for Terraform state is stored in a agent file system by default. Azure RM state is stored in a blob container with a specified Azure account, storage account. Okay, so in that case, what I'll do, backend Azure RM key, backend RM container name and all I can give it. It's okay. Let me take it at this as usual. My backend resource group and all. But if you come down, but this is already there, right? It's okay. These all things are fine. But what is the version it is using? We need to check it out. Only it is using Terraform CLI. Let it be. I'll give as usual. Okay. Stick with this. Cool. Inputs init Azure RM backend service ARM ensure backend equal to true, but timing again I make it false, right? It's okay. False is okay, but because unnecessarily it's going to create a group name, storage account, all this stuff. So simple one I want. In that scenario, we don't want this all stuff. So for that case, what should I say? This guy is saying already. Local default for Terraform state is stored in the local. Azure state is stored in a blob. Where it is using Azure RM, backend type is equal to Azure RM. So what I'll do here, say local backend type. Okay, and then these all things are not required in that case. Even if you keep it, also not a problem. These all things are not required. So East US, Azure resource group location, backend location, and all. Remove it. Not required. Just init Terraform working directory command and all, it's going to be as usual, but still I can take it out, apply command from service connection, this one. Good. So we can get it this plan. I have to take it up, right? But before that plan, before that, these things are not required. You can remove this. You want to go simple way, then you can keep it one step. Good. Now apply it is taking place. Plan I have to take, right? Same plan also we should pick it up. Somewhere we get it plan here. Init plan. What is saying this guy? Environment service name, secure var file, GUID for the secure file to use. Can standard Terraform var files to .env. But the blah blah things all not required. Just use this var. Okay, and I'll take it like this. Get it. You get it. Done. Good friends. We are good in that shape. So plan, apply, but remaining things are not required. Leave it all this stuff. Wait for external validation, blah 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 things all you can do. Just simple. Keep it simple. These three things. Plan. Terraform plan will be there. Oh, this is latest. Init. Plan. Which one we have deleted? Let it be up to init will take it up. Then later we'll talk about apply. Is going to be success or not? Let me try. Okay. Plan. Steps. Latest. Init. Then save this. Commit changes. If it is committed, automatically should pick it up, right? This pipeline should come up. Let me see this. See, just now triggered. Okay, but just come down. What it is saying that some versions are getting problem. Line number 16, 13 task difference must be in the format of name at major version. See, this format should be required. Format name at the rate major version. Nothing but here. We'll get it. Name at the rate button. This is the old part. It's okay. But still, I have another example. My GitHub, Terraform, Azure pipeline.yaml files. Source group, subscriptions, skip step, working directory, all are here. And Ubuntu latest, variables, subscription, resource group, storage account, container, TF state file. Any TF changes is going to be taken up. Terraform version, plan, some PowerShell it is going to collect it and tell that to apply. So I want to use this pipeline. So if I want to use it, pipelines, just delete. Create a pipeline, take it up repo, and take it up this. Okay, I have these permissions, approve, will get it, configuration. See friends, straight away it's coming. Okay, review your pipelines and blah blah things, variables, steps, task, Terraform, all are here. Now run it straight away. So what is the problems? Can you see this? Errors are 4. The pipeline reference task called Terraform installer. This usually indicates the task is not installed and you may be able to install it from marketplace. This because sometimes it is going to get it some errors. It's okay. Marketplace, what is that? Marketplace Visual Studio.com task version 0 job step. The build will retained for 30 days. Rerun the failed jobs. Yes. So this is a pipeline going to be, if you observe here, task, init, plan, and from that plan we are going to collect it. Is this a create or delete or update options? Then we are going to write host in that. Then we are going to refer that part. Terraform apply TF plan equals to variables any TF changes. Any TF changes. Variable going to get it true. Then we are going to apply it. But the problem here is what is the error it is getting? Some errors are there in this. Oh, pipeline, my demo, pipelines, it's throwing some errors this just now. If I click on it, a task is missing. The pipeline reference a task called Terraform installer. This usually indicates the task is not installed. Okay, give me a minute. Is the task installer is not there? Yeah, it's there, right? This is missing. Okay, if I go here, the top installer and then commit the changes. Cool, I'm done. Now if I go pipelines, run new, master, entered parsing pipeline YAML legend line number 17, mapping values are not values in the context. Meaning here 17th line, it's not taking this. Terraform task. Okay, got it. Task should be here. Input should be inputs. Syntax error. Simple. We'll get it and then commit the changes. Run now. Run new. Okay. Run it. And but the task event must be in the format name at the rate major version. Every time this error is coming. Okay. Edit. What we have to do here? See this here? We have to use this. Okay. Now you got it. Just go run new. Okay. Run it. Still problem? It is not able to install in the package Terraform installer. So that is a challenge. Normally, there is a Azure will provide that facility. This Visual Studio is maybe something else different. Terraform, but I want to take it up here. Microsoft, yeah. I'll get it here. Terraform job. See, Microsoft Terraform Azure DevOps Starter. Out of the Terraform job plan apply stages and all, if I go Azure pipeline.yaml file, see friends, Terraform stages template, test and all going to be takes place. But if I go back, Terraform main.a file it is there, the source code going to be, it's okay, quite interesting, right? Variables providers and all it's there. Terraform stages template, Azure pipeline. Azure pipeline, if you check it out, master path 101 Terraform job, variables, Terraform stages template.yaml file, params, test. That's what this is going to be executed. Template, that is the template part. See here, as usual, Terraform dash working directory, Terraform apply, Terraform template automatically taking place. Ubuntu latest template. So just everything is the taking template and directly executing. But this is example, you can try straight away, no problem. By using this CI/CD pipeline, you can try it out for your machine straight away. You can use in a repository. You can keep this, works friends. Fine. But if you want to just to practice purpose, if you want to do that better, I'll prefer to use just go into this part and actions. Very simple way it's there. But same approach it is going to be there in the here also Azure DevOps also. But YAML file you have to maintain. That's all. That is this one. This is the YAML file as it is. It works, but this is the version differences are coming. This installation is coming, not coming in the. Sometimes Azure DevOps going to work and sometimes cannot work while doing creation time. But just if you try little later, it works. This is the thing. Fine. Good. So everything we can execute it. So what you have to do that in that case, you have to create a multiple pipelines in Azure DevOps pipeline, or you can keep it code here itself and you can pipeline, you can set it up, it's done. Only the problem right now it is facing is this content. Say code, say Azure DevOps pipeline. Only thing is that this installer is not working because it is not able to install in this location because it's not able to download the Terraform utility. That's the reason it is saying that location goes. See this here. The pipeline reference task Terraform install usually indicates the task is not installed. That's the only the problem. Okay, good. So just try. If you want, I can share this example here. You can try it out. Good friends. In Azure pipeline point of view, just you have to create a pipeline.yaml file in the GitHub and just go ahead. You can get a lot of examples. Not a problem. It's not a big deal. Even through Jenkins also we can achieve it. I think we have done right. I think we missed out here. It is. So this Docker here. Just give me 1 minute. I'll just quickly tap here. Go HTTP localhost :8080. See Jenkins will come out. But I have to get it this right. Docker logs gentm. But it will take the time, friends. My bad. I would have because plugins installation takes a lot of time. Select plugins. Only I want to do here Terraform. It's not there. All selected, right? 19 selected. Huh? Good. Skip and continue. Save and finish. Start using Jenkins. Yeah, we got it here. Right? Go into the manage Jenkins. Go into the plugins. Available plugins. So many. Out of that, can you check it out? Terraform, is there anything? Super, right? See, this plugin provides a build wrapper for Terraform to launch and destroy the infrastructure. Right? You can take it up this, install without install. See, all relevant plugins going to be installed. Just it will take a little time. Almost done. Yeah, almost I'm done, friends. Okay. Once it is done, if you go into the home page, new item, you can create a pipelines or a freestyle project, whatever. Say test, say Terraform, freestyle. Okay. Then you can clone the code by installing the Git plugin. you will find it here. Build step, Terraform will come. Here, you can run it and do that. It's straightforward. But first of all, that this page, go to the home page, manage Jenkins, plugins, right? Available is installed. Yeah, Terraform is installed. No, Terraform still going on. All are like a dependencies. Okay. So if I install the Terraform option, automatically we'll get it there option. If that got it right, so we can get it and test TF configure step and policy and all. Here you can get it here, or else you can type it series here straight away. This is a step option. It's not a big deal, but Terraform must be installed so that it can be run. Okay, just try it out. It's okay because it is taking a little time. I don't want to take it your time. Say manage Jenkins, plugins, available section, Terraform. It's still taking. Still it is taking. That's the cause. It's okay, no problem. Just try it out even if you want to execute a Terraform script in Jenkins. But if you want to do that through Jenkins file, for example, if you want to get it, see here, Terraform plan for Jenkins file. So this here, you get it. Just so we are going to add this kind of gist. This here, pipeline, parameters, environment. What we are doing that as usual. Very simple. If you want to try this, you can try. Just once it is, you can create a pipeline job. You can add this Jenkins. You can get it straight away. Okay, friends? Yeah, cool.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.